All right, everyone, we have our next speaker. We have Shaun Harcourt speaking. And so I'm going to hand it off to him.
Hello, everyone. Thanks for having me today. I really appreciate the opportunity to discuss the optical sorters for wild blueberries and with your group. Um, with the university's help, we put together a little slideshow here just to kind of walk you through the offerings that WeCo has for a solution for wild berries. You can go ahead and do the first slide. This is our Chromax Berry Tech optical sorter. Um, it has cameras on top and bottom, so we can scan more of the circumference of each object, each berry, and it also has infrared and infragreen capabilities in it, which is more like an X-ray approach to a berry, where you look at the inner guts versus just the outer pigment. So you both on this machine you have both visible color range and IR to try to achieve the maximum effectiveness. A lot of what the IR is used for is defects and softness to berries. Um, that's the commonly that's how that's commonly used. Um, Just a little bit about the machine here is a very simple setup. We offer it in two different sizes, both 32-inch wide on the main belt, also in a 40-inch wide, which I don't think is that much necessary for the operations you guys have, as the 32 itself is capable up to 3 tons an hour. Um, very simple and straightforward to use. You have 3 visible color ranges, the IR range that I spoke of, and then you have 2 other, which is a total and an unround. You can go ahead to the next slide. This is just showing you about the camera system itself and the illuminators, a little more information of how that works. That's a proprietary in-house build that WeCo does. Our headquarters being in California, Sacramento, California. All the machines are built here in the USA. There's not really much to add to that. As we get down, there's another slide that kind of shows the spectrum part of the cameras that this is referring to. And I'll try to touch on that a little bit. You can do the next slide. Again, this is just more information about the cameras and how it kind of works and the proper lighting and everything that goes into it. Along with your operating temperatures, regardless of if the shed is freezer cooled or regular cooled or in just ambient temperature. This tells you, this is a big piece of what WeCo does, is I would like to say we're a service-oriented company first. We try to build all of our units very modular, meaning if there's ever anything in question that's not working properly, we can quick swap it out for a new piece, meaning that the downtime and calibrations and everything that goes into making an optical sorter works is your time is much lower for any issues that arise. We typically have service guys that come and check over the machines and go through all the parts of the machines to make sure that they're going to keep you up and running through your short season. And that's kind of what this is all about. Excuse me. You can go ahead to the next slide. So this is the programming part of like the defects that I was speaking of and how the camera actually sees. And this is one that I will like to address with you guys. So if you look across the top tab, I don't know if you can see my mouse, but there's a visible color, and then there's a visible gray, and then you have the infrared tab up there. But what you're seeing in this picture is this is actually berries going across the machine, and this is what the cameras are seeing. And you can see that this customer has got really right here in this blue area where it's blown out. This is all acceptable fruit that he wants to keep in the flow. Anything on these smaller scales going all the way around where these colors blend is all to be kicked out. So of course, green would fall in that category, a lot of red, and then you have some defect area here in between this brown and orangish color. Um, that's what he's targeting here. But essentially, what I'm trying to convey to you is it's very simple for us to take pictures of the berry. We can put them on the end of a pin, and we can take pictures of, both good and bad berries. And depending on what the bad one looks like, we can tell the machine, hey, this is what we're targeting. We would like to get all of this out. So that's kind of how this works. And then again, on the infrared, you're overlapping all of this again. So you can really target this individual areas that are problematic. But you still have behind the scenes all the visible color ranges working in conjunction as well. So I know it can be confusing to try to explain it over a slide and not being there with fruit in my hand, showing you how exactly it works. But it's relatively intuitive for the customers to understand after, typically a visit or two with the service team of how to work through each program. You also can, as you learn things, you can name the program so you can save them and run off of those just to be more effective. So it's a real good default point for you to go back to, and then simply just using a plus minus system, you can increase the sensitivity or decrease the sensitivity. So that's always highly recommended and a good place to start. So we can go on to the next slide there. So this just is covering the technical information about the machine and what the farmer would need to have available for the actual setup of the machine. And quite frankly, it's pretty simple. It's two 110 outlets, non-GFI. Um, and then you want that on its own 15 amp circuit. It's telling you the belt speed there at 120 feet a minute with half horse motors. And then the next most crucial one would be the air consumption. So the air requirements, and we require 90 psi at 10 CFM. So if you can give us the two 110 powers and the 90 psi with 10 CFM behind it, that's what it takes to run the machine effectively. And the rest of it is just to do with heights and setup. I know in a few cases up there so far, we've integrated the sorter into different looking lines that, different pieces of equipment, both on the in-feed side and the outfeed side. So um, another thing I'd like to touch on in that scenario is commonly what WeCo prefers to see is an air cleaner slash blower on the in-feed side of the sorter. That way you go through and you remove the chaffs and big sticks and stuff like that if possible before going on to the sorter. And you also get an even distribution of fruit where you spread across the sorter accurately, and it gives the sorter a much better chance of operating efficiently. On the outfeed side of the machine, typically there's an inspection belt. There could be another piece of equipment that, in process, we've had water tanks, you name it. But mostly in the fresh world, I've seen an inspection belt after the sorter, just for one last visual for manual labor. You can. This is just the dimensions. So here where my mouse is the in-feed side of the machine. And right here is the outfeed side of the machine. So this is where your inspection belt would slide under. And this right here is where your blower slash air cleaner would feed. Um, I know that we did not have great success with not having air cleaner feed here in Maine last year. So we definitely want to pay attention to that going forward and make sure that we are feeding this thing accurately so we get good results. Um, this is showing you the leg height here, the adjustment down here, with the machine all the way down. You're at a 29 and 11/16. And then you have the availability to go all the way up to 39 um, inches there, whatever you need to get on to your inspection belt. And there's going to be a couple more slides of this that are just kind of redundant, but something to point out is when you get the machine or order a machine from me, I always ask the orientation, meaning which way, this is the way the fruit's running through the machine. So this being where the trash comes out or the bad fruit, um, I always ask orientation for the customer so both their screen and their discharge can be oriented to suit their line the best. Meaning, if they want to operate, in this case, would be a left-handed machine, uh, and in a different scenario with the screen on the other side, it'd be a right-handed machine. So we always pay attention to that detail when we're installing. Again, just further dimensions of me sending out what you would want to pair your blower up to feed inside this tray here, feed right onto the machine. And then, yeah, the fruit's running away from you. Going right here is where the cameras are taking the pictures, and then on out. We can go to the next one. This is a back view. And if you can see on top of the belt, there's even a berry there just to kind of show you it's channelized all the way across this belt to give accurate delivery of the fruit to the optic. And that's a huge deal where if you're off just even a little bit, um, we call it delivery issues. You definitely want this belt square to the optics and all the funneling fruit to be consistent going across the optics. That gives you the maximization of the pictures you're taking. Again, just a whole overall look of the machine. This has good detail, so I'll point it out here. This is where your air would connect, and then right here is where your power would connect. So this is again a left-handed machine, screen on this side, discharge to the left as well. But your drops essentially would come down and hook into the power boxes, and then you would have air hook up right here to your RFL. And that has a filtration system on it where we clean some of the air out, and it has a filter in there. There's also a water separator there that you can see that you can drain every day after use and keep that fresh. I think this is the video. Is that correct?
Yeah.
Okay. This is a little video clip that one of my service guys took of what the real world scenario of running wild berries look like for us. This is coming off of an air cleaner dovetail feeder. And as you note that the fruit is being spread properly and it's consistent going across the sorter. And that's what we're going to need in order to sort effectively. As you see here, this is the rejects. This is everything that's being rejected coming out. And then this is the final throughput of what came through. So you can kind of see the feed, what it took out versus what it's letting go through. And in this case, you want all blue fruit going onto that inspection belt, which I believe is what you can see there. So, it's just a small video. I know it's kind of choppy around, but I thought it would be a good thing to share with you guys to show a little bit of a success story, trying to dabble into the world of wild blueberries and learning a lot about it. There's more stuff to come. I think it's been brought to my attention that one area of focus that WeCo could get better at is deer species. And we're trying to identify a program, and we're going to take multiple pictures of that this year and try to get something on all the machines that are there to be more effective on that. It's a really challenging thing. It's, you know, due to it being the same color as a berry, and looking very much like a berry when it's pretty fresh. That's going to be the hardest sort for us. However, if it's, you know, a day or so old and it start losing some of the color or drying up, I think we have a much better shot at getting that. But we're going to experiment with quite a few different things to see if we can't hone that in and get that even better than what it has been. So um, that's kind of an overview video, just quick. Again, I wish I had a more professional shot for you to share, but it is a real world scenario where, you know, you got a service guy running around with his head cut off, trying to get everything right and people around, and, you know, but it does show exactly how the setup should look, meaning, you know, you want to feed it correctly, you want to sort out the bad correctly, and then let the good go through. And I think it does show that, which is the reason I wanted to share that with you. With that, I pretty much am done and with what I wanted to share with you guys, but I will be open up to any questions that anybody might have.
What's the generic price range for what this is?
She asked, can you give a generic price range for these equipment?
Absolutely. So what I've been able to work out, that's another great topic. Thanks for the question. So what I'm doing is at this point, I'm offering any farmer in Maine that does wild blueberries a lease of $15,000 flat a year. That lease would include all service and parts from WeCo. We would take care of anything with that. And then you can also buy the machine, and it's not going to be brand new off the floor, but it's going to be the same one as if you leased. You could take that first year lease and apply it towards the purchase price the following year of 75K. So essentially, what I'm trying to accomplish with that is, um, you know, we got to cover our costs and make it effective for you guys as well. But where I'm going with that is it gives you a year to lease and have everything included that you need to get familiarized with the machine. And then it also makes it to where if you did want to purchase and you don't like the lease model of 15K per year, you could own the machine outright without losing that 15K. It applies towards the purchase price of 75K the following year. You would have a bill of 60 and you would be done and you would own the machine. If you did own the machine, it does cost time and material, and the just for the parts and the service going forward from that point. What I have done in the cases where a couple of people have bought is I've just included the service for a couple of years, even though I'm not supposed to. I want to stand behind it. I want to get you guys running right and, you know, see where we can take this thing.
What does the parts and service include? Issues with the software, winter items like brushes?
Correct. So the service included on the lease model is all inclusive. So it includes any part that's needed, brushes, software, cameras, fingers, sensors, belts, bearings, motors, everything. Um, with that being said, it also includes a service visit. So, you know, especially for startup. So startup dates are crucial. We try to work with each customer to make sure we have boots on ground for startup. That way the customer isn't overwhelmed and, you know, can tend to all the other stuff that's going on while we're training one of him or one of his right-hand guys.
Did I see correctly on one of the specification pages that that machine is capable of 4 tons per hour, 8,000 pounds?
He asked if the machine is capable of going through 4 tons.
3 to 4 ton an hour. 3 to 4 ton an hour. So, and that number is based off the cultivated world. So the way I'm going to look at that in the wild berry world, the average cultivated blueberry weighs 2.5 grams. I don't know what is the average wild blueberry weigh, but I'm assuming it's going to be 3 or 4 pieces more than a cultivated. So with that number does come down.
Any more questions? Yeah.
Shaun, do you have an email address we can directly email you?
Absolutely. My name is it's just my first name, Shaun, Shaun, and then it's at wecotech.com, WECOTEK.com. Maybe I can ask the moderator to share that with you guys. I'm sorry I didn't put that in the slide here. I must have overlooked that.
You could put it in the chat if you'd like.
Yeah. Can you help me with that? Let's see here.
Yeah, so it should be,
Yeah,
so
I
it should
got
be
it.
at the bottom.
Okay. To everyone, let's type this.
Yeah.
We got one that's part of the bottom, without inspecting at the end, we just see how many we can do with this, about 1,400 pounds an hour.
Perfect.
What was the question?
Oh, Ron is talking about how many berries he can process with his WeCo.
Okay.
Shaun, this is Nicholas. I leased a machine last summer that we're not keeping. So I was looking to cover that.
Well, when I say 1,400, that's just to see what the machine would handle. As far as packing, they're more like 400 pounds an hour, as we were doing final inspections. Yeah.
Any more questions for Shaun? Yep.
And one more, the air quality going to the machine. There is an FR on the machine, so a filter and a regulator, which of course will take some water and filter some particulate, but is there, since the air is touching the berry, is there another filtration system necessary before the machine to make sure that it is sanitary?
Did you get that done?
I think I heard most of that. To answer his question, what we have done is met all USDA and food safety standards. So the blast of air that's coming out of the reject block, touching the actual fruit, everything that touches the fruit has to be food grade and certified. So I do have all the certificates. If this is a food safety question, I send those out to my growers and every year an updated certificate of, the belts FDA approved, the air blast, the reject blocks, the chutes, the 304B stainless that it touches. All of that is food safe, yes.
Right. All right. Thank you so much, Shaun.
Yeah, thank you guys for having me. I really appreciate the opportunity, and please reach out to me with either via email or my phone number. For any additional questions, I'm always open for that. And I hope you guys have a great day, and I appreciate the business that I already have there, and I look forward to growing my relationship with all of you guys.
All right. Thank you so much.
Thank you. Have a great day.
Good morning, everybody. Thanks for coming. Before we go any further, I'd like to thank Dr. Calderwood and Extension and Jordan for putting this show on today. So thank you, Dr. Calderwood and University of Maine Extension. My name is Eric. I'm the Executive Director of the Wild Blueberry Commission of Maine. And we're going to talk for the next 45 minutes or so about irrigation. As many of you know, there's a new project, a new grant that's out there, and we're going to get into some of the details of that, including some of the uncertainty around it at the moment. But I'd like to start from the beginning. So about 4 or 5 years ago, the commission, which does this every year, set priorities for what we should do with the tax dollars. And one of those priorities at the time was to try and address supply inconsistency. So that's what's the quantity of wild blueberries we produce in Maine in any given year. And because largely due to drought and also due to late frost events, that supply has been very variable over the past, at least 5 years, probably 5 to 7 years. Last 3 years have been pretty consistent, but before that, a lot of you have experienced drought, late frost events that in some cases knocked your yields back to zero. So when you're in the market of trying to supply either national, international, or even just your local markets, if in 1 year you have half as many berries to move as you did the year before, it becomes very challenging to maintain those high value markets. Last year in 2024, we finally had an opportunity to really try to move on this priority in a bigger way. So some federal funding through the Inflation Reduction Act, that's IRA funding, became available, and the bounds in which we were allowed to put that funding to use was extended. So in 23, the NRCS had a whole lot of money and a lot of other federal programs through IRA to do all kinds of work. And it was really focused at the time on climate mitigation. So that's reducing carbon emissions, et cetera. And so a whole lot of groups nationally, including us, we pushed to get that expanded, to try and get it to include not just mitigation, but adaptation. Because we wanted you all to be able to actually be more prepared for the next time a drought rolled around. And so in 2024, the bounds of IRA funding, including through the NRCS, was expanded. And so finally, there were opportunities, and many of you have acted on those, to try to get funds, not just for mitigation, reducing carbon emissions, but also to prepare your farm for the next time there's a drought, et cetera. So last year, with that opportunity, we applied for some funding it was IRA funding through the NRCS through a program called the RCPP, or the Regional Conservation Partnership Program. And in October of last year, we were awarded funding, or I should say we received notification of award, a total of $15.5 million for this work that'll be carried out over the next 6 years in Maine. There's a lot of uncertainty. Two major things. One, there's a federal funding freeze that right now still very much applies to IRA funding. So we do not know at this point whether we will get this funding or not. Two, even if that were not the case, the way RCPPs work is once you get notification of award, you then work with the NRCS on a contract to work out the details. We did that work December through January, and that partnership agreement is currently in Washington under review, and we'll see if it's accepted. So there's a lot we don't know yet, but what I like to do is try to give you as much information as we can so that you are prepared if and when the funding does become available. So I'm going to try to focus on what we've proposed in that partnership agreement. And if we can hold questions till the end, Chris Phinney here, resource conservationist at the NRCS in Bangor at the state office, is going to answer a lot of your, go over a lot of the details, the finer details, and then together at the end, we'll try to address any questions you might. So a couple of points I'd like to hit on. The $15.5 million total funding, 75% of that, assuming the project goes forward, will go directly to producers to carry out the work of sustainable water source development. It could be wells, could be irrigation ponds, pumps, pipes, irrigation systems, and mulching. Where most NRCS programs offer a cost share, I don't know, I'm going to say 75% or thereabouts. We are asking for this program to be at 90%. So you would get 90% of the cost instead of 75%. Most NRCS programs have what's called an AGI, or an adjusted gross income restriction. So for some of the medium and larger sized operations, they're typically not eligible for funding through the NRCS if they gross through adjusted gross income over $900,000 a year. This program through RCPP, we're trying to waive that so that it will be equally available to all producers in the industry, from small to large. And finally, especially where we're still under the 2018 Farm Bill, there's a funding cap on how much an individual entity can use in USDA dollars or NRCS dollars over the course of a farm bill. And if you've already met or come close to that cap, you can only get an additional amount up to that, which is $450,000 over the life of the farm bill. This funding is outside of that. So even if you've done some big projects over the past, 5, 6, 7 last years under the 2018 Farm Bill, again, assuming this funding goes forward, it's clean slate, doesn't apply towards the Farm Bill cap. Before I turn it over to Chris, I want to try to proactively answer some questions that Mr. Phinney here, as a good government employee, may or may not be able to answer. And so first one is, well, let me back up a step. So the federal funding freeze pause has hit this grant, but many of you are also in NRCS contracts, and you also have potentially uncertainty as to whether or not you're going to get paid for the work you already did. So these answers and questions should kind of apply to all of that. So first, should you be spending money against any IRA funded contracts? So those are all the climate smart practices to the NRCS as well. Should you be spending money against any NRCS contract right now? I would say no. Pause on your activities and wait until you have certainty about the funding before you go any further. Should you be signing any new NRCS contracts right now? No. Again, wait till there's more certainty about the funding. 3, if you have an existing contract and you've done the work, are you going to get paid? I don't know. I think so, but I can't answer that question for sure. No one can answer that question with any certainty, but I think eventually the funding will come. Will we get funding for this project, this $15.5 million for irrigation? Again, I think so. There's a very real benefit here to very, very real farms on the ground. I think the funding will come through, but I cannot guarantee that right. And if you are interested in the irrigation project or any of the other work that the NRCS does, but especially the irrigation project, if you're interested in anything the NRCS does, including irrigation, I think it's still important that you go into your local field office and you start the conversations. Because especially when it comes to pumps, pipes, irrigation, etc., that takes a long time. There's a lot of work involved. It's still not easy, and there's a lot of steps that would have to happen before you even sign on the dotted line. So if you're interested, it still behooves you to go in and start that conversation and get things rolling. But again, don't sign on the dotted line yet. And finally, if and when we do learn whether or not this project's going to roll forward, we'll put the word out through Wild Blue newsletter. If you don't get our newsletter from the commission, make sure you go downstairs and sign up, and then you'll be informed of the status of this project among all the other things that we talk about through the newsletter. And one last thing, later today, Lindsay Werner from the Department of Ag Conservation and Forestry is going to be giving a talk on the irrigation water management rule. If you're thinking about irrigation, one of the things you need to be aware of is food safety. You've heard of the produce safety rule. You've probably done some trainings with the department, Ha Machado, others. There are also rules around irrigation. So you should definitely be aware of what those are before you take any further steps in this direction. So make sure you attend Lindsay's presentation later. And with that, I'll hand it over to Mr. Chris Phinney, Resource Conservationist at the State Office of Ag. Thanks, Chris.
All right. So I'm Chris Phinney, Resource Conservationist with NRCS at the State Office. That is a fancy way of saying I do what I'm told and I go where they need me. That's what I do. cover 6 counties, central part of the state, assisting district conservationists with whatever's going on in their office. So what I'm not is an irrigation engineer, nor an engineer by trade. Been working in the blueberry industry with NRCS for most of my career out of Hancock County. Almost everything I know I picked up as I gone along. So this is not perfect. This presentation is intended to give you some basics of the math for blueberry irrigation as I currently understand it. There are other folks in this room who probably know more than I do. So please feel free to shout me down, heckle me, throw stuff at me, call me names, all the things that you feel are appropriate if I get it wrong. So with that said, technology works, thank goodness. All right, so basics, we're talking very basic here, okay? Irrigation system, 4 main components, actually it's 5. Source, pump, pipe, heads, distribution, and labor. I forgot that, I did this late yesterday, please forgive me. What I'm gonna talk about today is really the 2 parts that go into some of the math as far as water. I can get into a little bit of cost share that I have off the top of my head later on if there's still time, if I don't ramble too long. It's all depending on y'all shouting me down if I get too long-winded. So sources, ponds or wells or both. I will get into those. That's one of the things I'm going to cover. That's sort of the critical part. Pumps, I'm just going to leave pumps alone other than to say they're variable and they're dependent on system design. Big pumps and small pumps, some pumps run off electrical, some pumps run off diesel. Depends on what we got on the ground. Distribution type, so that's the heads or the dispensing system itself. 2 common types in blueberries, big guns and sprinklers. There are some other oddball systems out there and other systems may be functional, but that's kind of the 2 core ones that we have up to this point. I'm going to talk a little bit about that because distribution type gets into flows and that ties into source, and that's really what I'm here to focus on is the water, where's it coming from and how do we deal with that? And then of course the pipe. Materials vary. I know it may seem like a shock, but bigger pipe for moving more water. I know it's crazy. And above ground, below ground, temporary or permanent, a lot of ways to deal with pipe. I'm not going to talk too much on that. Pipe gets developed, size based on pumps and source and distribution and all that other stuff. So not going too far on that. So water source basics, crop needs, current convention for irrigation and blueberries is 1 inch of water per week. From all sources total. So if we get some rain, we get 1/2 inch, then we only need another 1/2 inch coming from somewhere else. That's a very general rule of thumb. Obviously, fruit set might need a little more water. Irrigation is important in both years of the crop cycle. Sufficient moisture in a prune year is going to give you a bud set that sets you up for a good crop year. So that 1 inch of water is super important math. Basics of everything that I know, 27,000. If you remember nothing else out of this presentation, please remember 27,000. That's 1 inch of water on 1 acre, 1 acre being 43,560 square feet. So generally from the folks I've called and spoken to, extension and other growers that are more knowledgeable than myself, supplemental irrigation for blueberries should, with quotation marks, it's not a perfect world, but should aim to provide about 6 weeks or 6 inches per year of supplemental irrigation. More is preferred if possible. That gets into source sizing. We should be aiming for about 6 inches as I understand it currently. Does anybody out there disagree with me? No bricks coming my way, I will continue. So 6 inches a year on an acre, that is approximately 162,000 gallons per acre per year. Obviously that's scalable with field size. So the biggest challenge is finding that water. And it's not easy. So I'm going to use a hypothetical example through this presentation. Take a 30-acre field. So the crop water needs at that 1 inch application per week, 30 acres, 27,810,000 gallons per event. We need 6 events of those a year, at least we're trying to plan for those. We're looking at 4,860,000 gallons. Sounds like a lot of water. I have no idea what 4 million gallons of water looks like other than to do some math and try to figure out what sort of box that might fit into. So as a pond, I'm talking about a square hole now, a lot of limitations here, right? Very basic. I'm not doing 2-to-1 side slopes. Depth is variable. I set the depth here just for mental purposes, 5 feet shorter than I am, taller than Ashley in the back. So actually maybe you're a little taller than that, but something I can wrap my head around. So 30 acres at 1 inch should be a single application. It would also be 1 acre at 30 inches. Super tough math, I know. So basically 1/2 acre pond An acre being 220 feet by 220 feet, so you're talking like 110 by 110 by 5 foot deep. That's how much water for one event on that 30-acre field. We talk about seasonal needs, obviously 6 inches per acre. You can see the math there, a 3-acre pond at 5 foot depth. Now depth here is variable. Blueberries, most of you have probably seen a couple rocks in your field. We know we're shallow to ledge. We don't even know if we can do 5 feet of depth. Some places we can, some places we can't. So if we can dig 15 feet down, then we need a 1-acre pond. All that math is scaled. That's general, rough, super rough pond sizing. The type of water we're talking about with this 30-acre example field. Bigger field's gonna need a bigger pond, right? Pretty unique math here. We're using standardized 5 foot depth. Take whatever your field size is, divide by 10. That's pond size at 5 foot depth. Real rough, real dirty back in the map in math. So 3-acre ponds aren't going to be possible everywhere necessarily, and ponds can become pretty expensive. Currently, as I understand it from talking to the folks up in potato country, actual cost of ponds about 100,000 an acre. So a 3-acre pond might be 300,000. Cost share rate is not 100,000 an acre. Say that and hold those details a little further till the end. So what about a well? Some of you are probably thinking. Wells really depend on the distribution size, system, and the type of emitters that are going down. Wells have more to do with flow rate than actual just bulk volume like we're talking about with. So the flow needs, and again, this is very generalized. Some of you up in the audience who I recognize know a heck of a lot more about this stuff than I do. So if I get any of this wrong, please launch breaks, cups, napkins, shoes, anything you have available. Big guns are variable. All these systems are variable. You know, they make big guns that run 50 gallons a minute. They make them that run 200 plus gallons. They make big guns that throw 75 feet. They make guns that run 150 feet, and everything in between. I probably missed some. So just in general, big guns as a range, 50 to 200 gallons per minute per gun, throwing water 75 to 150 plus feet general. So you look at that area coverage, right? Circle math. I won't get into it with pi r square for y'all that got through high school fully. 0.4 acres of coverage on the small end per gun to about 1.5 acres on the high end. So for this 30-acre field example, 75 to 20 guns. Obviously 75 is the smaller guns, 20 is bigger for the whole field. Start looking at flow rates, take that top end math, 20 guns shooting 200 gallons a minute. 2 times 2 is 4. That's pretty easy math. 400 gallons a minute, 4,000 gallons a minute to run 20 guns at 200 gallons per minute. Rough math. It's not perfect. Specific systems are going to dictate what those numbers are. I'm trying to give you a feel of what we're talking about for water in general here. So big guns, depending on the size, we're going to turn a whole field on at once. 3,500 to 4,000 gallons a minute. If you're going to break that into individual acres, you're going to turn them on 1 acre at a time, 120 to 130 gallons a minute average per acre. If you want to run 10 acres, well, then you're 1,250 to 1,300, and you can parse it from there. But single acre rates, and then run times to put down 1 inch without factoring in evaporative losses and throw arcs and nozzle degradation and all the other stuff I barely understand. About 3.5 hours average to put 1 inch down. Anybody disagree with that, right? No, right? Okay. I'm sure I'm wrong somewhere in there. Sprinklers are the other way we go about this. Smaller systems are a little more efficient in some cases, evaporative loss wise, because we're throwing water less distance, so we're losing less as it goes through the air, flight paths. But they're lower flow and they cover smaller areas, so you may need more of them. So on the small end, 3 to 20 gallons a minute, 15 to 60 foot throw radius. Obviously, there are sprinklers that go more than that. 700 square feet a piece, so about 0.016 acres. To the bigger ones can be up to 1/4 acre. So on a per acre basis, 62 small ones potentially, up to 4 1/4 acre sprinklers per acre. If we start talking about that 30-acre field example, 1,865 to 120 sprinklers. It's a pretty big range. One thing to keep in mind with sprinklers, I am not accounting for frost protection or overlapping spray patterns or anything like that. I'm just talking bulk net coverage here. Of course, they don't spray in square, but the purpose of making the math easy, I made them spray in square. Do that, I'm responsible. So flows 2,400, 56,000 gallons a minute. Again, not a whole lot of difference between the big guns, really. Even though each sprinkler is throwing less water, they're throwing it less distance. And so when you're turning on the whole field, you're still in the ballpark. I mean, that's a wider range than big guns. It's pretty discrete band. We start running an acre at a time, 80 to 180 gallons per minute. Run times anywhere from 2.4 to 5.6 hours. Again, more variation because there's a whole lot more sprinkler variation in size, throw pattern, PSI, and gallon per minute. So again, not including evaporative losses in here, but the big takeaway here is when we start talking about distribution, running systems, even on a per acre basis, you're in the ballpark of 80 gallons a minute minimum. We could go smaller than that. You could run single sprinklers and cover tenths of an acre, but on a 30-acre field at a 2.4 hour runtime, because that stuff's standard. If you're spraying at a certain gallon per minute on your coverage area, that time to get an inch down doesn't change, no matter how many guns you put out. Each gun can only put the water out for itself as fast as it's going to throw it. So keeping those numbers in mind, start looking at wells. What kind of well runs that? Well, simple math here is you at least need a well 80 gallons a minute to run directly off the well and run sprinklers that need 80 gallons a minute, right? So the yield rates on a well is related to the recharge. So we're talking continuous pump rate. You know, everybody's got a well. If you understand basic wells, you got a casing, there's water in the casing, static water level is somewhere in the field. You got a pump below that. That water between the two, you can pump that out as fast as you want, but that's only a partial amount of the water you got in the well. At that point, you can only have as much water out of that well as what seeps back into it. That's the yield, that's the continuous recharge, and that's our continuous pump rate. It's not the same as what comes out of the spigot. So typical residential wells, will say it's 3 times because apparently from the psychological stuff I read online, if you say it 3 times, people remember it. So residential wells are not suited to run irrigation systems. Residential wells are not suited to run irrigation systems. A good residential wells are not suited to run irrigation systems. A good residential well, 20 to 30 gallons a minute. That is not really enough to run a system directly. 20 gallon per minute well, which I have at home, I think is great. It takes Schattman. Well, I'm going to avoid who takes the long shower discussion in my house, but you can run 4 5 gallon per minute sprinklers at a time. That'll cover about 0.1 acres. So even on a pretty strong home well, it's not going to cut the mustard. You can Google Maine water well database, punch that in, and it'll get you there. Or there's the website, it's DACF, it's a state website that lists drilled wells in Maine since some year in the 80s that I forgot. But it's some sort of law where everybody who drills a well has to list the yield on that website. There's a bunch of dots on the map. You can zoom in, you can find your home well. You can click on it. It'll tell you when the well was drilled, how deep it is, and what the yield is. Green dots are the higher yielding wells in that database. They range from 15 to 200 gallons per minute. I clicked around. I probably spent more time than I should have clicking around. I did it on my own time, so don't worry, it's no taxpayer funds expended doing that. But I could only find one 200 gallon per minute well. I didn't find anything bigger in there. There's a lot of dots, so I mean, you can really spend some time clicking around, but it's worth checking out. So when you start thinking about what might I hit for water if I drill a well, start looking at the dots around you and see what other people are hitting. Get a pretty good idea of what might be there and might not be. That's residential typical wells. That's the easy wells. We start talking about high yield wells now. I hope somebody's going to disagree with me on this because I just made this up. Literally, high yield wells, I'm going to call it greater than 500 gallons per minute. There must be some threshold somewhere that's an actual defined high yield well. I have no idea what that is. I could not find it in a reasonable Google search because I spent all my time clicking on green dots on the well database. We'll call it 500 gallons a minute. A lot more challenging to identify and more expensive to develop those types of sites. And so when we started looking a couple slides back at what sprinkler systems need for flow rates, I mean, 500 gallons is towards a solid sprinkler system, but it's still not running 200 gallon a minute big guns. I mean, you can literally run 2.5 big guns off 500 gallons a minute. So we're talking serious investment for a high yield well. It's challenging, usually requires hydrogeologists or other professionals, which I am not. Once again, I do what I'm told and go where I'm needed, but I am not an engineer or an irrigation specialist. Somebody who makes a lot more money than I do, who knows what they're doing, looking at subsurface hydrology. Some sort of input is needed to identify potential sites. Generally speaking, as I understand it, from talking to folks that know more than I do, you drill a couple of test wells to see if you're going to hit that kind of water before you drill the big well and develop it. Stuff can get pretty expensive. And once you're into big wells like that, you're really putting a big straw in the groundwater until there's regulatory implications, offsite impacts to neighbors, potential impacts to streams. I'm sure permitting is delightfully more fun than a residential well. And there may be some compliance monitoring. And that's just what I understand right now from talking to a few folks. I'm sure that it goes a lot deeper than that. So takeaway here is high yield wells are possible, but there's a lot more effort that goes into it. So some of you may be thinking well pond combinations. Why can't I take a low yielding well and recharge a pond? Maybe you can do that. But for our hypothetical 30-acre example where we need 4,860,000 gallons, straight math there, continuous pump time, you still need to find about 80 gallons a minute continuous yield to pump that pond full each week so that you can turn it on in the pond and have the volume of water you want with a bigger pump that you can pump faster than a well can discharge to be able to put out a full system on 30 acres. So still beyond the reach of a residential well. Other considerations, and again, this PowerPoint is very general. Ponds may naturally recharge, they may not. It's hard to say. We gotta explore the site. It's specific to the location. There's evaporative losses. Like I talked about, big guns lose a lot of water in flight, up to 40%. Sprinklers lose less, but you need more of them. Reduced irrigation frequency can stretch the supplies, partial acreage, leapfrogging guns, zone approach, drought-prone areas only. There's a bunch of different ways that we can slice this pie here. The intent here with these general considerations is not to scare you away from irrigation. We want to help folks with irrigation. We want you to understand how challenging it can be so that you're coming in with realistic expectations. Even if we can do this stuff, we got to think about labor to manage these systems. We're going to start and stop them. May not be on site. Where's the field in relation to where the staff are that might be running these things? We might have to move them if we're doing partial field irrigation. You run that thing for 2.5, 3 hours, and you got to move it over to the next array or zone or section. Is that something folks can handle? Seasonal setup and takedown. If it's temp, there's a lot of talk about lay flat pipe. Surface laid aluminum is pretty common in the industry. All that stuff. We got to set it up in the spring. Take it down before we drive a harvester through it. Typically, I know some of you may choose not to do that and have fun doing that, but most of the time we take that stuff down before we mow over it. On-site resources, do we have electrical to run a pump, or are we looking at fuel imported? Do we have support equipment on site? Depth of the ledge, I mentioned a little bit. It's going to impact pond depth, buried pipe potential. And then with all of that said and done, cost benefit. Is the juice worth the squeeze here? So again, this is not to scare anybody away from irrigation. This is to be realistic about what we need to go through before we start looking at RCPP funding. This process can take 2 years, easy 2 years. It starts with calling the field office. Let them know you're interested. We have a program that can fund irrigation right now. Things are still on pause. Probably shouldn't have even said that. I did. RCPP, Eric mentioned. That program is going to be a lot better suited for this if and when it comes active. But to get to the point where we can make use of that funds, we've got to start looking at your field, your site, how much you want to irrigate, system might you want to use, get a feel for how much water we're going to need to find, start poking around in the edge of the field. Usually we monitor a field for about a season, we put some test points in. Actually, we can go drop a tape measure down in the ground, see how much groundwater we have. Watch that field for a year, get an idea of what recharge might be if we dug a pond. All that stuff while we're talking the economics, and that's super important. So I mentioned actual costs of digging a pond right now from folks up in potato country that do a lot of ponds, about 100,000 an acre actual. As I understand our cost share rates right now, of course that stuff varies, but we're paying about 50,000 an acre right now. Those rates move year over year. So like we talked about, 3 acre pond for 30 acre field, $50,000 difference per acre there. So if we need a 3-acre pond, are you prepared to have $150,000 out of pocket to pursue this? That's probably a good conversation to have up front. We're not here to push anybody into anything they don't want to do, and I don't want to see anybody go out of business, but I want to talk economics and look at feasibility. Maybe that's out of reach. Now we know we're looking for smaller ponds, we're looking for smaller seasons. We're looking for smaller areas, maybe we don't have labor, maybe we're looking at partial coverage. That's fine, we can do that stuff. But we need to hone in on, because this is a 2-year process, where do we focus our efforts with limited staff, limited competitive funding to get you through that 2-year evaluation process so that we potentially are running on time. So I know folks probably have a lot of questions, big takeaways. I think I covered all that already. That's pretty good. Questions? Okay, awesome. Hands, go for it. Start throwing.
So I just wanted to clarify, to do the irrigation practices, you are taking people through an irrigation management as part of the
Yes.
prerequisite, right?
Yep, that is something that has to be developed in the process. And so we're kind of chicken and egg situation where we can't really come up with a good management plan until we know how much we're trying to irrigate and how much water we have. So that stuff, we start with some numbers, proceed forward, things are going to change, and we're kind of back and forth with the IWM to sort that out. Definitely.
And I just wanted to say that the state is running their farmer drought relief program locally starting this year. And the first level of funding for that is explicitly to help pay for a consultant to help you develop the water management plan to the NRCS standards.
Awesome.
So keep your eye out for that RFP. The second tier of that funding through the state has been developed in a way where my understanding is that it can be used to supplement the NRCS funding, so to help with that cost share amount. And I don't know if it's reimbursement based or direct payment based. I think they're still figuring that out. But just that state funds might potentially be able to use to complement them. That's all.
Thank you. Yeah, those are winners.
It's for water, so the state program is specifically for water source development, so you don't have to have water already. But what it's taking you through is the estimation for how much you need to ensure like current level of production. I mean, just for production, it might not be something. Like doing some of those calculations that would lead you to say, I need a 3-acre pond, or I need a well that yields.
The one thing that I didn't mention too much, worth taking note of, this is what I covered was finding a source that doesn't currently exist. Now, if you've got a pond on site, or you've got a pretty robust well, likely a pond, there's an existing source. We're way ahead in the process at that point. Now we're starting to look at how much water do we have there. That's just measuring in a rowboat with a rock on a string, generally speaking. Figure out what we got for volume. Okay, this is what we got to work with. How many acres can it cover? Things get a lot easier like that. So if you got existing sources, don't hesitate. I mean, we also put systems into ponds that you already have. This is just for folks that maybe don't have any water and are interested.
I meant to mention this up front. The Regional Conservation Partnership Program is a partnership. And I definitely need to thank and acknowledge all the various partners that are involved or will be involved hopefully in this project. That includes the University of Maine, School of Food and Ag, Dr. Schattman. It includes University of Maine College of Engineering. The person that's the lead on that is not here today. And it includes also UMaine Extension, Soil and Water Conservation Districts, Coastal Enterprises Institute. Let's see. I don't know, there's like 3 or 4 other partners that I'm forgetting about at the moment, but I apologize to those folks. But there's a lot of folks involved to make this possible, and I just want to make sure that I'm acknowledging everything. I'm here to answer questions too, but probably Chris will be your man for most of them.
Family.
Chris, I'm very much interested in this. I hope it happens. I know there's a lot of ifs, and more ifs now than there was.
I cannot comment to any of that, but.
Right, but having said that, there's a lot more ifs than you might even be thinking about.
Oh, there definitely is, yeah.
For most of us growers, because when you say that now it's open to everybody, including the big processors, they're the ones that's already best suited to be able to take advantage of this. Most of us, I'm lucky, I have a pond, a good pond, I hope I'll be able to use it sometime in the future. But most people haven't done any of that stuff that you outlined, which has already been done in most cases for the big processors. So my question is this, what's the rating system? What's the chances of anyone even applying for this? If you're talking $15 million, quickly in my head, I come up with math that you could have $1 million project, or at least $500,000. I mean, you're talking 15 projects, maybe 30. What chance does a little grower like me, or most of these people in this room have of being chosen if this ever goes to the end? Because I don't want to waste my time with all this.
That's a great question. And I'll try to answer that one. First off, the commission and our involvement in the project, we are staying out of the ranking process because that's not something that we want to get involved in. But there are built-in limitations. So I said that there's AGI, we're trying to get a waived, the max cap out of Farm Bill Life, that doesn't apply, but there are still limitations. And those are, number one, you can only have one open contract at a time with the project. So you can't start another one until the first one's been completed. Two, you're only allowed to have, there's a contract max, which is 450,000 per contract. So you cannot have one huge contract, as a large operation and take half the funding. That's not possible. So I think there's still lots of opportunity for folks to get involved, despite it being open to the whole industry.
Yeah, and I'll just tag on to that and say, I'm not involved with any of the stuff that Eric's in. The negotiations or how the agreement is crafted, that's none of my wheelhouse. I'll probably fit in if I'm involved with helping the field offices process these requests for folks that are interested and reach out to them and say, hey, I'd like to explore irrigation. And they may call me down and say, help me do what I need to go measure this pond or whatever. So as far as evaluating projects, I don't know what that's going to look like. I think your concerns are valid, and there's probably other people that are worried about that as well. And I'll just say from general experience with our programs, somebody's probably thinking about that and probably going to do something to try to bring some level of fairness to the table. It's nothing I'm involved with. Valid question. Anybody else? Mr. Howard?
Yes, not the same question, but to tag on to that, one of the things with the current programs that are out there, my understanding is, for example, you get all approved, drill a well, and go to all the expense, and you get no water. There's no reimbursement to the grower.
That's a great point.
Your expense.
Yeah. Yep. So that's a great point, and that is one of the risks. There are many risks that I did not get deep into, but the main one, you're absolutely right. We're trying to drill a well in our CS, and that contract has probably spec'd an irrigation system based on an irrigation water management plan and how much area you're trying to cover that has a flow rating that we need to hit for that system that we planned and put into a contract to run. And it requires hitting water that can support it. So if we drill a hole and there is no water, we don't pay for that hole. In some cases, we may ask you to drill again. I would relay some flexibility and intent from field staff to not leave anybody holding the bag there. Let's say you need 500 gallons a minute and we drill a hole and you only got 200 gallons a minute. I can bet that field office staff is probably going to call the state office or myself and say, hey, I didn't get the water I need, but I got some water. What can we do about this? That may be something where we start looking at smaller systems. We adjust planning size. We're here to work with you. Nobody should be left holding the bag, in my personal opinion. That's dangerous. Shouldn't have said that. But nobody should be left holding the bag at the end of one of these. So.
Yes, and there's a potential solution in the Farmers Drought Relief Fund that the state is currently developing the rules for. They have the program out for comment, the rules we commented on, and we actually are the only one. And this issue was one of the things we mentioned. So the program should, well, we'll see when it comes out, it should pay for a well that comes up dry. So I'll give you a couple of chances to do that. You know, of course, that means you've got to apply for funding from the state. And you've got to apply for funding from NRCS and kind of make the two work together, leverage both of these sources of funding to help reduce the chance that you end up with a dry well that you have to pay out of pocket for. So there are alternatives. And so once that program comes out, pay attention to it. Again, it's called the Farmers Drought Relief Fund.
Follow up, since I was Debbie Downer on that one. We did start going through their programs 4 or 5 years ago to apply for irrigation funding. So they've been through it. They've been terrific. The state folks, the engineers that come out, evaluate our land. We got already a 25-acre grant to put into place, but it does take 2-3 years easily. So I think it's very important, and it doesn't cost you anything to go through that. So if I were each and every one of you, I would call your office Monday or Tuesday, just to talk about whether you can start that on your land to get it in place, so that as all this works out, maybe in a year or two, whatever, but you can get yourself in line. The folks work with them. A new program for the state sounds like it's going to give even more resources, which I could never have done it. I could never have done it on my own without the engineers that they brought to evaluate our farm. So get on the list.
Yeah, thanks for that point. It's important to keep in mind, you know, if this thing goes active, it's a 6-year forward. But we don't want to wait till a year or two to start looking at this stuff. Because if it takes 2 or 3 or more years, we're in year 5. That's not where we want to be. Some of the risks we talk about with wells, and I mean, let's face it, you know, we all deal with the iceberg effect of a rock in a field, just a single one, you know, let alone some of y'all have some pretty wicked rocks in these fields. So, you know, you're all familiar with digging into the field and getting surprised, right? So we start looking at ponds or subsurface water supplies. I mean, you don't know what you're going to run into. So to mitigate some of that risk, calling early, giving us the time to spend that 2 years thoroughly chasing through this stuff is going to mitigate some of that risk. It's not going to remove it all, but we can be a little more confident when we actually go for something, spending the time to evaluate it, talking financials. You know, you should have a very clear idea of what we're looking at for money before we're moving forward and you're presented with a contract. Personal pet peeve of mine, sit somebody down at a table and say, hey, you've been funded, here you go. You know, it's the first time anybody's ever talked math, numbers, economics with somebody. We're wrong. You know, we should start that early, speak often and confirm. Back and forth is super critical. That's how we drill into a project that we know fits your needs and we plan for contingency. We've got a couple minutes left here. Any more questions or Eric, anything with that? Well, thank you everybody for your time. Please reach out. Table downstairs has a map with the local field offices and contact information. So if you're interested, just want to hear more, start that conversation, stop at the table, grab that, and give folks a call on Tuesday. Monday's a holiday, so nobody will be here. Thank you.
All right, we are going to get started. We have a presentation by Lindsay Werner.
All right, hi, everybody. Hope you're all ready for a nap, full of tasty lunch. I could use a nap right now. So I'm Lindsay Werner, and I do the farm inspections for the farms that are subject to that federal produce safety rule. So some of you may recognize me from that. This regulation is, well, federal FDA regulation. And so we have a contract with them to enforce it. And just a heads up to everyone before I dive into the water part, FDA is breathing down my neck about getting all the wild blueberry farms in the inventory. I don't know about a lot of you, and I'm running out of time to get you in the inventory. So at this point, I've met all of the processors, and now I need to move forward with getting farm information so I can get everybody in the inventory. Nobody will have to worry about me unless the gross annual sales are over 32,000 a year. Then you might need an inspection, but it's not the end of the world. Nobody goes to jail. Everyone will be fine. So these presentation slides are from the workshops that I did at the Ag Trade Show. And I'm not going to go through all the slides. I'm just going to skip through and try to do the fun ones with pictures and talk about the water testing part of it. But this is doing an inspection and assessment of your water sources as a way to get to know them and to make sure that they're safe for use on crop irrigation. So I put together this workshop because the federal regulation, the produce safety rule, subpart E on agricultural water was kind of up in limbo. And it is all finalized now. So for those of you that might be over the 32,000 a year, you might be interested in checking out what the regulation says. And the easiest way to find it is by searching 21 CFR 112, that's Code of Federal Regulations. And it will pop right up and you can read it. And the ecfr.gov link is my favorite one. That one where it references other regulations and definitions, you can just click on the hyperlink and it will take you right to it. That's why it's my favorite. I highlighted which ones to keep track. So just a basic quick overview of subpart E. It requires inspection of your entire agricultural water system. Of course, you've got to maintain it. And then it requires an agricultural water assessment if you have direct application to your crop. So if I don't foresee any wild blueberry people doing drip irrigation. So probably if any of you are irrigating, it's going to be direct application, probably overhead. And so that would require an assessment. And then we have pretty good water quality here in Maine, fortunately. So I don't foresee anyone needing to take corrective actions because they found some hazards associated with their water source. But some of the slides here kind of go over those scenarios. Been over that. Okay. So FDA has put out some tools to help people through this process. And this whole workshop is designed off of the paper-based tool. They have an online one too, but online doesn't work for me. I need to have it in my hands so I can look at it. And it took me honestly a whole day to digest this thing. But there's a lot of good information in here. It's just a kind of a lot to look at and take in. And so what I did was I took that and I broke it down into an outline. And this will be kind of like my cheat sheet for inspections to remind myself what I'm supposed to be looking at. And then I broke that down from there into these slides. And I also made a cheat sheet. So all of these resources are available on the website. If you do an internet search for Maine produce safety, it will pop right up. And so I made a cheat sheet that I could take into the field with me for how to evaluate the degree of protection of an agricultural water source, and then different considerations depending on what you're looking at, like other water users, crop characteristics, animal considerations, all these other things you're supposed to think about. So the thing that gets really confusing is the difference between an inspection and an assessment, and it's confusing because they have a lot of overlap. And so inspection, if you're subject to the regulation, applies to pre-harvest water, that's your irrigation water, but it also applies to harvest water. So like if you're icing product in the field while you're harvesting, or if you're washing product after harvesting, or you're hand washing water, your equipment washing water, that's all post-harvest water. So you would have to do an inspection of the agricultural water system for all of those different uses. And when you do that, you're going out and looking at it. You're inspecting the physical system that's under the actual farm's control, and you're considering anything that might pose a risk. But you're also, although you're inspecting what's under your control, you're also considering adjacent and nearby lands that might impact that. So basically you just go out and look at it. And then assessment, as you come back and you think about what you saw. And so assessment is only applicable to pre-harvest water. That's your irrigation water, dust abatement, anything you're using water for that contacts the crop before you harvest. It's based on your inspection findings, and you've got to evaluate the conditions that you saw. So you're just thinking about what you saw. And both of these have to be written. I've got commonalities on this slide. So the intent of both an inspection and an assessment is to identify conditions that could be a hazard for food contact surfaces or the produce itself. Both of these actions could trigger repairs or maintenance, and they're both annual, so you have to do it every year, and they both have to be documented for covered farms. And back to pre-harvest water. So this pre-harvest water assessment replaces all the testing that they proposed previously. So due to a lot of public feedback, they did away with that. They wanted you to test the water sources 5 times a year and then average all the numbers. So it was a lot of sampling, a lot of costs, a lot of headaches. So that's gone away and replaced with just an assessment. I have some examples of records if anybody wants to take a look at it. A lot of the point in putting these up here was that none of the record templates are perfect. They all have issues. And so I think everybody should just make their own. You could write something in a notebook, whatever works for you. I'm not going to spend a lot of time going through this, but this is the Produce Safety Alliance template that, I'm not wild about. And Community Alliance with Family Farmers puts out a lot of good stuff. They're out of California. And this is theirs. Problem with this one is it's 2 pages for one water source, and a lot of farms have way more than one water source, so that ends up being a lot of paper. So this is going to be a fun part of this. We're going to inspect my well, and this is my drinking water source, just so you guys all know. And if you go through the regulation when you're doing an inspection, these are the considerations that you need to be thinking about. So it's the nature of the water source. Is it a well? Is it a river? Is it a municipal supply? How much control do you have over the water source? How protected is the water source? And that's where the cheat sheet comes in. So cheat sheet's helpful for determining that. You have to consider adjacent land and then the use of the water prior to the farm use. And this assessment tool, the big packet that I held up, references a lot of inspection tasks in it. So that's why I say you can't have one without the other. They go together. So we're going to look at pictures. So this is my backyard. You can see my horse down in the back. We're standing right at the edge of my leach field. So the little stones are the corner markers of the leach field, and my horse manure pile is right next to my leach field, and then it slopes downhill. And that little white building is like an electrical access building, and my well is down behind that. So this is my old well, and out of view to the left would be the old windmill. So this well used to service the school when the school was next door to me. So it's a big giant windmill. It's pretty cool. I tried to drag it out of the bushes, but I just got a cement pad, and then when I bought the house, I had a wood cover and that was all rotting out. So I replaced it with that cement one. And that pole that's sticking up doesn't do anything. It's just the submersible pump is hanging from a rope and it's tied off to that pole. And so it's not perfectly sealed. This is my drinking water supply. It gets better. That's a close-up of my handiwork. This is my cement working skills, not too impressive. So it's pretty, like, the space between the cement pad and the cover, like maybe an insect could get through there, but it's not big enough for like a mouse to get through, but it's not perfectly sealed. And so this is a picture looking back uphill. So I'm standing on the cement pad, and you can see my little electrical access building and the manure pile up in the background. And those 2 buildings on the left, it's a run-in shed for the horses and the hay barn. And then my house is over in the trees. And then it's too bad that you can't see really well, I don't think, with the glare, but I lifted up the cement lid and I was trying not to drop my work phone down in there, but that's what my well looks like. So it's an old stone line well, and there's stuff hanging in there, wires and stuff. Oh, thank you. I'm capable of managing lighting. And so this is the fun part for me because I've got the manure pile and the horses, like my horses are fat and happy. They get tons of food. And so in the summer, and I took these pictures in the fall, they won't eat grass that's contaminated, that's going to make them sick unless they're starving, and mine are not starving. So what you can see here is the taller grass that the horses won't eat because of the runoff from the manure pile, right? So you can actually see it, how far it goes and what it looks like. So I just think it's a great visual example of runoff from a contamination source. And this is looking up. And I've got measurements somewhere. Moving around too much. I think it was like 25 to 35 feet is the distance from the edge of the bottom edge of the manure pile to the yeah, 33 and 36 feet, my best estimate to the edge of the runoff. And other distances that I didn't give you, which might have been helpful. The distance between the cement pad for the well and the electric fence is 10 feet. So I have about 10 feet of vegetation buffer where the horses can't go, between the fence and the well. And then the distance between the cement pad and the manure pile is about 235 feet. And so we're going to run through the findings of my inspection. So the source of the water, it's a dug well, could be under surface water influence. My well cover is not sealed, so something could get in there. Although I don't think it's likely to sheet off the land and then up over the edge of the cement pad. So I think it's mostly rain coming down and draining off the cement pad into the well. The distribution system, it's a closed system. This is my water source for my house. So it's all pipes, copper pipes, and it's intact. The extent of control, it's fully under my control. It's my well, it's my property. Degree of protection though, I would call it partial. Like my well is not sealed. It's stone lined, there's no casing. And so, you know, water draining through the soil can get into my well. It is regularly monitored. So every day that I'm out there doing the horse chores, I can see it. So I can kind of see what's going on. I have 2 horses. Like I said, the fencing provides a 10-foot vegetation buffer between grazing area and the well. Backflow prevention devices, I have them in the house. If you're in doubt about backflow protection devices, ask a plumber, because for all the training I've had on it, I still can't spot them all. It's kind of a tricky thing. So backflow keeps the backflow devices keep water from flowing into your well. So if you had like a contaminated hose and there was a hiccup in your system, the water could get pulled back into your well, and you're trying to avoid that to keep your well pristine, or whatever water source. And then I've got the manure pile uphill, which is not a great scenario, but it's 235 feet away, so that helps. Use of adjacent land, I've got woods, I've got my house, I've got the neighbor's house, and the horse pasture and the manure pile, and prior use of my water, there isn't any, it's just mine, I'm the only user. So is the water safe? Do you guys think it's safe? Anyone?
No.
All right, well, maybe it's safe. I don't know. Let's do an assessment. And then, you know, determining if it's safe kind of depends on the use of it, right? So is it pre-harvest use where you're doing an assessment, or is it harvest and post-harvest use, which is it's my drinking water. So that would be post-harvest use. And I'm just going to go for it so that you guys have an example, but you don't have to do an assessment if you have 0 E. coli and you're using it for post-harvest use only. But we're going to make a run for it and do an assessment. Oh, the template. So if you go on the website, I have a few of the packets available here. I made a template to try to keep you on track of what you've got to look for when you're out doing an inspection, so that you can come back and have a complete assessment. And so that's available online. It just makes sure you can tick off all the boxes so you collected all the information. So that is available. So we're going to start off the assessments. You can do testing as part of the assessment. You do not have to, because they did away with that. Thank you. And so we're going to run through my testing history so you can see what I learned and how much better I know my well from that experience. And so 2007, I bought the house, and the realtor did the full residential water test. So that's what you're seeing there. Everything looks good. I get the mortgage chained away for 30 years, paying the bank for that. So in 2009, I'm like, geez, I should probably recheck that. I didn't do that water test. The realtor did that test. And so I was kind of curious what it would be like if I did the test. So again, everything looks good. My pH was a little bit high, but it's a dug well, so that's going to fluctuate and corrode by pipes. Oh well. And so you guys can see for these residential tests, total coliform is absent. So they're doing presence or absent testing for that. And then E. coli is generic E. coli, and that's absent. So because this is drinking water, they're doing a presence or absence test because it has to be 0. And so that's an option. If you're trying to save money doing water tests, a post-harvest water is only paying for the presence and absence test, because it has to be 0. And so then 2014, I decided to test it again, and it comes back positive for coliform, not E. coli, but coliform. And so 2014 is when I started working for the state. And now I know about the basic water safety test, that that's what you need to have for a license. It's much reduced in cost and breadth from the residential test. So that's what I did. I have coliform in there. I'm like, oh no, what do? I shock my well, right? Which is a total nightmare because my well is like 400 feet away from my house. And so you've got to run the chlorinated water through all the pipes in your house. And then you're supposed to take a hose and hose down the inner surfaces of your well. And so I'm lugging buckets of chlorinated water down there, splashing it on rocks for whatever use that is. Probably silly. But anyways, it was miserable. But I've been through the experience. So in 2016, I'm like, I should probably check that, right? And so I do it, but it's a drought year. So I'm like, man, if this comes back positive, I'm not shocking my well. I don't have enough water to run it and shock it. So I had an epiphany. I was like, oh my goodness, I'll quantify it and see how much is there. Like, is this a problem or not? So I quantify it. I only got 1 colony forming unit of generic coliform. All right. That is not concerning for me. It would stop me from getting a food license, but I'm not worried about drinking that water at this point. So I'm like, fantastic. I don't have to shock it. 2019, I decided to check for coliform E. coli, and then the residential test didn't do uranium fluoride, and I use A&L lab. And so I was like, I might as well see what those turn out like. So here you can see I've got 1 colony forming unit of coliform, and less than 1 is basically 0 of E. coli, and my uranium and fluoride are good depending on who you ask. Checks out green. 2023, this was the last one I did just the coliform and E. coli. And what I did between the last test and this one was I did an internet search for where would this coliform possibly be coming from. And it was like, well, it's commonly from leaf litter. So now every fall I go down and rake all the leaves away from my cement pad and retest it. So I'm really curious if that's what did the trick, because now I have 0 for both, which is fantastic. I could get a home kitchen license with that water test for my scary looking well. Isn't that interesting? And so that's just a run through of testing. And so although testing is not required for a pre-harvest assessment, I would encourage everyone to at least test it a couple times to get a feel for what you're working with. And I'm going to skip, I only had 10 minutes. I'm going to skip through the assessment findings. This is all online if you guys want to take a closer look at what my assessment template would look like. I don't have time to do that, but when you do an assessment, you have certain outcomes. So these are the handy, beautiful FDA flow chart of outcomes. So if you determine that the water's not safe because, I don't know, you have a farm pond and there's a dead deer in it, that's not safe, then you need to immediately stop using that water, and you can't use it until you fix the issue and verify that it's been fixed. And then the orange box is you see something that could potentially be a hazard, and it's related to animals or humans. And so you would have to fix it within a year, right? You can keep using a water source, ironically, because FDA recognizes it takes time to fix these things. And then, thank you. Yellow would be some other hazard not related to humans or animals. And then you have a little bit longer. This is the one that's within a year. The orange one has to be as soon as possible. And if you do your assessment, so if like you go through my assessment, I find my well to be fine with no hazards because the manure pile is far enough away. I would just have to do an assessment the next year, or if something changed, like we had an earthquake or something catastrophic happened that could impact the well, I would have to do another assessment before a year in that situation. And so here's some examples from the FDA tool on some potentially not safe scenarios. So if there's a sewage overflow or a leak upstream from your water source, like I already said, the dead deer in the farm pond, a septic system fail near the water source, a significant, not just one deer passing through, but a significant amount of animal waste introduced into the water source. This is like a manure lagoon, leaking or a confined animal feeding operation. We don't really have a whole lot of those in Maine, thankfully, and there could be other unsafe scenarios. Like I said, you can't use it until you fix it in that case. And then if you find something that's a potential hazard, these are some corrective measures that you could take in that situation. So you can re-inspect the entire system and make these changes. If the hazard's under the control of the farm, you might be able to make a repair to take care of it. You might be able to remove the source of contamination. You might be able to treat the water by UV or pesticide, or there's a lot of different means. And if the hazard's not under control of the farm, not all is lost. You might be able to like build a berm to reduce runoff into the water source, or install a windbreak, or again, treat the water. There is an approved method, pesticide, for treating the water now, Sanidate 12.0. You don't inject it, you don't just dump it into your farm pond, you would have to have an injection system. So when the water is pulled out of the water source, the Sanidate's injected into it, and then that can go into the irrigation water, and that's labeled for use for reducing microbes of human pathogens. And so I'm gonna skip over that. And these are similar to, okay, no, this is where I want to stop and focus here. So other mitigation measures that you can take. You might be able to change the application method. So going from overhead irrigation to drip irrigation, where it won't touch the product. Make repairs, increase time between application and harvest. And so this is where die-off comes in. So if you take the Produce Safety Alliance grower training, we talk about die-off. It's a half log reduction a day. And so generally water is safe for irrigation if it meets the recreational water standard. That's the best science we have, and even that science is fuzzy, and that's 126 generic E. coli per 100 milliliters of water. And so I have in my packet online a little example where I did the math out, and I've seen a lot of water tests come back. So one side of my example is I made up some, I actually pulled water test results from gap audits. So these are realistic results. And then what I would do if I was a farm on how I was going to use that water. And then on the back, I did the math out. So 1 day of die-off would be applicable if your generic E. coli was less than 394. 2 days of die-off if it's less than 1,200. I've never seen a water test that high in Maine. 3 days if you're less than 3,800, and 4 days less than 12,000. So I think those numbers put it into perspective of how good the water quality is in Maine, and how I really don't think this is going to be a problem for anyone unless you're using Bieber bog water to irrigate your wild blueberries. Hopefully you're not doing that. So that tool is available online. And then you could also treat the water. If you're going to rely on commercial washing or increasing the time between harvest and end of storage, you have to have your own science to support that. And that's really expensive to put together. So probably not feasible for most of you guys, but you can use the science from the produce safety grower training for end of application and harvest time. So my water's safe, but this I want to close out with. So let's picture some different scenarios at my house. What if the manure pile was within 100 feet of the well? Now we're playing with fire, right? Because they say generally what's within 100 feet of the water source is influencing the water source. So if you guys want to go get to know your water sources, take a water test and go look at what's 100 feet around that water source to the best of your ability. If there was a dead deer next to my well, I mean, that's better than it being in the farm pond, but probably not great. And what if there was a dead deer 20 feet downhill from my well? Well, I don't know. I'd have to call a friend on that. So I'd be asking a hydrogeologist and be like, what do you think? Is this a problem or not? If my neighbor's septic fails while I was dog sitting for them, there are leach fields probably 200 feet away from my well. So it would have to be a pretty catastrophic failure for that to impact my well. Heavy rain events, we're getting heavier rain events. I feel like my manure pile is far enough away from my well right now so that heavier rain events is not going to impact it. But if it was 100 feet away from my well, certainly that would be a concern. And yeah, if my manure pile was within 20 feet of my well, I definitely would not be getting any passing water tests. And so we talked about possible mitigation measures. And so these are some, I think I'm 0, right? Yeah, okay. So there's a lot of other resources online. And so that was the quick and dirty about that. Thanks, guys.
Next we have Patrice Sison.
All right. Hello, everyone. My name is Patrice Sison. I'm a master's student taking up plant, soil, and environmental science at the University of Maine. I'm currently starting my second year here. So far here in Maine, I'm loving it. I love the people, I love nature, so everything's great. I'm also part of the wild blueberry team under Dr. Calderwood. And today I'm just gonna talk to you about drone spot spraying in Maine wild blueberry. But before that, here's just a brief introduction of the what's and the why's of this project. So in every wild blueberry field, there's a common pest. What pests do you see? Anyone? In both pictures. Yeah, weeds. You're getting there, yeah. Yeah, but the white ones are weeds, and on the right one, the green ones are also weeds. So weeds are common pests in wild blueberry fields because they compete with the plant or the crop in terms of sunlight, in terms of water, in terms of nutrients, sometimes space, and others. And due to the heterogeneous nature of our wild blueberry fields, weeds are also hard to detect because they occur in random patches all throughout the field. So because of that, they're hard to detect, they're hard to monitor, and therefore they are hard to manage because they just occur randomly all throughout the field. To combat these weeds, we are doing, growers right now doing integrated weed management, which is a combination of mechanical, cultural, chemical, and biological methods. For mechanical methods, we are cutting, we are hand pulling. For cultural methods, we add sulfur. For chemical methods, we spray herbicides. And for biological methods, we also could apply biopesticides and other biological agents. However, there's already an advent of new technologies today. And one of these new technologies are unmanned aerial vehicles, or what we call, or commonly known as drones. These drones can be equipped with different sensors. So we have the red, green, blue sensor, or RGB sensor. We have the multispectral sensor and hyperspectral sensor. Now, Patrice, that's like high tech. What are these sensors for? Well, let's get back to our old science classes, way back when we were elementary or maybe high school. So in our old science classes, we were taught that every object on the ground emits or reflects different amounts of energies and light. So the colors that we could see with our eyes today are part of the visible spectrum. Now that is what the red, green, blue sensor could detect. That's why you can take images to your cameras and your phones because of that red, green, blue sensor. There are also energies that we cannot see with our eyes, and one of those are in the IR or infrared region. That's what the multispectral and the hyperspectral sensors could detect, alongside this visible spectrum or the colors that we see. Okay, so now that we know that drones have this capacity to carry these sensors, we can now understand that drones also have, and because of that, drones could have drone aerial images or high quality images. Drones could produce that. An example of that is what you see here below. So this one is the drone aerial image. On your left, it's drone aerial image found in Harcourt, Maine, while on your right, it's Appleton, Maine. So it's a wild blueberry field image produced using a drone. And with this image, we can now detect the random weed patches that we see in our fields. So over here, the ones that are highlighted in blue are the weed patches, while those are in brown are the wild blueberry plants, which is taken during early spring. Okay, now that I gave you a brief introduction of these new technologies about drones, about the sensors they carry and their capacity to detect weed patches, we could now add these new technologies into our integrated weed management toolbox, which would now dive into the world of site-specific weed management, or SSWM, or what we call as precision agriculture. So we're now entering into this era of targeted and precision agriculture. Now, site-specific weed management system precisely monitors large fields, like as you see earlier in a few minutes. And thus it would lower our production costs because we would only target specific areas that we need to control or manage. And with that, we will now reduce the amount of material that we use and also reduce the onset of herbicide resistance because we're lowering selection pressure. And overall, it will improve biodiversity because we just spray to the areas that we want to spray and not to the non-target areas that are beneficial to us, such as the pollinators and others. Here in Maine, precision agriculture is currently being practiced, and one of those precision agriculture guys are AI, active intelligence. We are working closely with these guys. They offer drone services in the areas of agriculture, in forestry, and many other industries. So what you see here in this picture is they're using a spreader drone to spread weeds, seeds, to spread seeds into a corn. Okay, now that we saw the advantages of these new technologies, there's a research collaboration among University of Maine, Active Intelligence, and Dalhousie University, which is found in Nova Scotia, Canada. In Dalhousie University, they're currently targeting broadleaf weeds using these drone technologies. For us in Maine, we are targeting grass weeds using these drones. And with that, here's just the objectives of this project. So our first objective is we just wanted to create an herbicide spot spray map. Our second objective is we want to test that map and import it into a spray drone, and then compare the herbicide efficacies of our traditional boom spraying versus drone clethodim applications. And for our third objective, we wanted to quantify the amount of spray drift and deposition to determine optimal spray drone settings. Here are just the scopes and limitations of this project. So the herbicide that can only be drone sprayed in the state of Maine are grass herbicides. Now, since drones are still considered aerial applications, we follow what the herbicide label states. And as you can see on the figure on the right, these are just the common herbicides that we use in our Maine wildberry fields. And the ones that are colored green are airily allowed. The yellow depends on the formulation, while the ones that are in red are not airily allowed. So that's why this project is mainly just focusing on grass herbicides, because we want to follow herbicide labels. Also, the images that we took are during the early spring prune, because we wanted to capture the difference in color between the weeds that you see, which are white to brownish color, versus the wild blueberry plants that are colored like reddish brown. So we wanted to capture that so that we could create a good or accurate weed map. Okay, if you turn the person seated next to you and say, are you guys awake? You guys? Oh yeah, I see awake people there. Okay, now let's dig into these objectives. So our first objective, the creation of the herbicide spot spray map. So here's what we did. So in this first objective, we had 2 study areas. Site A, which is found in Appleton, Maine. Thanks to Paul Sweetland for hosting this. Hi, Paul. Thank you. And for Site B is found in Harrington, Maine. So this is what we did. So like I said earlier, with these 2 sites, we created drone aerial images with these 2 sites using the DJI Matrice 300 RTK equipped with the RGB sensor. After which, we process that drone image into a computer software named Pix4D fields. So each drone image has pixels in them. So we wanted to classify those pixels into two buckets, either they're weeds or they're wildwood plants. So because of that, we are able to produce a classification map. But we want to test the accuracy of that map. So we did an accuracy assessment so that we could compare the map we made with actual ground truth data. So the ground truth data may be image-based or ground-based. So what are these ground truth data? So that we could verify the accuracy of our map. So for image-based data, as what the word says, we use the actual image so that we could compare it with our weed map. However, for the ground-based data, that's me. I went out in the actual field, looked into the areas where I wanted to assess and saw, and I evaluated if that is a weed or a wild blueberry plant. And afterwards, I used that data to verify or to compare that with my actual weed map if that weed map that I did is accurate. Okay, so here's the results of our first objective. So like I said earlier, every object on the ground emits different light energies. So as you can see here, the ones that are solid blue are the wild blueberry plants and their respective spectral profiles or their respective light reflections. While the ones that are dashed in green are the weed patches. As you can see, there's a great distinction between the two, which makes it possible for us to create a weed map because of these reflectance pattern distinction. And with that, we have this weed maps. So here's our weed map. On the left is a weed map for site A. And on the right is a weed map for our study area in site B. So the ones that are in white are the weed patches, while the ones in black are the wild blueberry plants. Now these weed maps are great because it tells you the geographical location of your weed patch and also the total area of the weed patch that you have. And not to bombard you too much numbers, but I just want to show you the accuracy of the maps and how I did my accuracy assessment, like I said earlier, between the image-based and the ground-based. So overall, if there's a, oh, there it is. So overall, for site A, we had a good weed map accuracy, but when we used ground-based, it lowered into 71. For site B, when we did the image-based accuracy assessment, it was high, 94. But then when we did our ground-based accuracy assessment, it decreased into 71%. Overall, these weed maps are like medium to excellent weed maps. But what you can observe here is that when we went out in the field to actually see if our weed map is accurate, it lowered in accuracy. This may be because we got out in the field like early, around July, when weeds have started to expand. So because of that, some pixels that we had with our weed map may have, or the wild blueberry pixels in our weed map may have turned into a weed patch when we used our ground-based accuracy assessment. So that's a little, it just shows that our weeds expand once they vegetate. Okay, moving on with our second objective. We now want to test that map into a spray drone and then to compare our herbicide efficacies between our traditional boom and our drone them application. So now that we have our map, we want to import that map into a spray drone. And the commonly used spray drone today is the DJI T40 spray drone. Also, we have default drone settings such as height, speed, route spacing, and droplet size that can be altered by the drone operator or by our computer software, the Pix4D field software. And like I said earlier, we want to test the herbicide efficacies of the drone with the map versus our traditional tractor boom spray. So to test the herbicide efficacy, we just split our two sites into half. So the ones that are in highlighted in blue are the drone sprayed side, while those that are highlighted in black are the boom spray sites. The herbicide that we use in this study is Schattman at a rate of 8 ounces per acre for both the drone and tractor boom applications. And like I said earlier, we just used whatever drone settings that the Pix4D software used for site A. And for site B, we lowered the route spacing to 10 feet, which I will explain later. And then to see or to record and measure grass control, we had these plots. So we have a small plot, a medium plot, and experimental plots, which are found in the drone spray side and the boom spray side. We had these different sizes of plots because we want to match the wheat patch with these sizes. Within each of these plots, there are 5 quadrants. And within these quadrants, we measured wild blueberry cover, grass weed cover, and phytotoxicity severity at a rank of 1 to 5. And these are just a few pictures of how we assess our weed cover and weed phytotoxicity. And these are, if you could see the pink flags and other colored flags, that's our experimental plots. Okay, so here's the results of the second objective. So the result of our second objective showed that site A was not able to spot spray using our weed map, while site B was able to spot spray. The result is shown on the left. So for site A, the probable reason why it was not able to spot spray, so just broadcast spray the whole field, was because the wheat patch may have been too big. It's like 90% of the actual, it's a lot of wheat. So maybe because of that, the drone must have broadcast sprayed it, or maybe because it's the drone settings. While for site B was able to spot spray, because like we said earlier, when we saw that site A was not able to spot spray, we reduced some drone settings, which made it possible to spot spray. Now, spot spray in this sense is not going into the wheat patch and going to the patch and spraying. Spot spraying in the sense is autonomous. So as you can see here, these are the grid paths that the drone would fly through. And the ones that are in green is the time when the drone is spraying. And then when it reaches the area or the line that is white, the drone would stop spraying. And then when it turns into green again, the drone would spray. So it follows like a grid path that which is based on our map. So that's the spot spraying, that the essence of spot spraying in this study. Now, we saw that this actual spray path does not reflect the area of wheat patch that we found in our weed map. So that's a question, and that's a further improvement that we want to work on. And thus we need further improvements on the map creation and drone spraying, because it did not, the drone did not spray in just this specific area. It sprayed also to the areas where there are wild blueberries. So we need further refinement with our weed maps. So we're still investigating. Maybe it's the drone setting, maybe it's the other parameters. So we're further improving our algorithm on the computer software. Okay, now moving on to the herbicide efficacy. So when we looked into the herbicide efficacy of a boom versus the drone, there was just no significant difference with one another. And so yeah, there's no difference with grass control with the boom versus the drone. When we also did the study, we looked into requirements in terms of time, water, herbicide, and surfactants. So for time, the drone had a little higher time, but the drone had lower water requirements and also surfactant requirements. For herbicide requirements, they had the same. And because of these lower requirements, there are material savings from drone spraying. So imagine if we would broadcast the whole field using a drone, we would save 13 gallons of water or 4.15 ounces of surfactant, which is around $0.54 saved per acre, but depends on the surfactant that you guys would be using. So these are just the calculations that we have with our study. However, if you would spot spray the field using the drone, your herbicide requirement would drop from 24 ounce to 8.6 ounce per acre, saving $2.33 per acre. Now, this one is calculated based on our weed map, since the weeds are only 1 of 3 acres found in the map. However, like I said earlier, this is the potential savings. We still need to work on our map so that the drone could precisely spray only the 1 out of 3 acres of that map. Okay, let's move on to our last objective, and which is quantifying the amount of spray drift and deposition. So, but before that, I just want to explain what deposition and drift is. So deposition, it is the quality and quantity of droplets that land on the wild blueberry canopy, while drift is the landing of spray droplets to our non-target areas. Now, we don't want that. Herbicide drift is a major concern because it affects non-target organisms such as pollinators, beneficial organisms, and even humans. So in this objective, we want to lower drift and have a good deposition, or the amount of spray droplet that we have to our wild blueberry canopy. Like I said earlier, drones are still considered aerial applications. So we still need to follow the EPA label language for our drone spray. But these EPA label requirements are written or originally written for aircrafts and not for drones. So what we want in this study is to have added knowledge so that we could have an aerial label specifically for drones, so that we could reduce our equipment. Okay, now that I explained earlier, we have a drone operator, and that drone operator imports spray drone settings, like the height. How high does the drone have to fly? Or the speed, what's the speed of the drone when it sprays, and route spacing, which is the width of the spray, and droplet size, like how big the droplets that the drone produces. So that spray drone settings is what the drone operator could manipulate into the spray drone. But for this study, we are focusing only on the route spacing or the swath width and droplet size, because height is already dictated by our herbicide label, while speed is already governed by varying terrain. So the drone already compensates automatically for that varying terrain, and thus the drone will have it would adjust its speed automatically. So in this study, we just focused on these two. So the drone settings that we tested for swath width, we have 10, 20, and 24 feet. And for droplet size, we tested 220 droplet size, 280, and 340 micrometer droplet spaces. Just to review, these drone settings are what the operator alters so that they could import it into the drone. And to measure the deposition and drift, we placed water-sensitive cards in plots. So this is what our water-sensitive card looks like. And once we were able to spray these water sensitive cards with water, we added this into a drop scope or a water sensitive card scanning software. These drop scope would release or produce measurements of coverage area, like how much of the droplets are found in the, or how much area of the droplets are found in the water sensitive card. And it would also produce like application volume, the density of the droplets, the drift potential, and so on and so forth. So this scanning software was really useful. So here are the results. So as you can see, it's highly intuitive that with higher droplet sizes, there is higher droplet diameter. So it's self-explanatory because when we added higher droplet sizes, there's also higher amounts of droplet diameters that we found in our water sensitive cards. But this is what I want you guys to see. So what's CV? CV is coefficient of variation. It just tells you the uniformity of the droplet sizes. The lower the CV, the better, because the lower CV, the more uniform the droplet sizes are. So as you can see, with 220 and 280 micrometers, they are more uniform than the 340 micrometer droplet. For swath width, with an increase in swath width, there's also an increase in application volume that is recorded by the drop scope. With 24, yes, so higher swath width, higher application volume. So here are the actual pictures of our water sensitive cards. So when we increase our swath width zone settings, as you can see, there is higher application volumes with the larger droplets that you can see. And also when we increase our droplet size zone settings, you would also see the increase of the droplet size diameters. Now, why do we have to look into that? Why do we have to look into the sizes, application volume? It's because we wanted to look into the drift potential. We wanted to see if the drone had drift potential when we spray. So as you can see here, with an increase in swath width to 24, the drift potential lowers, while when we increase the droplet size, the drift potential lowers because, like I saw earlier in the last slide, there is greater or larger droplets. So that lowers our drift potential. And for this, our recommendation based on the study is 20 feet for swath width and 280 micrometers for droplet sizes, so that we could lessen our drift potential, but also have higher good application volume and a good uniformity of our spray drone spray. Just a brief summary. So this is my closing slide. So from our first objective, we saw that RGB drone imagery did effectively distinguish between grass, weed, patches from wild blueberry plants in Maine fields, which enables the creation of heat maps for autonomous spot spraying. Also in this study, we saw that the efficacy or herbicide efficacy of drone spraying and tractor boom spraying were comparable to one another. And thirdly, drone spraying saved water, saved surfactant, and potentially herbicide requirements. And the last findings in this project is that if the goal is to reduce drift and ensure uniform spraying with an agricultural drone in the system, we recommend a 20 feet swath width and a 280 micrometer droplet size drones. Here's a funky video for you all. Not a funky video, but it's the actual drone that we use in this experiment, in this study or project. So do you see the potential of drones in the library? Well, that's all. Thank you for listening. Yeah, So,
really?
yeah, good thing we have the drop scope, because that's the machine or the technology that just measures it,
It will.
drop by droplet, yeah.
So I want to use bigger drops, so I have less drift in my boom sprayer.
Mhm. Mhm.
But, I'm just a simple guy like me, measure my droplet size. I can use bigger,
Yeah.
I can use bigger nozzles, and I can use less pressure, and bigger my droplets are bigger.
Mhm. I think there's it's info card that I found that measures even like the droplet size. I think it's found in like Syngenta information card. I could forward that to you. It's a good tool that you could use if you want to measure the size.
Well, everybody ought to know, shouldn't they?
Yeah, I mean, I could share it to everyone. Yes, that's a good, thank you for that. I'm sure.
How long does it take, like, I don't know what size fields they were, you had field A, field B.
Yeah.
But how long would it take you to do like a 10-acre area with your drone
Mhm.
that you mapped out? And
Yeah.
like from when you get to the field until you're finished and headed to the next place?
Yes. Yeah, thank you for that question. So our fields are measured like around 10 acres. So it's like 8 to 10 acres, and it took us to spray half of that field around 8 minutes.
So you got there until you were ready to drive off to another. field.
Oh, I was not able to measure the moment I got there, but I was able just to measure when it was spraying and when it stopped.
Yeah, that's,
Yeah.
or you can go out and spray 8 acres in 2 minutes, but it takes a while to get there.
Yeah.
That's all else. So, and I see, I'm not trying to argue with you, put down the drone, but what we've done in the past, you were using, what did you say, you're using Sodoxidum or
I cut them.
grass herbicide?
Yes.
And so what we've done in the past with grass herbicides is, with a boom sprayer, it's just, you drive along and you can turn it off. The operator turns it off when he gets to the spot where there's no grasses and turns it on again.
Yeah,
It is.
yeah.
It's similar, I mean, it's not as high tech or complicated as using a drone and mapping out the field. But it's a method that we use of spot spraying with a boom sprayer. And to reduce our drift and our pesticide usage. Yeah, so that. So generally, unless the whole field has grasses, and we're going to spray collected them over the whole thing, right over the field.
Yeah.
So it's hard.
Well, one thing about drones is since they're up on the ground, so it could, especially for uneven land, they're really good because they're above the ground, so it does not affect the amount of spray that goes into your patch. So I think that's one advantage of using a drone. Yes.
Study one day when the weather was.
Yes.
Certain weather.
So we did have a weather station with our pockets, so we looked if the wind was less than 10 miles per hour, because we want to follow that herbicide label, and also we want the time of day when humidity is low. Because we had like one day where the humidity was high, so we had to stop our spraying, and then we continued when the humidity was low. So we did have we looked into our environmental conditions when we. Thank you, everyone.
All right, folks, how's it going? It's good to be here with you today. I guess I want to thank Lily for setting this all up and organizing as always. I think it's been a really successful day so far. Until now, when you have to listen to me, unfortunately, for a bit, but I'm here to talk about insects. Lily always just puts a generic title, probably because I usually forget to email her a title in time before she sends out the agenda, and she just puts down insect management. But I added on, it's also about keeping them alive. I'm going to jump around a little bit today. We're going to talk a little bit about mostly spotted-wing Drosophila as an insect pest, but I'm going to talk a little bit about those little parasitic wasps that we've been releasing and tracking around the state, and also update you a little bit on one project that we had funded through the Wild Blueberry Commission to kind of check in on the health of our wild bee population in wild blueberries here in Maine. Okay. I'd first want to thank all the people that did the work. I'm going to use the royal we here today, but for the most part, these are the people that did all the work, including Judy at the back. And thank some of the people that funded this research that I'm going to kind of update you on, the Wild Blueberry Commission. And we have a number of different grants from NIFA that have paid for different parts of the project or paid for graduate students who were working on some of this work, etc. Okay, so I will start with Spotted Drosophila, just because it's such a popular and fun subject to talk about. This is that little invasive vinegar fly that you're tired of probably hearing me talk about. But it is such a pest. We know the females have that serrated ovipositor and allows them to oviposit into marketable or ripening fruit, which most little Drosophilids can't do. So they lay their eggs under the skin, those maggots hatch out, and they can break down that fruit pretty quick, which is what we don't want to see. We obviously call it spotted wing Drosophila because of those little black dots that you have in their wings. I've been doing a lot of research into this. I was researching it before I joined here in January 2020, mostly because there is a large group of us nationally trying to figure out how to reduce some of the impacts of this pest here in the United States, but also globally. It's not just a pest in Asia, it's also a pest in the United States, in Europe, pretty much globally now, this is a big problem. I put this up mostly because of this little thing here. So when spotted wing Drosophila first came into the country, we were running around, we were trying to figure out really good ways to control it, and we were having a really hard time of doing that. This was a survey that we ran all the way back in 2014, where we looked at some of the effects of spotted wing Drosophila in terms of crop losses and how that impacted, we'll say, some of the costs associated with berry production. As you can see, blueberries, back in 2014, the average crop loss was estimated to be 13%. I will say when this survey was run, I think we had maybe 4 responses from Maine. So they lumped you in with cultivated blueberries. My plug is we're rerunning this survey, and I'm going to bring this back up at the end of the talk. I also have some paper copies, and I would love to get some fresh data to make sure, or to see if we're actually benefiting or have we reduced this 13% crop loss down with all of the years we've been working on this little critter, this little bug. We thankfully don't suffer as much as some of the other crops. You can see blackberries and raspberries. They really love blackberries and raspberries. They have about a 27% crop loss back in 2014, or 41% of your raspberry grower. Those 2 crops were really devastated by spotted wing Drosophila. Okay, so I've been highlighting this at multiple talks recently. This is early SWD occurrences in Maine. So my predecessor, Frank and Judy, they've been trapping this little bug in Maine for quite a while. We started consistently trapping in 2012. And you can see here, the graph on the left-hand side is the first adult male encounter. We track the males because that's what our action threshold is set on, and you see those spots in the wings. And as you can see, slowly but surely, we seem to have been creeping forward and forward when we've captured our first male. We haven't 2014 stayed on here. We didn't get out of traps early enough for my liking this year. We were running around with too much things in the lab. But conversely, when we trap males early, we also have our first larval infestation found has been following that same trend. So earlier and earlier, we're getting spotted wing Drosophila in our traps, and then we're getting associated infestation with them. I'm really interested to see what happens this winter. Feels like we've specifically been thinking some of these earlier occurrences have been based on some pretty mild winters of late. It feels like we have a little bit of a better winter. This is my 5th winter here, so I can't tell you that. You can tell me whether this one's a strong or harder one than normal or not, but I'm hoping this coming year when we put our traps out, we have a good few weeks of zeros because our population has been reduced by that winter. Maybe it won't, but I hope it will. Okay, so trapping for spotted wing Drosophila. My graduate student, Ben, who isn't here today, he has a whole chapter on all the different types of traps, the different commercial lures. He's been checking all of the different ones. We were really curious to see if we could come up with a better trap here in Maine, and I've concluded we can't. This little red solo cup with the yeast and sugar, they smell real bad, but they work real good. Spotted wing Drosophila are attracted to red, thus the red solo cup. It wasn't, and I think I've used this joke too much, it wasn't because there's a lot of red solo cups around the University of Maine campus. It's because it's really attractive to the flies. So the red attracts them first. And then when they get up a little bit closer and they land on it, all those lovely volatiles coming from the yeast and sugar mixture inside attract them inside where they get caught in that trap. So this is our standard recipe: 1 teaspoon of yeast, 4 teaspoons of sugar, 12 ounces of water, which is enough for 3 traps. We always recommend you put out 3 traps because one will be ate by a raccoon, the other one will get knocked over, and then you'll have at least 1 trap to give you data from. But really why we recommend 3 traps is that's what our action threshold is. We're really lucky to have an action threshold here in Maine. It's a good guide for us to just get out there and trap. So this action threshold, and we've updated these figures a little bit. I didn't include it in today's slides, but what we found is in our milder winters, some of this can get a little bit skewed. So I'm really interested in testing this again this year to see if our harsher winter has made this continue to be very accurate. But a good threshold here, say you put your traps out, you start checking them every week, you're counting the number of males and you're adding them up across your 3 traps. So if you have a cumulative male SWD fly capture, so you're catching males, you're counting them up, and you get an average of the likes of 3.5 across those 3 traps in, say, 1 week, that means you have a 90% probability of not having infestation the next week. So we're thinking ahead with this one. You're using the trap captures for 1 week to predict the infestation the next week. So a 90% chance of not having an infestation does mean a 10% chance of having infestation. So that can be a good threshold to think on. Mostly with thresholds, a lot of it is up to individuals' own preference, whether they're comfortable with a 10% chance, whether they're a bit more of a gambler or a bit less of a gambler. That is up to you all. But using these thresholds or using traps to monitor is really important to figuring out whether infestation levels are creeping up. Now, we also use in my lab quite a lot, and this is pretty easy to do. I don't think you don't need to be too intelligent because I can do it. But also monitoring for larvae is really important. This is a really good method for you to test that either you have infestation, you don't have infestation, maybe you're using sprays and it's working, or they're not working. You can also use it just to look at where infestation is happening in your field. I won't dwell on the method, but you basically just pick some fruit, you put it in some salty water. You can just use the bag and see if there's wee maggots floating around on top of the bag. Or in my lab, we do a little bit of extra sieving, and we also count the number of spotted wing Drosophila in this little cup to get a very accurate measure. Now, we've been doing this a lot. We've finished our last year. I don't think we're going to do any more on it. My graduate student, Ben, is about to write up this into a paper, but we were basically looking at transects into the field to determine what the spatial kind of distribution of these infestation from spotted wing Drosophila can be in untreated fields. So very simply, you can see here in this graph on the left-hand side, you have distance into field in feet, you have median proportion of infestation on the y-axis, so basically the amount of infestation. The key thing here is you can see we have a very big perimeter-driven effect for spotted wing Drosophila in our fields. Frank had shown very similar results for blueberry maggot fly. So that means we have the potential to reduce some of our costs, reduce some of our inputs in our sprays by just targeting some of our sprays in that perimeter area. And not basically spraying the interior of the field. Our recommendation has been to monitor infestation on the perimeter. If you find a little bit of infestation, then you could start your spray program if you're using sprays. And then you could then start monitoring your infestation maybe 100 or 120 feet in. And not until you really find infestation in there would you potentially stick to or go to a whole field spray. Okay, thinking about what to spray for spotted Drosophila. This is the results of a big survey that I ran. Well, it was quite a while ago now. We were 5 years ago. Unfortunately, we haven't had many new insecticides come on board to recommend or to repeat the experiment or the survey. But if you look at all of these active ingredients, and there's a whole load on here, there are a lot that basically would go from good to excellent. And obviously we want to use our most efficacious products because that will help basically to get us best control for spotted Drosophila. I'm not going to dwell on this. If you Google UMaine SWD efficacy, this is up on the website and you can download the full report. You can see basically all the different products. You still need to go and look at the label and figure out what rate we have labeled for here. But key point is there's lots of good products we can use to control spotted Drosophila if we're using chemical management for it. Here's another way to look at this, and I'm always going to stress this. Another way to look at it is the Lucky Charms method. Here, I've basically color-coded all the different chemical classes. And you can see basically we have a whole load of mixture of different chemical classes we can use. I know we're still restricted by, you know, who you're selling your fruit to, and you should always check with your processor what's on their recommended list. But rotating chemical classes is going to be key for this little pest because we've already seen resistance in other parts of the United States to some of our key insecticides. So resistance management will really be key. It also has a lot of good benefits for impacting the amount of residues we have on fruit, etc. But the key thing is to rotate your insecticides, stop resistance occurring. Okay, so we usually don't wander through this too much. We know a lot of these, so Mustang Max gets used a lot. Imidan was a product that got used a lot here in the past. So there's a lot of really good, excellent ones. People use Delegate. There was one insecticide that was on this list, Vertiprin. It's here in purple. I had used this previously in other locations when I was doing pesticide research. I had no data from it here in wild blueberries, especially for blueberry maggot fly, but I did know it worked really well for spotted Drosophila. So this year we tried to do a trial with this Vertiprin product and Delegate to see if we could test its efficacy against blueberry maggot fly. Unfortunately, we didn't get any good blueberry maggot fly pressure at the site we were working in, but we could still test spotted Drosophila because, well, spotted Drosophila is pretty consistent in its, we'll say, infestation. So here's the trial. We made 3 applications. The first one, what happened after August 2nd, and then we made weekly applications after that. The key kind of take home here is we got very comparable efficacy between Delegate and Vertiprin. So we think it's as effective as at least Delegate is, and it could be a really good rotational product for the control of spotted Drosophila. We also track the MRLs, so obviously, at least for those who think about exporting the crop or work in exporting the crop, really important to look at the residues on the fruit. The key thing here is the first day after treatment, we had a residue of 0.45 parts per million, which is the measure of the chemical on the fruit. That would be good for basically selling your fruit here in the US, Australia, Canada, Japan, Korea. The only people that haven't set a maximum residue level for this one product is the EU. And then, of course, you can see how Great Britain are doing from their independence from the EU. They couldn't set their own MRL either. So a really good product. It's going to work pretty well. We'd love if the EU would set a decent MRL, and then we could use it for any of the markets we want to sell our fruit into. When I talked to the rep about price on this, I think it was like $32 to $33 an acre. So it's unfortunately, like most new insecticides, a little bit more expensive than we want. Okay, so that's insecticides. I'm going to come back a little bit to insecticides later on. I'm going to just like remind us all about the impending changes to pesticide labels that are coming, but we'll cover that in a minute. Sticking with the spotted-wing Drosophila narrative, I'm also going to talk a little bit about classical biocontrols. So a key thing we've been aiming to do for spotted-wing Drosophila is to get biocontrols options first. So this is where we go and we find a little bug that attacks spotted-wing Drosophila in its native range. So because SWD is away, if it was from here in the United States or from Maine, usually what we have with any of those bugs is we'd have a whole lot of diseases, predators, or parasitoids that also attack it. Spotted-wing Drosophila didn't have that because it came over here all by itself and it didn't bring, you know, its enemies with it. The goal of a classical biocontrol program is to reintroduce those enemies into the same range as spotted-wing Drosophila and to release them to, you know, start hopefully reducing the population of spotted-wing Drosophila. I'll show you a little bit on the next slide what my thinking on that is. So when we think about spotted-wing Drosophila classical biocontrol, this started all the way back in 2014. That's when the first foreign explorations happened. They were very successful. They caught something like 19 different parasitoids. 3 of them looked really effective. They brought those 3 back into the United States into a quarantine facility. These quarantine facilities don't let anything in or out except for the humans that do the work in there. So they're very controlled because the last thing we want to do is release a little bug that we don't have permission to release. We have to do a whole host of research before we can apply for a permit from the federal government just to release those little biocontrol agents. So all of that happened, and I'm not going to go into that too much today. And we eventually, after much consultation at the federal level, got permission to release these things in 2021. I think it took 11 years of research, working with basically the government to go over that research to make sure everyone was happy that it was safe to release this biocontrol agent. So we got permission to release Ganaspis brasiliensis. It's now called Ganaspis camorum. We changed its name a little bit in 2020. And then here in Maine, the Maine Department of Inland Fisheries and Wildlife also do their own little bit of research to make sure they're happy with it. And I worked with them and I got permission in November 2021 to be able to release these little bugs here in Maine. So my lab got a little colony. We started basically rearing them up in the lab. It's a pain in the ass. Judy will attest to it. It takes a lot of time and a lot of money, but we were able to rear these up enough to release them. Okay, when I talk about a classical biocontrol program, the key thing I want to talk about is, well, one, the goal. So here is your SWD density. So this is like the numbers in your trap or the number of infestation. It's any level of population metric you want to think about. Spotted-wing Drosophila comes in, it gets established, its population grows, it grows over time. That means you find it earlier and earlier in the year, let's say, and that becomes really problematic. Say down here is where you have economic injury, that's where you get a lot of infestation. The goal of our little classical biological control program is to put this little bug in our field, and this is what we'd hope to see. As the little bugs population builds, our spotted wing Drosophila population starts getting impacted by that, direct parasitism. And slowly but surely, we get a reduction in the population of spotted wing Drosophila. The key thing is this x-axis here, it says likely measured in years. Unfortunately, these things take a while to build up and to be able to get working. So we're in the middle of what I would say is a long effort to try and get this to establish and get it to be effective, where we actually see results from it. So as a little bit of an update on basically where we're at, we got permission in 2021. We started our releases in 2022 and we worked at 4 sites. We released 1,200 wasps per site, so 4,800 wasps across all of the sites. And then we looked at the number of wasps recovered. So we released these out and we did a whole lot of sampling to basically see if we can capture them back again. We captured in site 1, I think it was 11 wasps. In site 2, it was something like 82 wasps. We got nothing back in site 3 or site 4. We just never got anything back. When we brought them into the lab and we started looking at them under the microscope, we actually found that we didn't even capture back the ones we released. It's pretty disheartening after all of our efforts. We captured a species called Leptopolina japonica. It was actually one of the species we had found in Asia. We looked at it in the lab and we were like, we don't know if we should release this. So when I talk about we have to do a lot of research to release one of these bugs, one thing we have to do is something called host specificity assessments. So what that is we bring all of these Drosophilids into the lab and we tested to see if they would be able to be parasitized by our little bugs of interest. So we brought in 3 species, Acebara. This is what we call a very broad host range. It would attack anything, and we don't want that. We want them to be very specific. This was that Leptopolina we found. It attacked a few more species than we wanted. It attacked a few other wee bugs that you don't really need to worry about. It also attacked in better numbers Drosophila melanogaster, Drosophila simulans, and Drosophila suzuki. Now, those 3, they're all non-native basically. So we really don't know if that matters or not. Ganaspis had very little other things that it attacked. So that was the more host specific one. Now we weren't alone because a lot of this was done in coordination on multiple larger grants. Other states were also finding this bug. It was just not here in Maine. It was also found in New York. It was found in New Jersey, Pennsylvania, North Carolina, Georgia. We all found it in 2022. We were all just sampling that time. So we think that this was just an advent of population. I will say it also was found in Europe. That's a couple of years earlier. It had been found in Washington before 2022. We just didn't realize how far it had spread. And it was also found in Canada and in British Columbia. So the outcome of this is we now have kind of 2 bugs attacking the spotted wing Drosophila. We have the one we released, and we also have this Leptopolina japonica that just found its way here all by itself and is now spreading around the country. Here was our 2022 data. Here is our 2023 data. So we went back out in 2023. We released 15,000 wasps. Again, this was just 15,000 total, mostly because we had a really hard time this year in our lab. A lot of our wasps died before we got a chance to release them, but we released across 5 sites. This year, we recovered 852 Leptopolina japonica, so numbers really creeped up. We got 10 Ganaspis back this time. We were really happy to actually get some of those Ganaspis back. But site 2 here in 2022 and site 2 in 2023, they're the same site. So you can just see how well it built up at that one site over that year. Now, I will say 2022, it was a drier year. There was less fruit out there. So we think that might have had an impact on its building up. But in 23, we had a really wet year. There was a lot of wild fruit that they were able to build up their populations on and really, really grow up their populations. Okay, when we think about how effective this wee bug is, this is field parasitism rates. So we collect a sample of fruit, we basically put it in a cup, and we count the number of the little drosophilids that come out and the parasitoids that come out. So if you had 100 in a cup, here on this like August 22 date, you picked fruit and there was 100 spotted wing Drosophila in there. We had about 65% parasitism. That means 65% or 65 of those little Drosophila larvae were killed and 35 were surviving. So it's working pretty good in the field. About 60 to 65% parasitism. I will say there's two colors here. Black is Ganaspis brasiliensis. Gray is that Leptopolina japonica. Mostly that Leptopolina species is doing really good. We caught a little bit of Ganaspis, but for the most part, it is all Leptopolina japonica that's doing a lot of that parasitism. Here was our 2024 data. We were out pretty early this year, and like the very first bit of infestation we found in some wild fruit was on the 9th of July. I was just as spotted wing Drosophila was starting to build up this year, and we had about 30% parasitism in that first sample. So a little bit lower parasitism rates this year, but for the most part, we're still tracking them, and they're still, you know, killing spotted wing Drosophila, which is exactly what we want. Okay, one thing we've been wondering in our lab is, given we've been releasing Ganaspis camorum / brasiliensis, but not really recovering them as successfully as we'd have hoped, what basically is its potential to overwinter? Me and some researchers from Michigan, New York, North Carolina, and New Jersey worked on this over 2 years. We put out basically those little Ganaspis brasiliensis into these soil cores. We pulled them back in on our regular occasions. I'm not going to go too far into this. This is some work from Shaun, my graduate student, but this is her data from last year. And what you can see here is we got pretty low return from our controls. So this is 0 days of exposure. That's our control. These are just like the ones we reared up in the lab. Per cup, we got about 11 of them back from each cup. But the really exciting thing is, while really low, we did get survival all the way out to 120 days. So we think this little critter can survive the winter here, but just at really low numbers. As we continue releasing more and we get more and more out to the field, I think we'll hopefully see those numbers increase. We can skip over it. Okay, so that was spotted wing Drosophila. I guess some key summaries. Trapping is key. You got to get out there early. If you're currently trapping, keep it up. If you're not currently trapping, start trapping. I'm done looking with new traps. I think yeast sugar traps work really good. We've many insecticide options, but probably not enough, or at least not enough cheap ones. Rotating them is really important, and those little parasitoids are really going to help, I think, control this insect. Does anyone want to ask a question on spotted wing Drosophila, or should I continue carrying? Lots of questions.
Captures the chart with expected infestation the next week.
Mm-hmm.
That was captures per week, correct? Not captures per visit. So if I visit twice a week, I would add 2 visits.
Yeah.
To get my captures per week.
You want your cumulative capture
per week.
Per week.
S plus or minus S dot E dot. What does S dot E dot stand for?
I'm trying to think of it as something funny, but it really just means standard error. It's just a
okay.
very boring thing.
Perimeters of spotted wing Drosophila.
Mm-hmm.
Perimeter is where more of the spotted wing Drosophila is.
Great.
And I understand the perimeter would be more where the Canoxus and other predator would also be.
Mm-hmm.
So don't I, when I spray the spotted wound Drosophila around the perimeter, don't I also kill my predator wasp?
If they're in your crop, probably, yes. So
What do I do?
you just worry about how good they're going to kill them outside of your crop. You should continue to farm your crop so you can get the most yields back from it. These little bugs will work outside your crop, and hopefully by the time they've built up their populations in a few more years, you'll have less spotted wound Drosophila coming into your crop. And maybe you don't spray as early, you don't spray as often, etc.
Right at the edge of the field, but not on the edge of the field.
You shouldn't drift beyond your field. Right. Anything you drift away from your field is just wasted money, right?
Or not, if it kills off spotted wound Drosophila, that's moving in my direction.
Well, I don't know. Could be off label too. Shannon.
Finding with these wasps is that they are working, but I mean, if this continues to show true, is there a point where they need to start growing these wasps and selling them to blueberry growers to put out in their fields? I mean, it sounds like this one that you found when you hadn't even put any out, it's developed, it's coming in on its own, and it's like a lot of things in nature, they're hopefully coming in on their own to balance off the spotted wound Drosophila, which everything is, but I mean, is in the future, is it gonna be a product that can be purchased or?
Potentially, especially that latter one, that Leptoplina. I guess the story on the two of them is we have that one that we have permission to release, the Ganastus one. That's a real pain to rear. We have to rear it in fruit. It costs us a fortune to rear that one up. The Leptoplina japonica one, that we can rear on an artificial media. So we can rear them all year long. We can build up their populations in the lab really easily. So that would be a lot easier one to commercialize and be able to send out to people. Yeah.
I just wonder if we have something similar, get horses, have a lot of trouble with flies in the barn. And we started buying these, they would send us a little bag of these flies every month that we would just sprinkle around the barn, and it somehow killed the larvae, the horse food, and it honestly got it really solved the fly problem, and it lingered. Even after we got rid of our horses, it lasted for, they survived enough in their own thing that they kept doing that for quite a long time, and they got rid of the fly.
Yeah. Well, yeah, that's the goal, for them to become self-sustaining and just continue beating down the spotted wound Drosophila without us having to do anything with them. And so hopefully over time we can get to that.
But they also eat ripe fruit. They just spotted wound Drosophila.
Yeah. Yeah.
So keeping like some things like blackberries and stuff on the edges of your blueberry fields is not a bad thing.
Not anymore. I think before we had any biocontrol options, I would have said got the weed whacker out and cut them down because the spotted wound Drosophila were just using it and then they were moving into our food. Now, still the spotted wound Drosophila are using it because they're not killing 100%, but at least there's this little biocontrol option out there now. Okay. I'll move on a little bit quickly to talk a little bit about pollination and get Jordan to keep me honest on time. But obviously we know to make fruit, we need to have this happen. Does anyone know what this is? Carrie?
Pollen.
There you go, it's pollen. These are pollen grains that have been deposited on a stigma in a flower. We need this to happen before we can get fruit. Frank had found, I think we need 25 pollen grains minimum to be deposited on a stigma before basically we get fruit set. The main way this happens in wild Burberry is bees. What happens when that happens is those pollen grains get deposited on the stigma. They grow these pollen tubes. Those pollen tubes go all the way down that stigma. They go into the ovaries, which are located here at the back. This is a blueberry flower that's just been cut in half. And they form the seeds that basically make your fruit set. And those seeds also, the more seeds you have, the bigger a berry you have, the more yield you have. That's why bees are so important to us. Obviously, we use a lot of managed bees. We use those dang honeybees that Jen Lund loves. She's shaking her head. They're really important because they help us have very consistent yields. They make sure that when our wild bees, which are really important, might be having a bad year, those honeybees are always around because we can just buy a box of them and stick them in the field. But honeybees are a great pollinator, but they're not as efficient a pollinator as some of our wild bees. So having a good, healthy stock of wild bees is really important as well. So I'm going to talk a little bit about some of the results from a 3-year effort that my lab has been doing in collaboration with Sarah Bushman, who is one of Frank's former PhD students, where we were looking at basically resampling some wild blueberry fields that she had sampled for her PhD 10 years ago. So these fields were predominantly in Hancock and Washington counties. In the original survey, Sarah had done 40 fields. She'd done 12 in 2010, 12 in 2011, and 16 in 2012. Our goal was to go back to those specific fields, those same fields. We wanted to resample the actual fields themselves. We couldn't get back to them all. Some fields had gone out of production, some had changed ownership. There was just some things we couldn't get back to. Yep. Oh, was it? Okay. We should chat afterwards. We might be continuing some of this work. Well, hopefully you get involved in this good news as well. Okay, so I will say the focus of this study was kind of more smaller fields, usually managed by a smaller scale grower. I don't know why Frank and Sarah wanted to specifically look at smaller fields, but we can say the average field size was about 8.4 acres, and it ranged in size from about 1.2 acres to 40 acres. And again, we didn't get back to all the fields. So that's important. We had like 40 fields versus 16 fields, and that's kind of played a part in the number of bees we caught in the resampling effort. But we can correct for that effort by talking a little bit more about it. So when we went out and sampled, we basically went out and we hand collected bees during bloom. We put out bowls to collect bees during bloom. We did a number of different methods to capture basically all the bees we could. When we look at the bee richness, and I will say that we did not look at bumblebees. For the most part, we don't try to catch bumblebees, queens, because obviously they're about to set a colony up, and the last thing we want to do is kill a queen before she's even got her colony set up. Here is our original data. So this is the original sampling from 2010 to 2012. And this is just the distribution of the different bee types. So we have a few very important wild bees in wild blueberry fields in Maine. The first are our sand bees, or our andrenids. You can see here in the original sampling, they made up about 42% of our bees caught. We also have sweat bees. These are tiny little bees that like feeding on sweat. We call them the lasioglossum. They made up 30%. In our resampling effort, and our resampling was a little bit different. We didn't go as far past bloom as Sarah did, but we've tried to correct for that. But our andrenids made up 57% of our bees caught, and our sweat bees were 21%. We're not too worried about that 9% drop, the sweat bees. But for the most part, our populations remained pretty good, which is really good news. These are like free bees. They do a whole lot of pollination work for you for free. Now, I will say there was 2 genera of bees, the Agichlorella and the Megachile, or the leafcutter bees. We caught them in really small numbers the first time we sampled, and we didn't capture as many of them the second time. We caught none of them the second time. But they're pretty small. It's a small impact. They're not very important pollinators. Okay, so if we try to correct for some of the differences in sampling effort, mostly the number of fields, we can look at the comparison of the mean number of genera observed per field site per date for the bees collected during bloom through June 4th for all years. You'll see 2012, which was in the original sampling. We had an exceptional number of bees that year. Everything went good that year. It wasn't too windy, it wasn't too cloudy, the temperatures were warm, etc. That was our best year. But what I'm really excited about, and I think is really important, is you can see 2022 to 2024, for the most part, they were comparable to 2010 and 2011. Now, in other crops and in other states, we have seen wild bees declining. There's been big crashes in wild bee populations in some studies. Others have shown okay things. For the most part, at least from this study, it looks like they're doing okay. This is a comparison of the mean number of species caught in each field by date. Note, we haven't finished 2024 data yet, but similarly, 22, 23 were good compared to 2010 and 2011. 2012 was still this exceptional year that it's hard to beat. Okay, I'll just focus it a little bit on the andrenids because they are really quite important pollinators. They're most frequently caught during bloom. If we look at any differences between our original sampling, which was on the left, and our resampling, which is on the right. So species marked with the blue star, they are known to carry extremely high levels of pollen, blueberry pollen. Then species with the red stars carry significant amount of blueberry pollen. So Andrena carolini, one of our key species. They were a higher frequency when our resampling. Basically, we had very little difference between the two. So our andrenids are looking like they're working really good still as blueberry pollinators. Okay, the next portion of my talk, I said I would harp back a little bit to the Endangered Species Act. Do you have a question, Karen? I can see. Okay. We had Cameron Douglas here last year, who kind of gave us a really good overview of the Endangered Species Act and what it might mean for using pesticides in wild blueberry. So this whole thing comes out of the fact that we have the Endangered Species Act. It's a really important act. We all love bald eagles and all of the things that are protected by the Endangered Species Act. The EPA have been meaning or has been meant to be thinking about the Endangered Species Act when it has been registering pesticides for quite a while, but they basically couldn't do that. They got sued quite a lot for their non-compliance with the Endangered Species Act. And because of that lawsuit, they had come up with basically a new rule where before registering a pesticide, the EPA must consult with the statutory specific agencies that have advertised on a risk of species survival. So they had to basically start complying with this Endangered Species Act. They had a number of options. They could just cancel the registrations of some insecticides and just give up on them. They could restrict pesticide use to only crops at locations without any endangered species. Both of those are pretty hard and really couldn't be managed at all. Or they could maintain all the pesticide use and add mitigations to protect species in their critical habitats for the Endangered Species Act. So this is going to have some impacts here in Maine. Those impacts probably aren't going to start being felt anytime soon, but they are coming, and it is widespread across Maine. Here are the number of endangered species in each of our counties. You can see we have counties that have a highest number of 17 endangered species, or as low as 7. But we do have many endangered species in many counties here in Maine. So this is coming. We already have a herbicide strategy that was worked on and consulted on and all of these fun things. I'm not really going to go into much about all of the changes or anything that might come associated with this. The insecticide strategy, they published a draft back in July. The final one is due at the end of March. So we'll have both a herbicide and an insecticide strategy. What that means is as new pesticides become registered or re-registered, they are going to have text associated with this Endangered Species Act on them. So you really need to take and pay attention to your labels and what they might say associated with these Endangered Species Act changes. One of the key things they're encouraging everyone to do, and it's good to start practicing this now, is you have to go on to this, what they've shortened it down to BLT, Bulletins Live 2 website. My colleague in Michigan actually puts up a picture of a BLT sandwich when he starts talking about this. But this is the website where you have to log on to and make sure your field doesn't have what we call a PULA, which is a pesticide limitation use area. It is seen by this like orangey shading. If your field has that orange shading on it, you're in a pesticide limited use area. You need to go to the label of any pesticide you might be spraying and make sure that you are noting that you are in a PULA and you are following any label restrictions associated with being in a PULA. Now, there's very little insecticide labels that currently have any of this text on them, but they are reviewing labels all the time, and slowly but surely most of our pesticides will probably have information associated with the Endangered Species Act on there. So when we think about these PULAs or these pesticide limited use areas, the key thing you want to do is go to that PULA. You need to do it 6 months before an application, which is a crazy kind of stipulation, but just think about every March, I should sit down and say, okay, I'm going to spray Delegate this July. That's what I bought. It's in my shed already. You can log on to this BLT website, make sure you go to your site. You can put in basically the pesticide that you plan on spraying that coming year and see if there's any restrictions associated with it. This was a recommendation from Cameron. He shared some of these slides with me that you should basically go and document again about a month before you have to make that application that you may or not be in a PULA. And it might be in your best interest to even like take a little screen capture to make sure you can see your field and see whether there's a PULA there or not. So there's still a lot of information associated with these changes happening. Whether it's going to stay at this current administration, who knows? But for now, it is the law, etc. This is a little QR code that brings you to a website called Protecting Endangered Species from Pesticides. There's a whole load more information on there. I will say one of the key things that they brought in is they brought in this point system. And we get a lot of points naturally here in wild blueberry. There's been a lot of good arguing by Eric and many others that we don't till our crop. We don't, do a lot of things that other crops do. We have a natural mulch based on our organic pad. We mow our crop and that provides another organic pad. So there's a lot of things that inherently get us points towards these pesticide limitation use areas. That could be a whole other talk talking about the points. One of those things that you can get points for is being in a conservation program. I think you get 2 points if you're part of a conservation program. So when I think about that and I think, okay, an easy 2 points could be to do something like the NRCS IPM for pollinators program or the IPPM program. I know Aaron Coca is here who can talk a little bit more about it. But this is a program, and I stole this right from Aaron's little fact sheet. I literally just copied and pasted it right in. But this is the Pest Management Conservation Program, or the 595 program. They have been offering this. I'm not going to get into the fact of federal government paying out things at the moment or any of that. We talked about that at the irrigation thing earlier. But if you were part of this program, you have to monitor and scout for pests. You have to consult some practices, but you do get paid per acre to do some of these things. And then you'd get points associated with being in a conservation program towards those points, the PULA points, etc. So activities you've got to do. You've got to sweep for spanworm and flea beetle. You need to monitor for blueberry maggot fly and spotted wing Drosophila, and you need to follow the disease forecasting model that Shaun has developed. And then you have to do a combination of these other things that basically means you're doing this program successfully. I will say, if you are interested, you should talk to Aaron after the talk or after the session. I'm sure she'll be down at the NRCS table. All right, I will end quickly. Do I have any time left, or a couple of minutes? Okay. Keys to helping our pollinators or conserving our pollinators. I did show we've done really well with our pollinators. It looks like our populations are looking pretty okay, but we want to keep that up. So when we think about pollinator protection, we want to think about basing your decisions on applying pesticides based on action thresholds. We want to monitor in the prune year, use the action thresholds that are in our little flip guide, use the pesticide forecasting tools. All of these are important for basically reducing the number of sprays and protecting our pollinators. We can use cultural controls, and I won't get into them, but their cultural controls can really help as well. Our bees really like flowers. Blueberries is a great crop for them because they have a mass flowering crop. There's been some really good research from Frank that showed that blueberries actually increase pollinators in the landscape because it's such a big resource in the spring. But after blueberry bloom, they also do need some additional flowering resources. So having some flowers not in your field, but away from your field, and then not drifting onto those flowers can really help with pollination or pollinators surviving. A few additional key points, and I'll cut these really short. Again, weed control, keeping flowers outside your field while you're making potential pesticides for pesticide applications for spotted wing or blueberry maggot fly is really important. You can use less toxic pesticides, reduce your drift, or do different timings. You can use less toxic insecticides by using this website here. You do UC IPM, bee precautionary pesticide ratings. You can see how your pesticide stacks up. Drift reduction can be done with different nozzles or using an adjuvant. And timing, obviously, you don't want to spray when it's too windy, or you can spray when it's so cool that bees aren't flying. Okay, I will end there and I'll take any questions, but here's that little QR code for that survey about spotted wing Drosophila that I'm hoping you'll all do, or you can take a paper copy. Any all questions while we're switching over?
I got to push it again. Folks, the executive director of the Wild Blueberry Commission spent a lot of time and put in a lot of effort to help us with the full list. The pesticide rules.
Yeah.
Well, for the Wild Blueberry taxonomy was done, having to do that in that effort. And did I understand correctly that you recommended some burning to reduce some of the different diseases, insect pressures, and helping pollinators? And if you did recommend that, did you make sure the NRCS people know that you're recommending burning wild blueberry fields?
I know they don't like you burning wild blueberry fields, and they paid a lot for de-rocking and mowing, but for organic growers, it is still one of the best options for controlling mumbleberry, or is that wrong now?
I just wanted to make sure that I understood that right.
Oh, I mean, I don't work for the NRCS. I can contradict them all I want.
You said that it's recommend burning?
Yeah.
Okay. Thank you. Make sure the NRCS people know that.
Oh, you're going to tell them, I'm
Should be
sure.
good to go.
Okay, well, welcome everybody. I'm glad to be joining you virtually. I am Rebecca Brown. I am a professor of horticulture at the University of Rhode Island. And one of the many areas that I work in is controlling bird damage in a variety of crops. And so that's what I'm going to talk to you about today, specifically controlling bird damage using lasers, which are a relatively new option. Okay, so I'm sure you're all fairly familiar with the problem. There isn't a lot of data on bird damage in crops, mostly because USDA doesn't actively collect that data. There was a 2012 survey of major highbush blueberry production regions showing that bird damage ranged from 3.8% to 18.2% of the yield. As far as I know, there have not been any surveys of wild blueberry production. And the majority of those growers in that 2012 survey were actually using bird protection methods. So even with protection, they were getting, in some cases, quite a bit of damage. And bird damage in blueberries is very difficult to quantify, particularly in pick your own operations, which are actually the majority of blueberry operations in the country. And this is one reason why there hasn't been a lot of research quantifying this problem. Okay, so as you know, there are some traditional control options, particularly used on smaller blueberry operations. Netting is the most effective, but it's very time consuming and expensive. And it doesn't work well on operations that are large because there's really no economy of scale with netting. Auditory deterrents are commonly used, but they're on their own, they're not particularly effective. And a lot of the other visual control methods have not been shown effective in controlled studies and have really been inconsistent in the field. Birds will be afraid of just about anything new in their environment for a little while, but they will quickly get used to that. And so things, may look like they're effective at first and then they stop working. Out on the West Coast, where they have large-scale highbush blueberry production, they've started using falconers, professional falconers who come and fly their birds over the blueberry fields during harvest to keep fruit-eating birds out. But those are extremely expensive, and I don't know that they're particularly available here in New England. So when we're going to keep birds out of something, one of the challenges is that we need to think or see like a bird. And vision is the primary sense for birds. Much more so than any other animal, birds rely on their eyes. And so visual deterrence should work because birds do use their eyes to sense danger. But we have to keep in mind that bird vision is very different from human vision. And this may be part of why a lot of the effigies and scare tapes and things like that don't work, is because no matter how real they look to us, they don't look real to the birds. Birds are able to see a much wider range of colors than humans can, and to better distinguish between colors. The difference between bird color vision and human color vision has been compared to the difference between normal human color vision and the color vision of a human who is completely colorblind. In addition to that, birds are much more sensitive to motion than we are. There are birds that can see the stars moving. And there are birds that can see as stopped something that we would see only as a blur. And birds are also able to process visual signals much more quickly than we are. So all of this adds up to the fact that birds can see a lot of things that we can't see. And one of those things is laser beams. So humans are only good at seeing laser beams under low light conditions. Once you get even ambient daylight, our eyes have a very hard time distinguishing that beam from the background. Birds, however, can see the laser beam or the laser spot even in bright light, and they react to that moving beam as if it were a solid object. So if they see it coming towards them, they get out of the way. It also is likely that green laser beams, which are the predominant color used in bird deterrent lasers, reflect and refract off the leaves because these are within that same group of wavelengths that are reflected by chlorophyll, right? So the reason leaves look green is that they reflect green light. And so this may make the plants simply look wrong to the birds, because rather than having all the different green wavelengths being reflected, where the laser is, you're only having a single wavelength reflected. So lasers have been gaining in popularity as bird deterrents. They have a number of advantages. First of all, compared to something like netting, there's very little labor required to set up or take down a laser. You basically take the laser and the power source, which is often a battery and a solar panel, out into your field. You set the laser up on, whatever you're going to mount it on, you aim it, and you're done. A single unit can cover a large area. Now, this depends on the power of the laser itself, on the crop being protected, and on the terrain. But a commercial company, Bird Control Group, makes lasers that can protect up to 20 acres in most crops and up to 100 acres or more in crops like sweet corn and probably wild blueberry, where your crop doesn't have a lot of diversity in canopy height. So in regular high bush blueberries, one of the challenges is that the birds can come in from above, they can come in from below, they can come in from the sides, because you have all of these alleys in between the rows of blueberries. If you get rid of those and the birds can really only come in from above, you can have a flatter angle to your laser beam and thus a much larger coverage area from a single unit. Another nice thing about lasers is that unlike sound, which is very hard to block, laser beams can easily be blocked. And so you can control the area of impact of the laser and limit it to just your crop field. As opposed to, for instance, propane cannons, where all of your neighbors can hear the cannon. And for instance, here in Rhode Island, what got me started on this work was problems between sweet corn growers and their neighbors over the noise pollution from their propane cannons. Unlike things like netting or scare tape, there's no interference from the laser with field access or crop management. And unlike things like bird repellent sprays, laser beams are not affected by wind or rain. Your laser's not going to blow away. The beam isn't going to wash off. They're quiet. They can be fully automated, and the movement can be randomized. And they can be used as part of an integrated bird pest management strategy by combining lasers with auditory distress systems, or auditory deterrent systems, whether that is bird distress call systems, predator call systems, propane cannons. You could also, for instance, combine the use of lasers with the use of professional falconry. So hopefully, if you can click on the play button on this, it's just a little video showing the URI laser scarecrow that we developed at work in a cornfield. So you can see it's all contained within a bucket, solar and battery power, and you can see the beam there moving across the corn. This was filmed, as you can tell from the sky, right at sunset, so the light was fairly low. But as I said, the birds will avoid these protected fields even in the middle of the day. And the lasers can be programmed to shut off automatically at sunset. So, once it gets dark enough that the birds are no longer being active, the laser will shut off, and then it'll automatically start up again at dawn. Okay, so I just want to give you some ideas of what the options are out there if you want to try laser scarecrows. Right now, for outdoor agricultural use, there are really only two automated options. There are some companies selling handheld units, but the automated options are basically limited to Bird Control Group, which manufactures and sells the Avix Autonomic Mark II. They sell it both directly and at least in recent years, they've been selling it through a number of distributors as well. And as I mentioned, that can cover 20 acres or more per unit. The downside is that they charge a lot for it. The current price, $15,500. That includes them coming and installing the unit in your field and programming it for you. And of course, once you've paid that, the unit's going to keep working with no additional cost for at least 5 years, probably longer. The lasers themselves have a 5-year use life, but that's assuming 24/7 use all year round. And of course, we don't use them that way in agriculture. And when the laser wears out, the Bird Control Group unit is designed so that just the laser can be replaced rather than the whole thing. Some cost analyses out in the Pacific Northwest on high bush blueberries found that as long as the area you are protecting is at least 5 acres in size, the Bird Control Group units are economically reasonable. In other words, you'll recover more savings from the reduced damage than the cost of the unit. For smaller growers, however, or growers whose fields are separated by lots of trees or very uneven ground, rolling ground, getting 5 acres protected with a single unit may not be possible. And so we developed the URI laser scarecrow, which is still an experimental device in that we haven't found anyone to actually commercialize it yet. But we are making it available to growers at a cost of $800 for a fully assembled unit. We won't come and install it though, that's up to you. I will note that while we have tested these units fairly widely in sweet corn, which is what they were developed for, we've done a lot less work in blueberries. We are currently seeking grant funding to do more work in blueberries, but to date, they haven't been tested on anything larger than an acre in blueberries. Also, at least for high bush blueberries, and we haven't done any work in wild blueberries, we recommend that our unit be combined with a bird guard distress call system so that you're using two different modes of action and doing an integrated pest management. And this is partly because that second mode of action, the auditory deterrent, helps to prevent birds sneaking in from the shadows where something like, say, a blueberry bush has blocked the laser beam. And so you've got an area that's not actually protected. You know, using the two different methods really helps with that. Okay, there are some potential issues with lasers for any crop, and including blueberries. First of all, while birds become habituated to lasers much more slowly than to most other deterrent methods, and the folks at Bird Control Group actually claim on their website no habituation, we have found in controlled studies with captive birds in an aviary, so a space where they're free to fly around but not fly away, that over a long enough period of time, you can get a certain degree of habituation. In blueberries, this is most likely to be a problem for growers such as the pick your own growers down here in Rhode Island, who are growing high bush blueberries and mixing together cultivars with a lot of different maturity windows so that they have blueberries in their field from early in July until well into September. It's less likely to be a problem if you have a shorter harvest period. Another issue, and again, this is primarily a problem for growers doing pick your own, is that all of the lasers currently on the market use class 3B lasers. And the US FDA considers class 3B lasers to pose a non-zero risk of eye injury if the beam directly impacts the retina of the eye for sufficient time. And so what this means is that you may have to post warning signs around your field, and you need to turn the lasers off when you pick customers or in the fields, mostly, you know, just to protect yourself, because if someone were to develop vision problems in the future, you wouldn't want to be held liable. It also means that if you have workers who are working in the field when the laser's running, they should be provided with laser safety glasses. Laser safety glasses are not really any more expensive than other types of protective sunglasses. So it's not a huge cost. Also, lasers have been shown to work really well against flocking birds. We've done most of our research with European starlings. We've also seen really good results with red-winged blackbirds. There have been good reports from cedar waxwing, people using them on cedar waxwing. They're used against seagulls, particularly at like airports and industrial sites. They work really well against Canada geese, but they don't necessarily work against birds such as catbird, where you're dealing with only a few and they act as individuals rather than as a flock. And this is partly because a lot of birds that are flock forming will set sentries who are at the top of the canopy. They're watching while all the others in the flock feed. The sentries will see the laser. Birds who act as individuals tend to hide more in the foliage while they feed, and they may not actually perceive the laser. And then, as I mentioned, lasers are line of sight, so you can get issues with shadowing. And they will not cover as large an area if, for instance, you have slopes or rolling terrain, unlike an auditory distress system or a propane cannon system that's not affected by shadows. Okay, so that's really what I have, and I'm sure we've got quite a bit of time left, or at least some time left. So if you have any questions, I'm happy to answer them. And I will say this is weird not being able to see any of you.
Sorry.
It's okay.
Has there been any results with lasers on other animals other than birds?
Okay, so that's a question I always get. And lasers do not work well with mammals. They also don't work on insects. So, and the reason for that is that, of course, most of our mammals that are going to eat our crops do not rely on vision as their primary way of detecting predators.
There been any research on wild turkeys?
So there's not been any formal research on wild turkeys. I have had some farmers using laser scarecrows to keep wild turkeys out of melons with success. But yeah, most of our research has been in corn, and wild turkeys, we've mostly been looking at protecting the maturing ears, because that's the biggest problem for sweet corn growers, and wild turkeys aren't really a problem at that stage.
They are here.
They actually did research here. I remember going to this meeting like 20 years ago. There was research done that at the end, they determined that turkeys, even lots of turkeys in your blueberry fields, don't eat a lot of blueberries. What they do is they eat insects.
Yes.
They really don't. That was like $2 an acre's worth of blueberries was all that they, and this was like with cameras and stuff. It was when turkeys just started to really come on here in Maine, and we have lots of turkeys in our blueberry fields, but the research that they did indicated that they're eating bugs, they're not eating blueberries.
Well, let's see, the blueberries at night with here.
Yeah.
They would come in with that night and they would just pounding off the tops.
Coyotes eat blueberries, you know, but not, I guess the turkeys, we just have kind of made our peace with it because they are eating bugs that we want out of the field, so.
It can be a food safety issue, for this month, food safety.
Yeah, you're right, you're right.
All right, any other questions? All right. Thank you so much, Rebecca.
Sure. And if anybody else has questions, my email is there, and feel free to reach out to me.
Perfect, thank you.
All right.
Okay, as mentioned, they saved the best for last, of course. So I'm going to talk to you about wild blueberry disease research, and it's actually much longer than 2024 to 2025, but I will kind of sum up what some of our experiments have been in the last year and what we're doing next year. Okay, first I want to acknowledge all of my students and workers in the field. So I've got graduate students, Zoe Kashav, Nihita, and Alex Shirsi, who are here. I don't have a good picture of Alex. I need a picture of you, Alex. And Zoe graduated last year, and All the rest are continuing this year. I also had Margaret Roberts was my research assistant for 2 years, but she's decided to go into the art fields. So I now have a new research assistant. His name is Garrett Harsh, goes by Harsh, and he unfortunately is, well, he had to fly away for a family event, so you will meet him later on in the season. He will be out putting out bumbleberry plots and doing other things. So I also just like to thank all the blueberry growers, and our funding comes from Wild Blueberry Commission and also Maine, especially crop grants that come from the federal government through there, and MAPHIS, which is also supported by the federal government and state. So we have lots of diseases in the field. We've got things like good old mummyberry, powdery mildew, spirulina leaf spot, rust. This is Valdensia leaf spot, which fortunately we don't seem to have a lot of that around anymore. Has anybody seen any of that recently? Good. I'm really glad to hear that. So a lot of these things to protect and to get rid of them is some of the cultural methods that we use. Pruning is helping. Flail mowing may help by disrupting, it definitely helps by disrupting the mummyberry life cycle. The mummyberry life cycle needs flowers and fruit to be able to complete its life cycle. So because we're not in a 3-year cycle, we can't build up as many mummies. And if we just left it go, we'd have many more mummies. Except it's also proportional to the number of flowers. It's probably increasing the debris layer, which could be burying diseased tissues and things like mummyberries, as we've seen with some of our mulch studies that Lily and other people have done. But the other problem is it can also insulate these fungi against cold temperatures. And so it can actually protect them from drying out and or getting too cold and freezing. The broil will freeze, but maybe getting not so cold that they actually have damage. So burn pruning is still the best thing, as I think somebody else mentioned with organic fields. This is still the best way to get rid of decreasing the number of mummyberries. We know that works. And also it kills off infected leaves and stem tissue. And that will decrease your amount of disease, as well as effects it may be having on weed seeds and other things. A lot of the leaf, all those fungi I just showed you, those diseases, all of them overwinter in your blueberry fields. So if you can come up with a method to decrease their inoculum over winter, such as pruning or burning, you can decrease the amount of disease. So if you have another options are fungicides. And the most what we have is all protectants, so they need to be applied beforehand. Weird things are happening. Here we go. No. There we go. They usually last 7 to 14 days, depending upon the weather and the material. But they need to be applied at the right time. And as I've mentioned to you many times, this is when the infective spores of the fungus is present. We do have viral diseases and bacteria, but they're just such minor problems with our wide variety of variation. So I may have seen the odd virus in a blueberry plant, but it's affected like one clone, and all the other clones around it are fine. So we have nothing like the serious diseases they have in high bush with viruses. So they need to have the infective spores around. So that's actually the fungus present to be able to infect the plant. We need to have susceptible tissue so the fungus can get into the plant. When the fungus, of course, when the plant is completely covered up with bud scales, it's not susceptible, for example, in the spring. And if we known, it needs to have suitable weather conditions for infection are present. And we do know how some of the conditions are for some fungi when they can get into the plants, but a lot of them we're still working on in my lab. So some of the ones that are, keep hitting my button. We do know the infection conditions for mummyberry on the left and for botrytis blossom blight on the right. Now I just want to point out once again that mummyberry not only kills leaves, but it also kills flowers. So you can have dead flowers that are due to mummyberry, and you could have, or dead flowers due to botrytis, and there's also frost. When you look at botrytis, hopefully you can see this, you'll see these little things sticking out of the flowers, the dead flowers, and most of them are opening or were partially open. That's typically when botrytis hits, and mummyberry usually hits and it kills the flowers before they open. So if you see flowers that aren't open, there's probably mummyberry. But we do know from research that was done in Nova Scotia, and we've translated here, that, for example, mummyberry disease, we need to have the cups present, which is why we put out mummyberry plots. We need to have successful leaf and flower buds, which is why I ask you to please go and look at your plants before you spray. And also we need to have suitable rain and fog conditions. And that means it has to be long enough to cause infection. So one of the ways we're still doing this is we're putting out mummyberry plots, and this is a plot up here, 20 to 30 mummyberries, and like Phil's thing, we try to put out at least about 3 as possible in a field, because we do find, even though we pick spots that we think, oh, this will work, it turns out it's a runoff area, or it's a big frost heave right in that area, or something happens. And then you get the cups and the different swips. You get the cups coming up in the spring. Now, we need more mummyberry plots out. We definitely do not have enough to really cover the area that we're covering right now. And so we, if you do get mummyberries in your field in harvest, please grab a few and put them out in the field that's pruned that year. And of course, put on stakes to mark them. And there is some sheets up on the extension website to show how to put out a mummyberry plot. And I'd also be personally glad to come down or have somebody come down and show you how to do it. But it's really a good thing to know what is happening in your particular field. See if this works. Oh, much better. So we put out weather stations too, and we have 14 that we're putting out right now. But as Lily was mentioning, we're going to have a mesonet out soon, which hopefully will be also providing this disease forecast and other things in the future. And this is where we've had our weather stations and our mummyberry plot outs last year. So you notice there's areas that have gaps. Oh, there it is. Right here, we don't have anything. We don't have anything down along here. We don't have anything up there. And we just don't have any plots that people were able to put out or have anybody who's willing to go look at them. And this is where we were able to put out plots this year. We didn't have a lot of mummyberries to collect. So we ended up putting plots out in the some of the more heavy areas where there's blueberries. But again, we still have some gaps along the north side and of Highway 9, and then also Liberty and that sort of area. So putting out more plots is always a good idea. So we have the mummyberry and disease reports that are up here, and botrytis reports that are up on the Wild Blueberry Extension site. And also you can get an email for that. I'm sure a lot of you know about this already. Does anybody already know about this? Some of you do. So what this is I send you emails and or something up on the web to tell you if you apply fungicides for mummyberry botrytis, that now is there's going to be a risk of it, and you should be thinking about what to apply if you have that option. It's also available on your phone. If you look up the AgriNet app, you'll find this symbol, the circle, green circle with the spots, and that's where you can get the app on your phone. And you can also get it on a computer if you use the Chrome browser. And this is the login. You'll also see this and links on the Blueberry Cooperative Extension site. And this is the kind of information you get. You get a map, and then if you go up closer to it, you'll see certain weather stations and what the conditions are. We get the leaves are dark if there's mummyberry infection. Black is for botrytis risk, high botrytis risk. And right now it's telling you if it has a temperature below 35. So a lot of these aren't sending any cellular signal, and so they don't worry about that. It comes up every 10 minutes, it usually sends a signal. The reason why we have it at 35 degrees is that if it's 35 degrees or below, then it's probably a good chance that some other part of the field will be colder. So that's why we've kind of used that measure. So we do a lot of fungicide efficacy trials, and typically with mummyberry, we're applying 2 applications. We're following the mummyberry forecast method I just mentioned. And leaf spots, we're usually doing 2 timings, early June and mid-June, and that's because we don't have exactly figured out what the weather conditions are that cause infection. And usually that's only 1 application. So we need to have good results over at least 2 years before I will recommend something to you. And these are our trials from 2023, where we tried a bunch of different things. You can see the negative control was about 30% of the stems had infection. Tilt was quite a bit lower as our standard, which a lot of people use. And we tried some other things. These are regular fungicides that had equal control or better control than tilt. And then we also had this organic material, which really didn't work well. And so these 3 things here, this was the 2nd year where we had good results. So you'll see that they're now on your fungicide recommendation. And this one, Luna Sensation, we retested this year, and also another material. And Luna Sensation had really good results again. This is our negative control, actually had closer to 65% disease. So Luna Sensation worked well. It's now recommended. This is a new material that's not registered yet, and this is our 1st year of trying it, and it worked really quite well. There was no significant difference between how well it worked at the lower rate than the higher rate. And we will be testing this year. From this last trial, we had this problem with the Eco Swing and capsule, and so we ran a trial to just see, is it the capsule? Is it any kind of adjuvant that's causing a problem? Like maybe just having adjuvants might be causing disease. And so what we did was we put together this small trial where we had untreated control, capsule by itself, Eco Swing by itself, Eco Swing with capsule, and Eco Swing with a common or dynamic adjuvant. And we didn't see any significant difference. So we don't really think the capsule itself is causing the problem, but we don't think Eco Swing is doing anything either. So we really don't recommend either one of those. So the current recommendations this last year is we have Luna Sensation as additional material, and Eco Swing is really not effective. And I also cannot recommend you use capsule as a possibility. And we'll be testing this at least this next year. So these are some fungicides that we have recently tested that are more newer materials. And these, as you can see, we've tried them mostly for mummyberry, because that big problem with mummyberry is we tend to have a lot of materials that are in group 3. Proconazole is in group 3, prothioconazole is in group 3, Civia is in group 3 too. But we now have some other materials that are at least mixtures. This should have a slash, sorry, that should be 2/9, and things with other types of active modes of action on fungi. So if you have a lot of mummyberry and you're spraying tilt and proline, which is prothioconazole, you might want to consider putting in something else in here too, something that has a different mode of action, just to kind of break it up, because the concern, of course, of spraying constantly with the same mode of action is causing problems. Now, we have tested some of these for fungicide residues. So these ones, we haven't found anything. Moravis Prime, Inspire Omega, Super and Omega. Provia, we used the Canadian info that showed none. Civia, we checked it, we saw no residues, but then they also didn't have a test for it yet. So we're going to rerun that again. And these other materials we're going to run and check for, hopefully get some funds, and we'll check for their residues this coming year. When you look at costs, unfortunately, all of these things are more expensive than tilt. it's still the leader in price. Sivia would be another possibility. And Proline is also, does work somewhat on wild mummyberry. It definitely works well on leaf spots. And you can see these other things go up in price, unfortunately. So that there's still some things that might be worthwhile to regulate in if you have a big concern over mummyberry. Now, while I've been testing conventional fungicides, I have also been trying to find an organic fungicide, as Carrie keeps asking me, that works on mummyberry. And this is what I've tried. We've tried since 2017, and we haven't found anything that works well. This is the problem with mummyberry, is we're trying to control it at the stage when the leaf and flower buds are expanding. And a lot of these things are protectants that just coat the leaves when they're sprayed. And so by the next day, there's new leaf tissue, there's new flowers tissue exposed. So we have tried all of these, and unfortunately, none of them have worked on mummyberry. The few that we also tried on leaf spots, we were thinking that would work better because leaf spots, you know, the leaves are open. They have a surface area, we can spray on top of them, that will work. And again, they didn't really work all that well either, not enough for us to recommend them. So we're still going. If you hear of anything that you'd like us to try on either for leaf spots or mummyberry, I'm very happy to try it. And I'm constantly bothering people to try to come up with something else we can try. Right now, burning is really the best control for organic blueberries if they have mummyberry. So some notes on the fungicides from 2025. You've probably heard already that chlorothianol, which is Bravo and Equus, is proposed to have its registration revoked in European Union and Japan. Not yet, but probably. So a lot of people won't take any berries that have been sprayed with this for that reason. Buconazole indar is also on that list to be revoked, but in the USA. So I would suggest not using that. A lot of people, I don't think, use that anymore. It's quite an older fungicide. There's also the PFAS. Yeah, that's a better way of saying it. List at the Maine Board of Pesticides. That's constantly changing. But I did look yesterday. Yep. And all the recommended fungicides that we are a recommendation are on there, except these. Captivate, Puntellus, Indar, which you probably wouldn't use anyways, and Quilt XL. And so anything, I would not recommend using Bravo and Equus either. So most of the things that we've got on there are already okay with the PFAS. They have registered their formulation, and so it can be used. But of course, always ask whoever's buying your fruit what you can apply, because they may have different markets where you need to narrow things down. So after fungicides, I just want to present a little bit about what my students have been doing. They've basically been collecting a ton of data, and now they're trying to go through and analyze it all. And I actually just hired a statistician to help them because it's so much data. So Kashav Bagal is one of my PhD students, and he has a bit of data to present. He was looking at warming chambers and its effects on leaf spots and the blueberry plants. And he had two major treatments, was either a warming chamber or an open plot. And then each type of plot had, within those plots, had a following treatment, either fertilizer, that should be fungicide, biochar, or control. And so over 2 crop cycles, he's got data from 2023 to 2024, and he's going to do 1 more crop cycle. So this year is the prune year. So this is what his setup looked like. So these, of course, are the spaceship treatments, and he's got temperature sensors inside. This is the heating coil around it. And then he also has plots that are replicated, the different types of materials to apply biochar, or fungicide, or a control. And each of these is in 1 clone. So we have 6 clones in total. So we found that the temperature was significantly warmer in the warming temperatures, but not as much as they have been in the past. The relative humidity was a bit lower in the warming chambers than in the plots, 4.2%. But he found no effect on leaf spot diseases. So we didn't see any difference between leaf spot diseases in these chambers. And we also did not see any effect on leaf loss. We are continuing this the next year to see what the effects are with 2 years. We've never actually had these things going over winter and also continuing on to a second year in the same spot. So this is the first year we're going to do that. So he did have some results from yield, and this does follow what has been found in the past, where there is a higher yield in the warming chambers compared to outside. And exactly why this is occurring is still kind of to be figured out. It does appear the sugar content in the open areas are slightly higher than that in the warming chambers, except for this one plot. So the control and the fungicide plot had slightly more sugar content, but they're all very, very similar to each other. And it was kind of the reverse for acidity. And what was also interesting is a result with biochar. We have been trying different types of biochar. The last results using these warming chambers to see that biochar seemed to improve soil moisture, or at least help the plants keep soil moisture. They use biochar equally mixed with with compost. So it's hard to know which was having the effect. So this is a biochar that is just simply biochar sprinkled on the surface of the plants, of the ground. We didn't try to mix it in or anything like that. And this was measurements taken in September. He was taking measurements of soil moisture only after at least a week of dry weather with no rain. And he did see the biochar had higher soil moisture than the other treatments. So there may be some effect. We are going to continue this again, of course, till next year. And Jean Zhang has a bunch of students who are doing other trials with biochar and mulch, and they will have more information too about this. So for our projects in 2025, we will be doing fungicide efficacy trials. We will be testing for pesticide residues. I will be putting out mummyberry stations, or Harsh will be. I'll be going out with showing him how to do it. And then hopefully he'll be doing it. Shaun is going to be continuing. He has a big trial looking at fertilizers and fungicides on leaf spots that he's analyzing. And he's also got data for next year. He's going to be continuing to look at the warming effects of blueberries, not just one blueberry. And he's going to be identifying fungi that occur in blueberry leaves. So we're going to see what's inside the leaves beside diseases. Because some plants have endophytes. These are fungi that live inside leaves. And oftentimes they can actually protect the leaves against different types of other fungi. So we're going to see what else is in the leaves. And these are leaves that he's taking surface sterilized. So he's gotten all the fungus and everything else off, hopefully off the surface. And we're really just going to be looking at what's in the leaves. And that's never been done before. Nahida Kabir, she is also working on effects of fertilizer and fungicide combinations on mummyberry and how plants recover from mummyberry. And she's also going to be starting some red leaf experiments. Basically, how does it spread? How can maybe we can decrease the amount of red leaf in our fields? And now let's, Serge is working, as Rachel mentioned, she is working on the effects of warming and different levels of precipitation on mycorrhizae colonization and pollination work. So we're going to be very busy this year running around in the field. And one of the things that we're forgot to put on this list is we're going to be trying to look at disease levels in whole mulched fields. So if you have a field where you completely mulched a field, I'd like to come and look at it. And particularly if you have nearby a field which you haven't had a chance to whole mulch yet. We want to see what are the long-term effects of mulching. As Lily was presenting this morning, we often see initially the first year, we see a drop in disease. And we want to see, is that a continuation afterwards? Because covering up all of the diseased tissue should drop the levels of disease. But then the problem is the mulch making a better environment for the fungi to survive till the next year? And that's what we want to try to start looking at, is what are the long-term effects of doing this sort of mulching? So if you have anything like that, please contact me. And that's all I have. Anybody awake for questions? Yes.
Talking about the blueberries themselves, when they come later, are you testing the blueberries for residue, or are you testing the whole plant?
I'm testing the blueberry. I am testing the blueberry fruit when we harvest. Yeah, so I'm collecting the blueberry fruit when we harvest. From all the different plots, pulling it together and sending it off to be tested. Yeah.
I mean, you spray fungicide really early, it's amazing.
Yeah.
that-
Oh, we didn't detect anything. We saw no detection of anything. Yes. Yes.
Mummyberry report.
Yep, so Mummyberry report is still going to be on by email, on the blog, and also I'll make a recorded phone message. Yep. Any other questions? Okay, thank you very much for your attention and have a safe drive.
All right, good morning, everyone. It's about 9, so we're going to get started. Kicking us off is Nathan Bieber, the Maine Department of Inland Fisheries and Wildlife, to talk about deer management programs. Let's give them a round of applause.
Thank you all for having me. As she said, I'm Nathan Bieber. I'm the deer specialist for Maine Department of Inland Fisheries and Wildlife for 7.5 years now. And I'm going to talk a little bit today about a program we're developing called the Deer Management Assistance Program, or also a DMAP, is how I'll refer to it throughout this presentation. So what is a DMAP? A DMAP is a Deer Management Assistance Program, and it's a very small-scale deer removal option that's used to facilitate meeting site-specific deer removal goals. So you think of deer management and what we do as a department, and most of our management occurs at the wildlife management district level, a much larger scale, sort of broad brush approach to achieving the sorts of deer numbers we're looking for. But a DMAP is for a much smaller scale, specifically for the parcel scale. And DMAPs are most often associated with the southeastern United States, where they were originally created, but as of 2021, around 20 or so states had DMAP programs or DMAPs, and a few provinces. While all these places do have DMAPs, every DMAP is just a little bit different. There's no one size fits all or template for every DMAP program. They're very flexible and they can be tailored however you need for whatever needs your jurisdiction is facing. Typically, progress towards DMAP program goals is met by issuing property-specific permits to remove antlerless deer. So again, most of our permits are issued for the wildlife management district level, where a hunter receives an antlerless permit and they can take an antlerless deer within the district, which in Maine is anywhere from a few hundred to a few thousand square miles. A DMAP permit, however, allows you to remove deer from specific parcels. So you can try to adjust very locally your densities to help achieve whatever your management goals are. In your case, probably alleviating pressure on blueberries or whatever crops you may have. While all DMAPs are different, they kind of fall into two different categories. There's firstly a category of DMAP programs that's seeking to address issues of deer-human conflict, so situations where deer are exceeding social or biological carrying capacity, things like habitat damage, crop damage, a lot of deer vehicle collisions, things like that. And then there's sort of a second category of DMAP, which is not really the category we're looking at here for Maine, but this is where you work with private landowners who have custom deer management plans. And maybe a landowner has a few hundred or a few thousand acres and they have custom deer management goals in mind. Maybe they want a very balanced 1-to-1 sex ratio, and very advanced age structure of bucks who would work with the wildlife management agency to achieve those goals. So that's sort of a second flavor of DMAP. But here in Maine, we're mostly going to be focused as we're developing this program on the conflict end of things. There's some other common elements amongst DMAPs. These include that the DMAP permits are to remove specifically antlerless deer only and during the regular hunting seasons. Any deer that's removed on a DMAP permit needs to be registered or in some way reported with an end of season report or report card, something like that. There's often a restriction on the number of permits that are issued for each property based on the size of that property, what the specific land use of that property is, or maybe some other insights that were gleaned when we were consulting the landowner that's seeking these permits. And then the DMAP permits can either be used by a landowner to remove deer from their property, or they can dole them out to friends or family, or if they don't know someone, we can help match them up with hunters who are interested in removing additional antlerless deer from specific properties. And unlike our antlerless deer permits, these are free permits. We really want to take advantage of these and use all the permits that they get. So what might a DMAP program look like in Maine? Anytime we're looking at putting together a new program, I think it's important to ask ourselves, what is the problem that we're trying to fix here? What are we trying to improve upon? What is the point? In my mind, three things occur to me that could be not necessarily solved, but helped with the DMAP. And these include data collection, availability, and reporting, specifically as it relates to deer that are killed in conflict situations. Currently, a deer that's killed on, say, a depredation permit, I never know if that permit's issued or if the deer's been killed. It's just not information I have. And I think a DMAP could help us to gather some of that information up so I actually have access to it. Also improve customer assistance by providing some additional removal options and some other assistance with human conflict issues like fencing assistance and deterrent assistance, things like that. Would improve customer service. Also, we'll have sort of a couple people that will serve as point people for human conflict related issues. So rather than one grower seeking this person out and getting this advice, and the next grower getting this advice from a different person, we have a couple people to which we would funnel requests so people are getting consistent information and they know who to contact. And lastly, private lands access has always been an issue in Maine. It dates back many decades. Seems like every now and then it flares up again and becomes a hot topic again. But much of our deer management does rely on removing deer for the hunting season, and don't have access to land, and that becomes very challenging. I think a DMAP could help us improve land access a little bit, and I'll touch on each of these things in a little more detail in the coming slides. On data collection, availability, and reporting, a lot of you guys have probably got depredation permits for your farms and have people with deer outside of the hunting seasons on depredation permits. Stuff I never hear about. I don't get that info, and I would really like to have that info. So part of this program, which would probably come a couple of years down the road, be mandatory reporting for a registration system of any deer that are killed on DMAP permits or on depredation permits. We're currently slowly inching in the direction, as many other northeastern states have, of offering online self-reporting of killed deer. Rather than take your deer physically to a check station, report it on your phone. Once that's in place in a couple of years, I would imagine maybe 2 or 3 years, my hope is that we can have people who kill deer on depredation permits just register their deer to that online system so they have access to those data. And then while depredation permits are used outside of regulated hunting seasons, DMAP permits would be used during the hunting seasons. So they would be subject to all of the normal restrictions and requirements of a hunting season. We have to register those deer normally. So currently, if we issue DMAP permit, so if you're on that DMAP permit, you'll have to register it, so I will have access to those data. That makes me happy because my job is very data oriented. When I don't have certain data, it makes me a little cranky. On customer service, a lot of people with deer problems, they oftentimes don't know what their options are, or they don't know who to contact for help, or sometimes they get inconsistent information by reaching out to different people who tell them different things. And sometimes they just lack the means to address the problem. So there's a lot of proposed solutions to kind of help with this. It's an issue that goes back hundreds of years. There's no one set of program criteria or whatever that's going to solve all these problems, but I think these things will have myself, and we now hired as of I think December or so, wildlife interactions biologist. So she and I will be kind of point people for deer conflict issues, and all these requests for deer damage and things like that will be funneled to us, so that hopefully you know who to contact and get consistent information. We're also developing a landing page on our website that's going to pull together all of the information that we have on different ways you can address human conflicts. So we'll have issue from our dealing with wildlife page, the living with wildlife page. We'll talk about DMAP permits and how to get those. It'll talk about cost sharing for fencing and things like that. Bring all these resources together in one place so that it's kind of a one-stop shop. People who don't know what the best approach is for dealing with the problem that they're facing. And lastly, as of like 2 years ago, a bill was passed that doctored our deer management fund a little bit, or adjusted our deer management fund statute. The way it worked prior is every deer that was registered from the hunting season had to pay $5 to the registration station. And $2 of those went to our department to different funds. $1 went to habitat work and the other went to a predator management program. As of this change a couple of years ago, those $2 for every registered deer are now allocated towards deer-human conflict issues. So we've had on the books a very long time a statute that said we would cost share for fencing if people needed help paying for their fencing. But we never really had funding to do that. So this is a small pot of money, but it gets us started so that we can start cost sharing for fencing some of the landowners who have an issue that may be addressed with fencing. Probably not applicable for very big farms. We're dealing with tens of acres, but for smaller organic grows and little fields and things, we may be able to offer some assistance in their short fencing. And then on private lands access, a lot of the issue is countries just don't know where to go. There's a landowner who needs deer removed from their property or would like deer removed from their property. They don't have a way of knowing about that. So we're hoping that we can put together a system that'll be integrated into the web page that will offer some sort of matching assistance where if a landowner opts into this and wants to say, I have this property in whatever town, I have these free permits available, here, Hunter would be able to search through that list and see if anyone nearby has permits available and they can match up with that landowner. It's to hunt that way. Ultimately, though, this kind of depends on landowner buy-in. If we don't get feedback from landowners that they're interested in this sort of thing, it makes them nervous or whatever the reason may be, we may not end up integrating this into the web page, but if we do get the sense that there are tens or dozens at least of landowners who are interested in participating or some acreage threshold, we'll work on doing this. We kind of have a, what was the hunter sort of thing on our website where we can match landowners with land users who want deer removed from their property. We already have a lot of things in place that can be integrated into this effort. There are some things we still have to work through, but we already have in place depredation permits, which is where we offer assistance to landowners who are experiencing issues with deer browsing on their crops or causing property damage outside of the hunting seasons. You can work with wildlife biologists from our department or with game wardens to get depredation permits, and they can essentially set you up to remove deer that are causing problems as the problems are occurring. You've got deer browsing your beans, whatever the case may be in June, there are options to remove deer. We also have what are called special hunts. These are administered at the town level. If the town is experiencing town-wide issues with property damage or whatever the case may be, they can actually administer a hunt at the town level or portion of a town to achieve locally lowered deer densities. We have our antlerless deer permit system, which was put in place a few years ago, and it's I think becoming more and more familiar to hunters and can be adopted to fit this DMAP framework. We have an online registration station system already to capture the data from deer that are killed on DMAP permits. And we have a little bit of funding now set up, so we could offer some assistance with deer-human conflicts that landowners are experiencing, whether that's cost sharing for fencing or deterrence or things like propane cannons that make a loud noise when a deer walks by, whatever the case may be. We have some funding to offer assistance now. And through our landowner relations program, the Warden Service, they have kind of their own fencing program, which is more of a loaner program. We do have some in-house knowledge of fencing arrays and how they work, what setups work well, and what costs are associated. So we have some of that in-house knowledge to start deploying fencing right away, which we have as a total stockpile. But we are missing some pieces yet. As I mentioned, we're missing data collection, basic data collection from deer that are killed, both on depredation permits and near future on DMAP permits. DMAP permits will be easy because they'll have to register their deer, but I think the data from deer killed on depredation permits, that's going to be a few years out when we do that online system of self-reporting. We also have to set up a registration system so it will recognize a permit that is issued to a landowner, a DMAP permit. If someone is given, if a landowner is given DMAP permits and they want to issue that to a hunter who's going to come hunt on their property, we need our registration system to be able to recognize that permit. So we have the specs into our registration system company right now, so that hopefully by this season it will be able to recognize DMAP permits. Hit the ground running with that. We have a draft of a web page that's going to bring together all these deer resources. I've I've got a timeline, I think, later in this presentation, but I'm hopeful that that'll be up in spring. And similarly, I'm hoping soon we can sort of add to that webpage some resources for landowners and land users or hunters to match up if they're landowners that need to remove from the property but don't necessarily have a hunter in mind to do that. As far as timelines go, there's kind of a lot of different things we're trying to pull together. So the timelines are going to be a little bit all over the place for these different aspects of the program. It's not all going to come online at once. But with the draft already created at the webpage, I think that'll be live in the spring. Just a couple months we can get that up. DMAP permits being issued to landowners, that's going to be a slow rollout. I'm hopeful that we can get a few landowners interested in this sort of thing this year. We'll try it out and see how it goes. And as early as this summer, we'll be able to issue those permits to landowners. Essentially how that would work is we consult with the landowner. If they have deer removal needs on their property, we may be able to get say 2 or 3 handleless permits that would be free of charge for them to provide to, could be for themselves, could be a family member or a friend, or if we can match them up with hunters, they would have free permits to try to draw hunters to their property to remove deer, specifically from the area where they're causing an issue. As far as the fencing cost sharing, I'm optimistic we can dabble in that by this year, but we'll see. It may take another year to get that in place. We're working with a couple other programs that work with deer fencing. We're working with the USDA folks. They have a fencing program. It's a lease to own program. So we're kind of working with them and the landowner relations fencing program to see how all the different fencing programs are different and how we might work together and synergize and who can best handle different types of requests. And then probably 2 years out is when we actually be able to start getting the data from the deer killed on depredation permits, the deer killed outside of the hunting seasons. That would run on the same timeline as whenever we get our online self-reporting deer up and running. And then lastly, the landowner land user matching aspect of things, that really depends on interest. If we don't get a sense that there's an interest in this sort of thing by landowners, we probably won't integrate that into the webpage. But if we do get feedback that hunters and landowners are both interested in that sort of service, we'll get that online. Now, timeline for that will just depend on when we sort of match that critical threshold of interest where we feel like it's worthwhile and put the service on the webpage when there's one landowner confident that the program that would be worth it. So in summary, we're looking to repackage some of our existing deer management tools that we have and add some new parts and bring them all together sort of under one umbrella, which is going to be our Deer Management Assistance Program, or DMAP. And hopefully by doing so, I can get some better data on deer that are killed in conflict situations. Maybe we can improve customer service as it relates to deer issues on farms. And we can also improve land access for hunters who are looking for a place to hunt and some additional removal options. Small parcels who need deer removed.
And then you would want to consider mulch. So once your weeds are under control, you can apply mulch. If you're putting on a granular fertilizer, it does make sense to put that on the ground before you mulch. We haven't studied yet, how quickly nutrients can get to the root zone after you mulch, which is a big question. I think it would be a bit slower. So here's our 2024 team, and I just want to thank them for all of their work in putting this, all this work together. Hey, can you close the door up there? Oh, it's Paul. Chatty Paul, thank you. Thanks, Paul. Okay, so we do a ton of work on Rhode Blueberries. This is a list of the projects that we have done in 2024 and will continue into 2025. We've been doing a nitrogen rate study, a mulch thickness study, and a phenology tracking and reporting in live real time. We also did a shade study, and we are studying mulch and biochar, comparing the two for their moisture holding capacity and nutrient holding. We're also doing a drone spot spray project. A graduate student doing that. She's giving a presentation today about it. We got a large grant from federal government to install a Maine mesonet. And the Maine mesonet is going to be a network of weather stations across the state of Maine. And these are scientific grade weather stations, and they're actually going to improve your forecast, which is amazing. But it's also going to bring you the ability to predict when the plants develop to the next stage. And you'll be able to use decision support tools, which means like you could go on to the Maine Climate Center office website, and you'll be able to select wild blueberry and then blueberry maggot fly, and then you can see, it'll do a bunch of calculations, and it'll show you, okay, I need to put out my traps this week to capture the flies that will inform me when I need to spray. Things like that. It's a decision support tool. And they'll be across the state of Maine. We're aiming to install the first round of them this year, but installation will continue into next year. And we also have a transition to organic project where we are creating more educational materials. And Leila here is one of my new employees. She's new to our team, so if you're able to introduce yourself to her, that would be great. She is from Maine, but moved from Wyoming. So welcome her back to Maine, please. So this year we had a total of 15 on-farm collaborators, which is amazing. And we cannot do the work without farmers. The work we do would not be relevant without them. So thank you. And we will continue to work with you as long as we can. In 2024, we hosted 8 different events, and we had about 300 attendees. And I received 95 email or phone consultation requests. Just so you have a sense of the number of people we work with. Okay, so now I'll start talking about weeds. And you need, as I mentioned, you need to have good weed management before you consider applying fertilizer. One weed that we're really having a problem with right now is fine leaf shoot fescue. This is the grass. It's a bunch grass, and it spreads very quickly across fields. And it has been present in Maine at least since 2012, but I'm sure David saw it earlier. And we now see fields have been taken over by this grass across the state. It was just in down east for a while, and now it's definitely in mid-coast as well. So it's native to Europe, and it was introduced as a turf grass, but it has spread into agricultural fields that are well-draining soils, kind of sandy soils, are exactly what it likes. It is drought tolerant. It grows well in nutrient-poor soils. It can handle close mowing. These are all things that point exactly to our wild blueberry environment. And it does prefer soil pH of 5.5 or greater. And so that is where we can nail this grass. Or some. I have heard that some fields do not respond well to soil pH changes or the addition of sulfur. So I'd like to try to figure that out. These are more pictures of the grass. And so on the top left, you can see a picture in June, and it looks like a darker grass in June. But then as it dries out in August and September, it's really a field of white. It looks kind of snowy. So there are still blueberries underneath. It's not completely lost, but it's definitely competing with the blueberry for nutrients, water, sunlight. And so the herbicide options that you can use are really fall management. Fall weed management is really critical for this weed. Curb is one product that you can use that works well. It needs to be applied in the fall, and the window for using this product is narrow. You have to find the right conditions, which is when air temperature is 55 degrees or lower. And glufosinate rely is another product that works and is labeled for our use. You can apply this one in early spring or in the fall, late fall. But it will delay blueberry emergence the following year. It hasn't gone dormant yet, especially these years where we've had warmer fall conditions. And so the grasses keep growing. All these weeds keep growing. And last October, you know, I was out in fields and it was still green, you know, they're still growing that time of year. And it's, even our blueberries are still green. You know, we used to have leaf drop in October, probably in September, way back. And it's just not happening anymore. It can be November by the time they really go dormant. And we also see fall bloom quite a bit, which is another indication that the blueberries are still active. So you know, often I see wild blueberry growers, you're exhausted. I'm exhausted too after harvest. Are you kidding me? You're gonna make me go out in the fall? This is our only break. I totally get it. But it is really a timing of the year that we're gonna have to focus on. Because you do have your blueberries in and it is a good time to get out there. That answers your question. All right, another product is diuron is the active ingredient. We have two different trade names for diuron. One is diuron and one is Carmex. These are also labeled for use on blueberry in Maine. So you are legally allowed to apply these. We have not tested it yet, but I'm hoping that the Wild Blueberry Commission will give us funds to do that this year. But they did test it in Nova Scotia with good luck, where they applied it in early spring. And I have heard that you can also apply it in the fall after harvest with good success. So fall weed management is something to start to wrap your head around. And the other practice that you should really employ, whether you are organic or conventional, is soil pH management and reducing your soil pH. So Paul Sweetland is a grower in Mid-Coast, Maine, and his assistant Mary and I went out in Mid-Coast to test soils of different fields this fall. And I'm going to show you a series of photographs, and each indicates the soil pH that was determined. And so on the left, this field, this is an organic field on both sides. And on the left, the soil pH was 4.8, and on the right, the soil pH was 4.0. And so it's pretty clear here that there is no fine leaf shoot fescue where the soil pH is low, and it is very present where the soil pH is high. Again, different field. This is a field where you can see that somebody did apply sulfur, but they missed sections. And so the sections that did receive sulfur are at 4.3, and where they did not receive sulfur is 4.8. So same situation. Again, another example. On the left, this is another property managed by the same person. I'll put pictures. On the left, that was 4.7. On the right, 4.5. So in this field, you can see there is still fine leaf shoot fescue. There is less of it, 4.5. And last example, you know, this could go on and on. I think you get the point. The space, there's clearly strips here. And so the operator missed sections of, you know, 4.3 where there's no fine leaf shoot fescue and 4.8 where we have this grass. And here's the data in a table. Here's somebody who learns this way better. So the mean for soil pH where there was fescue was 4.8. and the mean for where there was no finely shoot fescue was 4.3. But I think, you know, sometimes we say bring it down to 4.0, but I think you can aim for 4.3 and have good control, at least in this soil that is in Mid-Coast, Appleton, Hope region. I'd like to do this in down east where the soils are different. Yeah. So how do you understand what your soil pH is? You can take a soil sample and send it to the University of Maine. The way that you do that is filling out this form and writing wild blueberry soil pH only on the form and putting soil in this box. When you take the soil sample, you want to zigzag across the field and take a representative sample. So you can use a trowel, you can use a soil probe to take about you want to go 4 inches deep and clear off the leaf and duct material from the very top and put that soil in a bucket as you go across your field and mix it up in the bucket. And then you take a few handfuls of that soil that you've mixed up and put it in this box and mail it to UMaine. The other nifty thing that you can do now is you can buy a soil pH tester that you just stick in the ground. And so the accuracy is probably, there's probably a little more error with these, but it's a really nifty tool. It would be faster than sending it to the lab and perhaps cheaper in the long run. These cost $165. I found them on Johnny's. I'm sure other people sell them too. So if you're taking a lot of soil pH samples, this would be a good way to do it. If you do go this route, I would suggest that you take multiple readings from your field. You want to zigzag across the field like you would for your soil sample, because and you want to make sure that this goes to the right depth. We're aiming for 4 inches by blueberry soil. Because if you just took one reading, soil pH can change drastically across a field. You can also test your own soil pH using different meters, and we have a fact sheet on how to do that. So how much sulfur should I apply? The product you're looking for is 90% elemental sulfur, and you're trying to reduce it to between 4 and 4.3. 100 pounds of sulfur reduces the soil pH 1/10 of a point. And so, for example, if you had a soil pH of 5.0 and you're trying to get down to 4.0, that would require 1,000 pounds of sulfur per acre, which is a lot of material. I would not recommend applying 1,000 pounds per acre. Kind of 800 pounds per acre is a good limit. And it can take 2 to 3 years to see visual progress, but that progress lasts for 8 to 10 years. And you want to apply it after pruning in the fall or the spring. You don't want to apply it when the soil is frozen, because it could just wash away. And you don't want to apply it when the soil is fully saturated with water, because it can burn the roots. You also don't want to apply it when the blueberry leaves are wet. And so, you know, it's a drier conditions that you're looking for. Okay, I did some math. I'm gonna hurry along here. I did some math. Basically, the cost of sulfur, the boom spray cost per acre is $138. The sulfur cost, if you buy bulk rainfall, costs $120 an acre if you're supplying it at the 400-pound rate. So basically, I would encourage you to do some math, understand how much it costs you to apply herbicide with boom sprayer, and compare it to your return on a longer-term investment with the sulfur. Because sulfur is expensive right off the bat, but over time, it may not. Okay, so nitrogen study. We did this nitrogen study in 2 locations, one in Cherryfield and one in Hope. Our goal here is to identify the amount of ammonium sulfate, this is a granular fertilizer, ammonium sulfate, that you would apply in addition to MAP or DAP. MAP is monoammonium phosphate. DAP is diammonium phosphate. These are the typical granular fertilizers that we apply. We're trying to understand how much extra nitrogen should we put on that would be optimum for a fresh pack operation and would be optimum for a frozen operation. Frozen producers are looking for a lot of branches and a lot of fruit per stem. Fresh pack are looking for fewer branches to make a higher quality berry. And so our hypothesis is that you would need less nitrogen for a fresh pack operation. You would need more nitrogen for frozen operation because of the volume you're trying to produce and the type of stem you're trying to grow. So these were our different treatments. Basically, we had a group of pre-emergent applied nitrogen and a group of shoot elongation applied nitrogen. So those are two different timings that you can put nitrogen on your prune field. Branching. This is just the first year of the study, but we did already see a response, especially at the shoot elongation period. You can see that there was a significantly higher number of branches where nitrogen was applied at the shoot elongation stage, and increasingly so as you applied more and more nitrogen. And then for fruit buds, we see a similar trend. It's not as clear, but certainly it was significantly, we had significantly higher number of buds on stems when 40 pounds of nitrogen was applied at the shoot elongation stage. So this doesn't mean that you should apply 40 pounds of nitrogen per acre. It's showing that that's where we saw the most buds on stems. It may not be right for you. It might be right for frozen producers who are trying to grow a lot of stems and a lot of buds as most as possible. In future years, I'm hoping that we can narrow down for a fresh packed operation what rate of nitrogen is ideal. Okay, and lastly, we are continuing our whole field mulching project. This is located in 2 locations. It started in 2021. We're comparing thicknesses of mulch. Half an inch, 1 inch, 1.5 inches, and 2 inches. 2024 was our second prune year. 2025 will be our second crop year. And so leaf nitrogen, something that we've been concerned about with mulching whole fields, is that we're worried that the wood chips are tying up nitrogen, locking it up. And that is not what we see. It's not significant. We do not see any nitrogen tie up in the leaves, the leaf samples. And I think this is because the mulch is applied just to the surface of the soil. It's not incorporated into the soil. If it was incorporated, the microbes would be breaking down the mulch rather than breaking down other parts of the soil and making that available to the wild blueberry. Phosphorus, just in hope, we saw significantly lower phosphorus at the 1 inch depth. This is an observation. I think it is probably variation in our sampling because we only saw it at this one location and it's only at the 1 inch depth. If it was a clear trend that was dropping off, I would be pretty concerned. And this is potassium. The nutrients were lower here. Just in Orland, so one of the locations, we saw lower leaf potassium at the 1.5 and 2 inch thickness. So this is certainly something we'll keep an eye on. And that's why it's important to keep studying this and continue to take these samples. Yeah. We haven't put any fertilizer down. No fertilizer, yeah, good question. at some point in the future, we should apply fertilizer on top of mulch to understand how quickly the plants can take it up. So the question was, are you not recommending bark mulch anymore? And yes, I would not recommend bark mulch anymore because it's stringy. Depending on the lumber company or supplier of mulch that you work with, you may have a different definition of bark mulch. And so you just got to communicate with them. But in general, from my experience, when we say bark mulch, we end up with stringy bark, and it gets caught in the rates in whatever harvesting mechanism. But yes, she also has another point that weed seed can come with mulch. So you want to be a real stickler about where your mulch is coming from. And it would be a good idea to see the mulch before it comes to your farm. Yeah, it's pine, white pine. And so we're using softwood wood chips rather than hardwood wood chips. We have an ongoing monitoring site where we're comparing hard versus softwood chips. We haven't seen any change yet in the soil pH between the two. Some people have hardwood wood chips available on their farm or land, and so I wouldn't shy away from using that. But in general, we're getting softwood wood chips because they have a naturally lower naturally low wood pH. And that's what's available. But for a large field, that you're going to have to be applying softwood chips. So I'm running out of time. The last slide is that I wanted to show you soil temperature at these two sites under the mulch. So you can see that we had significantly lower soil temperature in the 2-inch compared to the control 0.5 and 1 inch. And soil temperature is an important factor in our world today because a lower soil temperature could moderate stress that occurs during the summer during really hot temperatures. It could also cause the blueberries to emerge a little bit later where you have 2 inches of mulch. So the soil is cooler there by about 2 degrees. Summertime, right? Just in the summer. We didn't really look at spring temperature. I'd have to look to see when our date started, but we started collecting in May. Yeah. So this is an NRCS practice that, well, it has been paying for mulching. It's been a wonderful partnership with NRCS, and we will continue to work with them as long as we can. I am aware that some people are worried about funding from NRCS, and I know as much as you do, it's very difficult, and we hope it becomes resolved. You can call your representatives. I called the other day on your behalf, and I was told that you can call the Bangor office and get on the list. I don't know what that list means. So you're getting at how frequently should I be applying more wood chips? And we don't know the answer to that yet. The challenge is that this we've had wet seasons, and so there's no rain exclusion here. It's just in the field, and so I would have loved to be able to say, okay, these are our soil moistures as the mulch is decomposing, our soil moisture is going down or going up. I don't have the answer to that. But I can say that the wood chips are very settled into the blueberry environment, and burning over them is no problem. Mowing over them is no problem. They have reduced leaf spot disease right when they're applied. And then, so in the first year, we saw a very clear decrease in leaf spot disease. Now in the third year, that's starting to wear off. So the leaf spots started to climb back up. In the second year, we saw more mummyberry, significantly more mummyberry, where there was 2 inches of mulch. which was a very wet season. And it's possible that the 2 inches of mulch was, that is thick, and that could be holding more moisture. But we're gonna continue to look at that, and Shaunna may be able to comment on that this afternoon. So those are some of our other observations. Does that answer your question? Dave, go ahead.
How big are wood chips? Because the larger ones last longer, that's
Yeah.
the problem with sawdust is so it breaks down, it will cause a problem with the larger chips.
Yeah, so right, sawdust and bark and shavings is another particle size you can get. They can all blow away. We see much more sawdust blow away than wood chips. The wood chips, they're variable sizes, but generally they're like this big. Some are bigger, some are smaller. 50 cents. Yeah, you don't want big pieces, because they'll take a lot longer to break down. And I think in the first year of this study, we saw higher soil moisture with more mulch applied. And that was because of it was blocking evapotranspiration or holding the moisture in the soil. And we really need to study more of it. I'm looking at Rachel because she knows so much more about it. Like we need to do more on the connection between mulch and soil moisture. There are more readings we can take for sure. This started out as a small project relatively, and there's so much interest that I think it warrants a bigger. Yeah, so the question was, could over time the nutrients that are brought into the soil from decomposing wood chips increase your weed problem? I don't think so. I don't think mulch is bringing enough nutrients to cause a weed problem. I think the weed problem that can occur is really weed seed coming with the material. So 2 comments. One, Tom said that it's very hard to apply mulch evenly across a field. Absolutely. You can't put on, the difference between an inch and an inch and a half is crazy. It's really for us scientifically to know, like, what's the ballpark that we should be aiming for. And so right now, I think NRCS still recommends 2 inches. They went down to 1.5, which is great, because then the goal is just a little bit lower. And you don't, because I just don't want you to end up with too thick a layer. And so I really am glad that they lowered it to 1.5 inches. For our pest management, we don't know enough yet. This is only the 3rd year of the study. I'm hesitant to say, yeah, apply 2 inches across your whole field. I think it's much safer to do 1 to 1.5, however you're able to get it across your field. And then Paul was saying it's easier to pull weeds when you have mulched the field, probably because the soil moisture is higher and you can just pull them up. Yeah, so NRCS has a spot mulching practice that's to fill in bare spots. And that the thickness is 2 inches to 4 inches, I believe. And that's great. That should be thicker mulch because there typically are not blueberries in that space yet. The goal with that is to allow blueberries to move into that space and create a more moist environment for them to move into. And they really do. They move in quickly and you can see them sprout up. And you can also see them sprout up on the edge of a blueberry patch that has been mulched. So that works very well. Whole field mulching is a separate practice that is more new or coming back around again. I wanted to just show you this table. I went through it really quickly, but these are the payment rates for NRCS. You can afford to buy the mulch and buy a manure spreader. The manure spreader that works well is a side shoot manure spreader. And Peter Jordan is back if you have questions about that. He is kind of our resident expert of the H&S side shooting manure spreader. bark sprinter. Mill Creek bark sprinter.
You did it with an old John Deere.
Yeah. So NRCS has their own goals, and as an organization, they're really trying to reduce erosion and conserve soil. And that's awesome. There are additional benefits from my perspective for wild blueberry health and production. So, yeah, we kind of add on. Yeah, so if you couldn't hear that, Hancock County is really ahead of the mulching phenomenon. And so you should drive around Hancock County and see these fields that were land level. It's very common for a field to be land leveled and then mulched. Land leveling really disturbs the soil, and in the long run, it will recover, but it will recover faster if you mulch it afterward, like absolutely. And so a lot of fields now that are whole field mulching are fields that have been recently land leveled or de-rocked. The rocks are coming out to make it more manageable to farm with mechanized equipment. How to apply mulch? Yeah, so maybe you couldn't hear us, but we were talking about manure spreaders, and that's really the most effective way to do it. It's either a manure spreader or a bark spreader. In this project, we did compare manure spreader application across a large space compared to a tractor bucket dumping a pile and people raking it on the ground, which is just a lot of labor, not efficient. I know some of you in the room have done that. It's tough. It's tough. I would recommend the manure spreader or a type of spreader. And the NRCS payment does allow you to pay for that. So it's a good choice. Something that has happened in Hancock County down east is that there is a farmer who has purchased a manure spreader and he's willing to do some custom applications. That's Peter Jordan and Beck. And so if you're interested in that, talk to him. And that may be, if there are people calling in from different parts of maybe Massachusetts or Southern Maine or Canada, maybe that's an option in your area. You could buy the manure spreader and help apply it to other fields. Yeah, a live bed manure spreader. 50 grand. I did we actually, Jordan put together this slide and he called sorry. Oh, it's overheating. Okay, well, it costs about $45,000, they say, from our calls most recently for a side shooter capacity 1,500 gallons. That doesn't make sense. Load capacity 13 yards. And it goes up, you can buy a manure spreader that's 66,000, 74,000 with larger capacity. And they're really only available in Maine on site at the Fairfield equipment dealer.
This morning about effects of climate change in lobstering. If you are making your living in close collaboration with the natural world, if you are growing a farm product, you have experienced and have probably been thinking carefully about how to deal with changing conditions. And the thing that I want to just kind of draw our attention to is that sometimes it's not increasing temperature that is really hurtful for farm business, right? It's not just the changes in precipitation, but it's these things combined and it's the wild swings that we're seeing. So Lily was talking a little bit earlier about how late leaf drop is getting. I think in everybody's experience, we're seeing more long stretches of dry periods in the fall, especially heavier rains in the spring. So all of these things combined and maybe different aspects of our management really challenging. But even more than that, sorry, I did what I said I was going to do. I'm wandering around. Even more than that, it's that any given year, not really quite sure what the challenges would be, and we have to prepare for all of it. And that's an expensive endeavor, and it's a decision-making conundrum, right? Because you have to figure out where you're gonna invest your time and money. So that's really what is driving this research that I'm going to talk to you about today. The goal is better understanding how climate change is going to affect wild blueberry plants so that we can make management changes that will make production more consistent year to year, because we know that has a big effect on your ability to sell your crop, right? All right, so these are the things that I'm going to go over. This is an in-progress research study. It's got a lot of different moving parts and pieces, and I am going to try and do justice to most of them, but I'm certainly happy to field any questions, interrupt me as we go, and we have lots of folks who are collaborators on the project in the room today. So if I can't answer your question, one of them will hopefully be able to. So this is the overall goal of the project. I should explain that the project is taking place on a center that we have developed in Old Town on the University of Maine Ag Experiment Station Witter Farm. We turned an old cornfield into an artificial blueberry barren, more or less, and I'm going to show you some pictures as we go so you can see how we did it. The development of that site was really thanks to the generous support of Wyman's, and the research that I'm going to be talking to you about today is funded through a USDA NIFA grant, a competitive grant through the Sustainable Agro-Ecosystem Program, and we're really grateful for NIFA's support to do this. The first goal that we are going to look at in this project is, like I insinuated with my maybe a little bit rambling intro, is we really want to know how wild blueberry plants are responding to changing temperature, changing precipitation, and the interaction between the two. I think the thing that makes this such an exciting project to me is that we're trying to look at it from a lot of different angles. So what are the pollinator responses? Thank you, Phil Fanning. What are the underground soil biota responses? Thank you, Shaunna Annis. What are the crop physiology measures that we're looking at? John Zhang, who many of you know, is our collaborating physiologist. And then overall, how are we looking at weed pressure and yield and fruit quality? So all of these measures are things that we're trying to collect and understand, not just how they exist in isolation, but how they interact with one another. Because we all know we don't grow crops in a vacuum. The next phase of the project, which I hope will be useful to the industry kind of at large, is that we're going to be taking that information as well as a lot of data from the literature and all the research that's been done on wild blueberry crop development over the last 30 to 40 years and putting it into a computer model that we can then alter precipitation cues and temperature cues according to the forecasts that have been developed to look at end of century and mid-century climate change conditions. And when we do that, and when we are able to make it spatially explicit, we'll be mapping it. What it'll show us is where in the state of Maine are conditions going to be more challenging to manage, and where are they going to perhaps be a little less challenging. The models that we're working with can get down to a 30 meter resolution, I think. Yeah, 30 meter resolution. So it's pretty fine grained. And we're using some climate models from the CMIP6 package, which, if you know about climate modeling, is kind of the most current package. That hopefully will be completed by next year, and so come back next year, and I'll have some maps to show you. The last section of the project is being led by Dr. Jonathan Malacarney, who's an agricultural economist with the university. And he is taking a irrigation cost guide that was produced by Dalton in, I think, 2001, basically looking at the return on investment for different irrigation practices in wild blueberries. He's updating it with the more current costs. We're adding different types of irrigation to the analysis, which I'll talk about in a minute. And then we're adding climate change projections into that so that people can start to see whether or not it makes sense to financially invest in a lot of these different irrigation systems, knowing that some people already have made investments, others have not, but really kind of needing to see the dollars and cents of it. And I think that will feed very nicely into some of the irrigation work that Eric and crew are doing in partnership with NRCS, and I'm really excited to be a part of that project. You should go hear Eric's talk later today to learn more. Yes. What is the what? Aha. Ecosystem services. God, that is such academic jargon, isn't it? Okay, so an ecosystem service is basically anything that the environment provides to humans that we can use. And it can be as kind of cut and dry as food provisioning, which is like how many berries can you harvest off of this plant? But it also includes the water filtration potential of perennial crops. It includes the spiritual and cultural significance of a production system or a land management strategy. So ecosystem services is kind of a big term to collect everything that this system does for humanity. Good. It's a great question. Okay. All right, here you go. Perfect lead-in. It's like you're psychic. So these are the ecosystem services that the field portion are particularly going to be looking at. So we're looking at food provisioning. That's how well your plant is yielding. Carbon sequestration and storage. Right now we're looking at just the plant matter, but perhaps Ollie Bello, who is a PhD student working on our project, we might be able to broaden that out into soil carbon as well. Looking at pollination and agroecological diversity. I'll talk for a second in a minute about that part of the study, and then nutrient cycling and water regulation. This is what our site looks like in different stages of development. So what you can see is to do this constructed blueberry barren, we dug 2 feet down into these pits, lined it with a impermeable plastic barrier, taped it up, and then filled it with gravel. So we did 2 feet down, 1 foot up. So we've got these mounds, which we then installed wild blueberry sod on top of, and then mulched really heavily around it to help with establishment, keeping the sod from drying out. We then installed hoops above them and covered those hoops, and those are our rainfall exclusion areas. So what this allows us to do is control individual plants that are smaller, obviously, than the plants that most of you have out in the field, and also limit the amount of rainfall that gets down to them. So then we come in and spray the rainfall according to a calendar that we've developed with the help of the state climatologist, Shaun. And then we have the task of manipulating the temperature. So I'm sure if you've come to this talk before, if you've gone to the wild blueberry field days that Lily's team hosts up in Jonesboro, you've heard John Zhang talk about these plexiglass open top structures. So these are the same design. A third of them are just the plexiglass, a third of them have the heating coils in the middle, so they're actually actively elevating the temperature. And then a third of the plants are just open with no plexiglass. So we've got 3 temperature treatments and then 3 precipitation calendar treatments. I will also say the experiment is in 2 halves. So in one half, we've got these 6 foot by 6 foot plots with plants just in isolation. And the other half, we've got 12 foot by 12 foot plots that have 4 plants per mound. And the reason that we're doing that is that we have, you know, an educated guess that interaction between plants of different genotypes influences how they do or do not provide ecosystem services or develop and establish all of the measures that we're looking at. We guess that there is a difference. We may have made things a little complicated. So this is our site map. This is a slide Shauna told me to take out because it was too complicated, but I thought rather than take it out completely, I would just break down a little piece of it so you can see the different elements that we're looking at. So this is a little close up. And what you can see, this is just of the 12 by 12 plots. We've got our precipitation treatment. So the first one is wet, which is based on 2023's rainfall patterns. We're taking daily values. You guys all remember 2023, super wet year. We also have Dry, which is based on 2020. I'm sure you also remember 2020, kind of notoriously dry and drought periods. I know you all had frost also that kind of limited production, but the drought was a big factor, I think, in plant health. And then we have the amplification treatment, which is taking the total, it's mimicking the total amount of water that came down in 2023, but mimicking the distribution, the seasonal distribution of 2020. And this is similar to what climate forecasts are saying are likely for the end of the century. So we're more likely to have these kind of long, intense, rainy springs with high, what's the word I'm looking for? When you get a lot of rain in a short period of time, high impact rain events, but then we're also more likely to have late summer droughts. All right, so those are all the water treatments. We're working with several different genotypes, and we're keeping track of the different plants that we harvested, what we're calling our child plants from. So when we harvested the plants to bring to this experiment, we basically took a large plant and cut it into 4 so that we can place different child plants in different scenarios and try and understand to what degree genetics is influencing the results. These are the heating treatments that I mentioned, active, passive, and control. And that leads us to a 2x3x3 factorial design for the study, which is fun. And then even within that plant, because we have so many people who are asking so many different research questions, we have to divide up each plant to make sure that people who are doing destructive sampling aren't interfering with people who are doing non-destructive sampling, et cetera. All right, so we've had 1 year of data collection under our belts. The most visually interesting, I think, thing that I have to share with you is a slide of mycorrhizae in roots. This was done, this is one of your slides actually, right, Alex? Yes, so Alex is another PhD student who's working on our project. She's co-advised by myself and Seanna. And what they are looking at is the association between mycorrhizal fungi and nectar quality, working with Phil to understand how underground populations of Bieber do not affect the food source for pollinators, which I think is fascinating. And if you have questions about that, I most certainly cannot answer them, but I will invite somebody else up to do so. This is really kind of like an update on the research talk more than a share the data talk, so take it for what you will. I will say that there have been some really interesting lessons learned. To my knowledge, this is the first time in Maine that this type of climate simulation study has been done in wild blueberries, and it's certainly a big lift when it comes to figuring out the logistics of it. My experience, I used to be a commercial vegetable farmer, and my experience with research farming versus commercial farming is that you're working on such a much smaller area, but all of the decisions are so finicky, and balancing everybody's needs when you have so many different scientists working together can be interesting. We've also had some issues with our equipment, which we're working on figuring out, and the wildlife. So we are really lucky to have a deer fence going all around our plot, which is relevant for those of you who were in the deer control session earlier today. But we still have smaller mammals that are enjoying messing with our work. So just to give you a quick update on sorry, let me check the time. Okay. Just to give you a quick update on the modeling effort, which I think is super interesting and has been making really great progress. Stephanie Miller is a postdoc working with Brian McGill, who's really leading this effort. They're basically taking this model that was built for soybeans and changing all of the parameters to fit a Ericaceae plant. And in the process, I have to say, the most interesting thing is when Stephanie called, to me at least, is when Stephanie calls a meeting of all the researchers who run the project and says, okay, so what is the growing degree day Q for leaf out? And everyone sits there and goes, I don't know. Well, how do I know what temperature I should put into the model for leaf drop? Like, what is the Q for that? Y'all shrug again. So through this process of developing the model, yes, we're making a lot of assumptions, but I think it's also raising a lot of questions about how little we actually know about the crop development phases. And I think it's kind of providing fodder for years of investigation to come. All right. The economics component that I mentioned, we're focusing on updating the past economic analysis and looking at what the financial and non-financial barriers are to practices like irrigation. So once we develop the guide or the updated version of the guide, I imagine that is going to be the piece that is probably most useful for the people in this room. There'll be a lot of more current figures and numbers about the cost of these products, although some things are much more difficult to price out than others, for example, pumps. But we all know that we don't make decisions just based on finances. So with your gracious agreement, we hope that we'll be able to cycle back around when we have the guide developed and have some conversations with you all, people who know the ins and outs of these systems better than anyone. In quick overview, the table on the left are the irrigation systems that were previously included in the Dalton guide: large gun, real gun, small sprinkler, and both permanent and movable sets. We're adding real gun with lay flat and small sprinkler with lay flat into the analysis. However, I think it's also important to recognize that it doesn't really matter what your irrigation is if you don't have a good source of water. And that is the thing that we're not addressing in this economic analysis. I think I personally have an interest in water source development and would love to talk to people more about that, but that's not really kind of included in this portion of the work. All right, so I'm almost at the end of my time. This is where we're headed. Like I said, 1 year down, 3 more years of the field experiment to go. Obviously, half of our experiment is in crop year, half is in vegetative growth year. So we're flip-flopping back and forth, and we want 4 years of data to be able to have 2 years of information. Does that make sense? Crop model should be done by this summer. Economics of irrigation, hopefully by next fall. And I'm just going to close before I take any questions by acknowledging Wyman's has been a super important supporter of this work, but the USDA has really made it possible, both through the competitive grant process and because through the Hatch Act, so many of our faculty members are supported through formula funds. I think what we are seeing right now in the workforce of our federal colleagues is both it's distressing on many, many levels, but I just want to draw a very clear and bright line between reduction in the federal workforce and the type of work that we are trying to do. We are not going to be able to get at some of these really big, complex problems without the support of NIFA and other partners in the USDA. And what Lily was saying earlier about calling your representatives, kind of showing that you are noticing what's going on, is perhaps the best and maybe only thing that private citizenry can do right now. And I just encourage you all to do it. So with that, I'm happy to answer your questions. Yes. What is lay flat? Oh my God, it's the coolest. Okay, so it's a hose that when water is running through it is inflated, but when you shut the water off, it collapses and you can drive over it and you don't need to worry about, it's not like running over PVC, you're running over aluminum pipe where you might crush it. Yes, it basically replaces piping. Yeah. Well, so that is the question. So in my experience, a lot of the studies that are out there that are field-based in wild blueberry responses to environmental conditions make a lot of conclusions and then end with the caveat, oh, but genetics. Oh, but genetic variability. And you all are growing one of the most amazing crops in the world that you have this amount of genetic variability in a single field. It's really quite extraordinary and beautiful. But we don't have a lot of clarity about how those genetics do or do not actually influence a plant's ability to withstand extreme conditions. Yeah. different varieties from different countries. In my experience, and maybe somebody else wants to weigh in, when we're looking at wild blueberries, we're looking at the endemic plants that are in the area. So we selected, I think it was 40 plants from the Wyman field in Cherry Field. Exactly, yes. So there were 40 clones. We then divided each subsection of the clone that we harvested into 4. So that's 4 different, and we tested them. We did run some genetic analysis and confirmed that they are indeed genetically distinct individuals. So, I mean, wild blueberry doesn't have a breeding program like other crops, so it's not like we're in control of the genetics, but we are trying to document the ones that are in the field. There's also, I think, a really good question of, is a phenotype a genotype? So when we were selecting the plants in the field, we were looking for physical differences, whether there was a slightly different leaf color, the stem color, the number of branches in the same management area, things that might cue us to think that this is kind of a separate individual plant. Yeah. We tried to do random selection. I was actually not on the ground for the selection component of it, but our partners at Wyman's, you might know Travis Dillard, was a big part of that harvesting effort. And my understanding is they were looking for variety within the same growing area. So there were 2 fields that we collected from. But yeah, it's a good question.
So yeah, you can contact MOFGA to get a sense of what is prohibited and what is allowed. We have to follow the national list of allowed and or prohibited substances, which is published as part of the Organic Food Productions Act, which is the federal regulations that we certify all operations to. So that's the big thing, the 3-year transition period. I'm also here to speak to the top program in a little sense. That's the Transition to Organic Partnership Program. So you can participate in that either as a mentor, if you have transitioned and have experience with that, or as a mentee. If you're looking to transition, you can work with a mentor. So the important thing to keep in mind with TOP is that it's a funded program, meaning that there is money available for people to transition. There's also money available for mentors. So I believe it's $3,000 per mentee per season if you are a mentor. But if you're a mentee and if you're looking to transition, there is a program that has been funded with up to $70 million from the USDA through the Organic Transition Initiative, okay, under the EQIP program. And that's to aid new organic farmers or people looking to transition to organic on non-organic land. Okay, so existing organic producers are also eligible to apply if you're looking to transition non-organic land to organic. So you don't have to be uncertified to apply. You can be certified already and still qualify for the TOP program. The monies are administered through the NRCS, so that you need to approach your Maine NRCS field office to access the monies. Okay, the payment contract is 1 to 3 years with yearly payments on a per acre basis. All your activities related to transitioning have to comply with the organic standards, so you'll be working with your NRCS agent to make sure you follow the rules. And the payment cap for a multi-year contract is the same as normal EQIP programs, which is $450,000. Okay. So to apply, again, you need to go through the NRCS, your Maine NRCS office, and you can apply for a couple different programs. The one I'm going to be speaking to mostly here is called the Conservation Practice Standard 823. Okay, there's another program that you can apply for that allows you to hire a transition service provider. That's a separate program, but the 823 program is the money is given to you and you work with the NRCS to make sure you comply with transition to organic. Payments will be up to 90% of costs if you meet all the criteria. And there are a lot of criteria for eligibility. If you don't meet all of them, your cost share will be at least 75% of costs. Okay. The deadline for application for fiscal year 2026 through the NRCS is February 21st, so it's around the corner. That's for the Organic Transition Initiative, I should say. And then August 22nd is the deadline for the CSP program, which is what funds the top, the transition to organic land. August 22nd. Yeah. Right, thank you. Yes, so the monies from NRCS acknowledge the loss of income from a reduced yield and otherwise if you're transitioning. So basically all the activities you're doing and the inputs you use, that's a really important component that I can speak to a little bit, during the transitional period must meet the NOP, that's the National Organic Program, regulations and standards in order for those monies to be distributed. So there will be some sort, yes. So if you're interested in the top program and receiving the funds or offsetting the lower yields, then you'd reach out to NRCS. If you're interested in, if you have land that's eligible for certification right now, you could reach out to MOFGA, okay? MOFGAcertification.org is where you would go. And we could work with you to get you certified pre-harvest. Okay, that's an important component. We cannot retroactively certify already harvested berries. So you can't have a huge crop and say, oh, you know, that land was actually eligible for certification, and then reach out to us and say, hey, I have thousands of pounds of berries. Can I sell them as organic? Can you work with me to do that? We can't do that. It has to be pre-harvest certification. So we have a certification deadline of June 21st. If you are looking to get certified this year. Yep. And then just one other question a lot of people have around certification is paperwork. Okay, so it is additional paperwork. It's not a paper-free process, unfortunately. But at MOFGA certification, we're here to help you. We have a lot of templates that you can use to facilitate the paperwork process. But the most important things are to document your practices. So you're going to be filling out a plan every year, or just renewing the plan with the same information. And then you're going to also be telling us all the inputs that you're using on the land that you claim is certified to organic standards. So we need to know any fertilizers, any pesticides, otherwise that you're using, as well as any sanitation materials you're using on your wash pack line. And if you're also looking to make value-added products with your blueberries, that's going to be an additional step, in additional what we refer to as a scope in the organic certification world. So you would become not only a blueberry producer that's certified, but you would also become, for example, a handler processor of frozen blueberries. Or if you want to make jam or juice or whatever it might be, that is a separate process that requires certification and additional paperwork. But we're here to help and answer questions as well.
I think with a single crop blueberries getting certified organic, pretty straightforward. I think when you're, somebody doing like 40 different crops, it gets hard, but it's definitely not bad. And it gets easier once you, like the first time you might have some questions, but after a few years, it's really simple and straightforward. So.
Yeah, the first year was where there was a lot to do, but then any other year, a lot of your farm plan, what the paper is about, doesn't change much. And really, the annual updates are just checking that what you've said in the past is still what you're doing, and then your field updates, like what you did last year in this field, So as Mark said, I found it really just making me a better record keeper, a better farmer, because of what's required, and what's required isn't burdensome in a sense, like it's not worth it. To me, it's worth getting certified for the value of that in my marketplace and to my customers. And I would just reiterate that MOFGA is one certification agency, but there are other certifications. Recent Wild Blueberry Commission meeting, someone asked if there was something besides MOFGA. One of the nearer other agencies is Bay State, Massachusetts, right?
When I certified
depends on my time allocation. I need to certify it until crop year, which is 3 years or 36 months from the last prohibited chemical application. So typically I'll wait, just skip the first 2 years and then certify it on that 3rd year. But
meanwhile, we're working those fields that are transitioning.
yeah,
But just, it's not in our program until we're actually ready to harvest.
yeah. If the field's in your plan, the only added burden, if you think of it as such, is you'll have to schlep your inspector around to that field. And so if it's not going to be organic for a couple more years, I don't bother with that. I just wait until it's going to be an organic crop, so that I can benefit from having the inspection.
So we've always looked for fields that are better than fields we're already managing. And some of what that meant for us is if a field is and can be, just more efficiently, whether mechanical harvested or even just driving your tractor out on the de-rocked or flat field is a benefit to us. If it's closer to our own home farm, because we do a lot of fresh packing. So when we transition fields, it's because they're either flatter, closer to home, or cleaner because they've been conventionally managed in a more recent time period. So that's some of the things we look for.
I know if you have that advantage of having a clean field, then coming in, and where do you see it moderating off, or do you see it continue to go? Or I guess it depends how you manage it, the inputs and sulfur. And there's a lot of things.
Yeah.
Question.
From my experience, I see fields kind of reach a plateau of organic management to me has meant kind of a plateau of yields and insect and disease pressures. I don't have huge mountains, like huge yields or huge mummy berry disease, and I don't have huge peaks or valleys. It's kind of comes pretty constant. So generally a conventional field yield will be higher, and over 2 or 3 cycles, I'll see that drop certainly. And under organic certification management, I don't fertilize my fields, mostly because of then what you're doing to feeding the weeds. So naturally, conventional yields will be higher because of the fertilizer that's been added, and that will generally settle down. A couple other points I look for though too, when we lease fields, we own 2 of the 7, but we lease 5 from 5 different landowners. So I kind of ask the landowner of a potential field for harvest records and management records. Specifically, I need to know when was the last prohibited substance. And something I look for and has worked each time was that I take over right after a harvest. And typically under conventional management, there is some spraying during the harvest year, like fungicide for mummyberry that spring, maybe an insecticide in July. And so from that July or June spraying, I have 36 months till I can get it certified. I usually then try and take it into a prune cycle. So out of 3 years, the 36 months, I only have 1 harvest, which is transitional, which is not organic, so I have to sell it as conventional. So I try and take advantage of wild blueberries being a 2-year crop. Out of a 3-year wait period, I only have to have 1 conventional or transitional crop.
I don't have a whole lot to add. I thought you were pretty thorough there. Let me see. I mean, most of my fields were not really transition. They were just organic from the beginning, which has a lot of cons, but you can get them certified right away. I am in the process of potentially doing a transition from a field that was managed conventionally last year. So I'm really interested in seeing the difference. And so basically I'm just looking to get harvest records, spray application records, and that's about it.
So we're looking for a field now. It's evolved over time, but we'll only consider fields that are mechanically manageable, that we can mow, that we can harvest with mechanical equipment. And picking also, we want to preserve the option of being able to mechanically rake. Also, we have found over time that small fields surrounded by woods
in villages are not fields we can manage well. Typically, the deer pressure is too high for us. We can't do anything about that. And so we've given up a number of fields that we used to manage that are in around towns like Cherryfield and Harrington, just because deer pressures are so high and we don't have a way to address it. So those are fields that we avoid. We like to we fresh pack, and we like to fresh pack as long as possible. So we like to have fields over a large geographic range, and we try to shoot for fields that are in different, what we think of as climatological areas. So if we have a big field along the ocean, say, and we have a large field that lay inland on the Bering. And so whatever the weather will be that year in terms of drought or rainfall, we're more likely to have fields that we can manage well, based on the distribution of them within likely climatological areas. So here is, for us, weed management means keeping the soil pH at around 4. So we do that by spreading sulfur. There's an argument to be made in having it even lower. We find the low pH weeds are more pernicious than the high pH weeds, so we don't like to go below 4.5. We do a lot of weeding. We either mow or burn traditionally. We try to alternate mowing and burning. We are trying to get away from burning and switching to more field scouting and burning and spot burning areas that are revealed to require it, and generally mowing. We do that because we want to be better with the planet, mostly. There are also cost interests there. Our other way of weeding is we have crews that go out with string trimmers, weed whackers, and top weeds that emerge above the blueberry canopy. Also, we're experimenting with sort of weed elimination in areas. For example, if you have lambkill moving into your field in spots, that will overrun your low pH field in time and greatly reduce your harvest. One way to get at that is just to eradicate it entirely in an area, give up the harvest in that area that you would have otherwise had, so that it doesn't come back and spread. That's something we're experimenting with now. Those are our general weed management approaches.
I mean, you're not really addressing trying to take the landfill out.
We are
done that before.
Yeah, we are by pulling or going back. Let's say if it's an area that's 5 by 5, we'll go back with string trimmers and just keep hammering it until we've exhausted the nutrients in the rhizomes and it won't come back.
You can't do it all by hand.
That's the same, you want to control your pH with sulfur to begin with, and then mowing, flail mowing, burning, we definitely are pushing, I think a lot of people burn a lot more than we do. So we kind of are just seeing how little burning we can get away with for just cost wise and environmental and just more mowing. And we haven't had any real disease issues so far, but and lots of weed whacking, and also, as Mark was saying, in certain areas, if the weed pressure is so bad, where it's just not feasible to string trim, we'll just mow over the top of the blueberry canopy as just sort of a rescue. Yeah, even like there were areas on the harvest year that they were so weedy that, it was either you don't harvest at all or you mow high. And, in June, sort of when the berries are sort of in their like little solid green stage, go right over the top and, harvested it. So that's kind of a, if your field is really bad, but it's possible. We just have like an 11-foot, not a 9-foot finish mower. tractor, and it was okay, because it was really nothing to lose, so.
Yeah.
And I think another really critical part, well, I guess this is kind of getting ahead of myself, but harvesters, you guys have the DH harvester. I think having a DH harvester for organic fields I think that's a biggie too, but I might be getting ahead of myself, so.
Just more on mowing versus burning, something we pay attention to is, and it's been mentioned, the cost. From our farm spreadsheets, it costs about 4 times per acre to burn than it is to mow, and we burn with straw. So that's often a case, like if we don't have enough money in the bank this winter, we're not burning next spring. But also disease cycles and insect cycles. So we transitioned several fields from 2016 to 2018, started mowing them, and after 2 cycles in several of the fields, saw flea beetle explosion and mummyberry. And so we've burned those fields 2 cycles in a row now and have seen that come back down. So our approach is basically mowing for economic reasons, burning for organic control reasons.
Yeah, we make it a summertime adventure.
Yeah, it's like a summer.
We all have great fun. I gotta say, we've never had trouble getting labor. We always have a wait list. We pay really well, and we treat everyone as if they're a member of our family. And we all have a great time. So that's our approach to having blueberry labor. And I gotta say, when we think about hiring people, which our kids now do the hiring, we don't think about hiring labor. We think about who do we want to spend our summer with. That's the first way to think about it to us. And then everything follows from that. So if you're going to find people you would enjoy spending your summer with, and you enjoy your summer working, well, then you're going to end up spending your summer working with people. That's the way it'll turn out for you. And that's the way it's turned out for us. Sometimes we have them from June till September.
Depending on their schedule.
Yeah, yeah. Most of the people who come to our farm are college-age kids. They're not necessarily in college, but they're kids of that age, because kids of that age are often out wanting a summer adventure, and that's how we reach them.
Yeah, similarly, my wife and I advertise primarily online on a couple sites and draw employees from around the country primarily. Similar age bracket, usually in their 20s or 30s, usually with farm experience. Since 2020, we really shrunk our crew down. We now hire about 6 or 8 in addition to my wife and I.
Well, being in far eastern Washington County, I think it's maybe a little slightly easier to find people. We have a crew that comes from Danforth, actually, and they're just kind of people that we knew, and we're really, really fortunate right now to have them. And if we didn't have them, I don't know, I would consider getting foreign workers or perhaps try one of these sites, but we're really happy with our local crew right now. So, yeah. Well, we mostly harvest with DH harvesters, and we kind of just, well, actually, to start before the harvest, we just kind of sent them YouTube videos of harvesting, just to familiarize everybody with the machine. And then, we would get on the machine and just show them, and then mostly just set them on the machine, and kind of, it's a small learning curve, but we just set them out. And I mean, we've had some people where, we're like, you have to slow down. You definitely have to watch people and have clear expectations. And if somebody is, their boxes are too dirty, you have to just
set the expectations clearly right away and, you know, hopefully they'll improve and, yeah, just clear expectations, I think.
DH harvester, is that the little one on the grasshopper?
Yeah,
Okay, yeah, the big thing. What size rate, heads?
I think they only make one now, yeah. We're getting one now too, so you're looking at. I think similar to the other growers here, my wife and I are operators in the field and in the winnower shed, so I train everyone in the field, my wife trains everyone in the winnower shed, and we work alongside them. We are kind of there, and part of our hiring process, kind of the language we use is that we want people to be willing to learn and in cases relearn if we need to. So we're clear that this is how it's done. Like, this is how we do our product. And there's a million ways you can use a hand rake or a DH harvester. And we want to show someone the way we do it and have them do it our way. And so from the hiring process on, that's what kind of our expectation is.
So we get people in about well in advance of the harvest, at least a week. We pay them to be there so we can show them how to do everything and train them. Also, we find, so we're operator. Pardon? Well, right now we pay room and board plus $15 an hour plus a bonus if someone warrants a bonus, and many do. So the other, we have a fresh pack line, we do deliveries, we do all sorts of different things. And what we notice is that some people are better at some things than others. And part of the trick is getting the right person to the things they're good at and want to do. So if you have a person who's just really horrible with equipment and breaks it every time they get near it, it's likely that person is really good at something else. And so that's part of our job, working with people, is figuring out what they're likely to be able to do and to help them do that.
And we work with everybody knows everything that goes on.
Yeah.
They try delivering, they try harvesting, they try the fresh pack line, so that, and we switch it up all the time, so that they don't get barn, or they don't want to go to the field instead of way out there. So we do a lot of switching up and we do a lot of working with everybody. We're out there with them. It's just works out really well that way.
I'd like to make a larger point about transitioning, if I could, about pest management. So what's really important is not to get discouraged and to have patience. And I will give you an example of that. We transitioned a field that was 80 acres, and we managed pH right away, and we had so many weeds and so much red striped fireworm that we couldn't even rake it. So the pH dropped over time. Ground wasps came in, they're predators of red striped fireworm. We didn't have to do anything about it. They all sorted it out themselves. The red striped fireworm disappeared. The weeds mostly disappeared. And 2 cycles in, we had 5,000 pounds an acre, which is a huge amount in an organic field. And we had that because we did what we could on weed management, but we're patient. We didn't do any draconian thing to try to address the pests that came along. We allowed the field to reach a balance. You'll find when you're transitioning in a field that some of them have been more chemically managed intensively than others. And those that have been really intensively managed will tend to have a bigger spring back, as we think of it. There'll be a lot more weeds come on. There'll be a lot more insects come on because they've been so suppressed. And you're just going to have to wait that out. It'll be worth it to wait it out.
Our sort of, we haven't had it. Our sort of trick is just to harvest slightly early and harvest really fast. Like we have several mechanical harvesters just so that we can harvest as fast as possible. Basically, that's our strategy right now. And so far it's been working. Yeah. And turkeys.
Just do it quickly, yes.
Yeah, do it as fast as
Get it
possible.
before they-
Get it done.
Spotted ring Drosophila, like any insect or disease, is gonna have some cycles. And again, we never really, in almost 30 years, experienced complete crop loss. And this past summer, we had our highest yields ever, and it's not because we did anything differently. And so much is out of your control. What we try and do with organic management is just a broad, with the tools of which are limited, salt. We burn and we whack above the fields, there's kind of a limited toolbox, and with that, there's this balance which does seem to plateau in a healthy way. I mean that in a balanced way. We typically try and weed whack just during the prune cycle 3 times above the blueberry canopy. So if you burn or mow in the spring, then I try and get in there in June, July, and September, especially with the more pernicious stuff like saplings or ferns or sweet ferns. We moved from a 5-acre field that was on our property within a couple of years into managing or at least harvesting other people's fields. Just kind of grew slowly, but soon realized the value of having multiple sites. Exactly the point you guys made of the microclimates of each will help ensure. I mean, we literally have all our eggs in one basket, so at least to minimize risks, having several fields. One might get hit with spotted wing Drosophila or deer or a hailstorm, but another, at least on any given year, gives you a better chance, better range of harvest and success. One thing we also, once we started managing other fields, one important thing we found organic management required was to get one whole field into the same cycle, not splitting a single field into a prune and a crop year, primarily to break certain cycles. We test these principles. So in our transitioning of several of our fields, including our own, we combined a split field into a whole management, either in prune or it's either in crop. And we are rock solid on a 2-year cycle. When we're looking at maybe taking on a new field and transitioning or for our farm existing fields, we have no pests. Like we don't have a sprayer, we don't even have a pesticide like applicator's license. That's just our choice. So we manage pests through this balance. And again, if we see an outbreak of flea beetles in particular, that's something we can control by burning. So, again, the limited toolbox is, well, we can burn.
As much sulfur as you can afford,
Yeah.
like before you do anything, it's like get your
that
pH
hit,
right.
yeah.